All right, let's get started here. You guys should be able to hear me. I think everything's fine on all this stuff. So, what we're doing today, we're continuing kind of this series that we've been running through where we're working on getting you guys the skills to get into Linux. I'm trying to get my stuff set up here. And the last few days, we've just been kind of going through skills that I think that you need and going through labs that you can get those skills, talking about different ways that you can do that. That's what's kind of going on the top right of the screen there. In the bottom right of the screen, right by me there, you can type in !answer if you want to send stuff into our lab environment and see what commands do and all that good stuff. That should all be set up and running. The only thing then that I need to do is keep going with the labs that we were working on. So let me pull up one other thing. So I got our little chat here. Yep, should have our chat there. Yeah, you just do something like !answer and then put in whatever command you want to run in Linux. But we are up to lab, I believe this is lab 10 now. It's not exactly 10, it's just the way our numbering ended up working. So I'm going to link that to you guys that want to do this with me. The way our labs work is they're up in Killer Coda. We do have labs that we do in the Prolog environment, but that's not necessarily, not everybody needs access to that. Killer Coda is a free site, so I like to give you guys the opportunity to do the labs with us there. So let's go read about what this one is. And what we're doing here is, this one says you are a new systems administrator at a company. You need to better understand the software that is installed on the system. You also need to better understand how to install software and where that software is coming from. All right. So that's all, I think, all useful, right? All useful stuff to understand as a user or whatever, or even as an admin. So you decide to start out here by looking at a server to see what software package information you can discover. And often, early on in your career, you're going to find yourself just at some base command line like this, right? You're going to be doing something to some server and trying to figure out what's going on, right? At the end of the day, we go into servers, we jump in via SSH or console connections or whatever we're doing, and we gain access and start getting information, right, back and forth, sending information into the site. So the first thing we're going to do is we're going to list all the packages on the system. So Ubuntu uses dpkg, right? And with a -L, it'll show us all kinds of information about if the system's if something's installed and what version. So this is the package manager kind of software repository list, right? This has everything about it. This may be something that we would produce if we were doing contracting or government work. We might produce something like this as what we call a SBOM, or a software bill of materials for, whatever customer. And mainly, they want to know what's there and what applications we're using and that kind of stuff, because we need to know that for security and vulnerability reasons, right? We need to know that for system baselines too, but also for system security and those kind of things as well. So anyway, so we get on here and we do this command, right, dpkg-l, and that's okay, but I don't really want to be in the business as an admin or engineer. I don't really want to be in the business of counting these up like this and going up and down. That's a bit much, right? This is, I think, a bit much in general. So what I might do is hit Q to exit that, and then I might come over here and say, well, how many packages do we have? Well, the system will count them for us. So we do a dpkg-l, and that will give us that output, and it'll capture it with the pipe command, right? Pipe is shift and the key above your enter key. And then we feed that into word count by lines, and you might have noticed there were 5 headers on there. So we have about 813 packages on the system. Now at that point, if it's 813 or 818, we're kind of in like a I don't want to say like it's kind of a rounding error at that point, right? How's it going, Sandeep, over on the YouTube side, and Abacor? Hopefully this stuff's useful to you. Lucky said, find for executable. I mean, I guess you can find all your executables that way. That won't show you what packages are installed, though, and definitely won't show you version numbers. Plus R said, I just installed a 3 terabyte hard drive on my home security server. Is it cooked to also use as a file hoarding swap space for SCP and transfer? Plus, it depends what you're doing. I mean, I don't do I mean, I guess I can give advice out here if you guys want. But what I would tell you to do is monitor it. The best answer anybody can tell you about something like that, like I just installed this extra space and now I want to see how it's being used, is make sure your monitors are in place. Make sure that you're seeing, like if we were back here, make sure that you're seeing the things that you want to see. And what I would want to know on that server is, one, how full is it getting? So what's our, what's our usage? Because maybe you get up to like 75% of it and then you don't have any more storage to put into it and you're good, right? So the term cooked, right? You're probably fine. But then the next thing you need to know, after you know your usage, right? Usage is only one part of storage. The other is I/O. What is the disk access times? What are the amounts of time that are spent looking for things on the disk, right? If you're using an actual spinning platter hard drive, which I know they're slowly going away, you want to be looking for I/O into that. Your commands for that are, I believe I have IOstat on here. You want to use IOstat with specifically the -D, right? And then now you can see how your block devices are being read. You can look at specific things with that. You want to use your tool SAR. SAR will show you I/O into the system. And yeah, really, I mean, at this point, once you've got it all installed and up and running, the next thing to do is start monitoring it, right? This is true of all systems. We prepare, we plan, we design, we implement, we operate, and then we optimize. Operations is getting it running, and optimization is what's going on with the system and where are our bottlenecks. Because see, now you'll have decisions to make in the future. Do I add another hard drive because I'm running out of space? Do I then take that hard drive and move the data off and split the way that the raid's occurring so that I have better I/O? Because different RAID and different what we call access patterns of disk are going to improve that, right? And I don't really teach it much on stream, but I'm heavily involved with back-end storage area networking as well. So we do look at all of those things when we're organizing. But the first rule always is get your monitoring up, because until you have monitoring, we're literally just guessing. So that's the main thing I would say there. Hey, Robdom, how's it going? And Luck said, made a centralized client-server system where the clients are Debian systems and the server lists are clients with all the packages, query CV, vulnerabilities with CVSS score, and generate support. Nice. Yeah, Lucky, you're in the same realm as like some of these paid-for services like Tenable, or Tenable has Nessus, and then Qualys and these kind of guys. I guess Falcon Strike and Falcon Sensor, which is a CrowdStrike tool. And I would say, hey, that's a good market to be in if you know how to do that stuff. Absolutely work in there. Robdom, I always appreciate when you're hanging out. Hopefully you're not working too hard today because it is a Saturday. Colchis has showed up, so there you go. Plus said you're only recording about 150 kilobytes per second. That shouldn't be a bottleneck if I do more at the same time. Yeah, Plusser, yes. So here's what you do. You've got now, if you're getting about 150 kilobytes per second right now, that's your baseline, right? That's your system operating normal. Now what you start doing is, you load up a video or you load up some storage, because in your initial load, that's going to be a big slowdown, right? Your initial data load. But now you start to look at access patterns of data. And really, like when we start to talk about storage systems, we look at, how much storage do we have and when are we going to run out? Then we're also looking at I/O into the data. Then we start looking at access pattern. This is like the last, not the last layer, but there's more maturity as you get more and more into enterprise stuff, where now we start to talk about how often is the data accessed. And some data, like I used to work with gene panels and gene sequencing for humans, and it was for cancer research. And the data would be really, really important for like the first 3 days. But after 30 days, if it wasn't touched, we could move it to a slower tier of storage, right? So I'm not saying you have to do that in your home lab yet, but what I'm saying is you can start to think about, where are the data residing in my network and where are we going to access that data from, right? That going into the future. Like you said, it was just an Uni project. We built skeleton for the basis, and there's a long way to make it market ready. Yeah, absolutely. But at least you have something to start, right? And Lucky, one of the things I always tell people with a lot of this stuff is, when you're trying to get into the industry, you need that stuff and you need to be able to put it on the resume, because then that gets you into the interview. Then in the interview, you need to be able to talk through it and understand the component pieces of it. Yeah, Lucky, all my videos are on the YouTube side of things. So I have all the Twitch stuff, because Twitch deletes things after 60 days anyways. So I mostly just let Twitch, lock, it just goes away. But then YouTube, I have all my videos ever over there. So yeah. And Robodom's one of my main mods, so he's good for that stuff. And I think that's Mike. Hopefully this stuff's useful to you on the YouTube side. So let's keep going through this, right? We're just looking at stuff. If you guys want to see commands sent into the Linux world, if you type !answer and then your command, it'll drop it over here, right? I can give you guys an example of that if you want. Right, something like that on either side will send it over, and you can do that on Twitch or YouTube. All right, so back to what we're doing here. We were counting up the number of packages on our system. We were counting up the number of packages on our system for fun, and we saw that we have about 813 or so. There's some headers, there's some other stuff. Maybe we just want to kind of know what's going on in our system. In the big scheme of things, if you were to say, hey, Scott, 813 packages, is that a lot or a little, right? Because we always make that joke about, well, is 8 a lot? Well, 8's not a lot if we're talking about, like, times you've driven your car this month, but 8 is a lot if we're talking about times you've been shot this month. That's, you know, the number 8 in itself is neither big nor small, right? It's relative to what we're talking about. Where I'm going with that is 818 packages or 813 packages is a lot for a server. If I wanted a streamlined compute image server that was really leaned down to what we needed, I would not have very much in. In fact, if we go in the home lab here, oh yeah, see ID, you're the root user on that system. There you go. I'm gonna jump over to one other thing real quick to show you guys here. On my Rocky boxes, let's just say I did an RPM QA word count -L. These are the kind of streamlined boxes for our environment. They're 484, and they probably are 484. They're probably that many because I chose to put extra packages on there for our labs. Otherwise, I try to keep my servers down in like the 200 range when I'm doing specific stuff, right? Okay, so how many packages do we have? Yes, we can find that on a system. And I often tell you guys, like we have this other, one of my most popular video series is the Socratic method, where we just ask ourselves, can I do this and can I do that? Can I find all the disk IO for this server? And can I find the number of users that are logged on? And I just ask myself questions, right? And we do that as a group, and we figure out how to do Linux things. We figure out, oh, I really am ready to do admin work if I needed to, right? Well, what I was saying here is, in this world, you know, we can do that. I forget where I was going. Anyways, approximately how many packages do you have? About 813. That's a lot. And can we find all the packages that have something to do with SSL? Can we do that? And we do have that. Malvi did a Ranger check, guys. Ranger has had his last formation, so we can't really do Ranger checks anymore. But we'll pull up the Ranger cam one last time. The Ranger cam pretty much sits on an empty room. Ranger's last day with us was Friday, so that's Ranger cam. I have to disable that, so we can't really do that check anymore. I'll probably go get rid of that right now. Let me see here. I'll do it here in a little bit. Malvi, Ranger passed away on Friday. He had a really hard night on Thursday night, and he was on a tremendous amount of meds for his back and his back legs and stuff, and if we had kept him going with more meds and more stuff, it would have been for us, and that's not, I don't think that's fair for him, and we gave him probably an extra year and a half of you know, after his initial injuries and stuff. So yeah. So Ranger. The only time we see Ranger anymore, we actually saw him once on stream here, was when people follow. He'll pop up sometimes as the little follow message. But yeah, Ranger's met his last formation. So how many packages? So maybe we want to look down at one set of packages, and the question here would be, can I find a specific package? If somebody came up to me and said, hey Scott, do all the Linux servers have this? Well, then I could go say, yeah, we do have all of that, in this case SSL, right? I want to see if we have all the SSL packages or whatever. We can do that. And here's OpenSSL. And we used a -I, which I was talking about the other day. When you use a -I, you ignore case on the search. Sometimes that's not what you want. Sometimes you only want like a capital. Maybe you only want network exactly like this. You do not want a lowercase network. You only want uppercase network because you're looking for some very specific thing. But if I change this and I say grep-I, like I just got 3 output there, right? But now I'm going to change grep-I for network, and I'm going to get, you know, word count -L. Now I got like 23 things. So I saw way more things. And there may be reasons to do that, right, in a system. and that kind of stuff. So yeah. So yeah, half the times it does do all the Linux, and the other half the times it does Ranger. I could make that 100% for Ranger if you guys want when people follow. I got to go find where that is. I don't do a whole lot of that kind of moving around stuff like that live on stream, but half the time when people follow on Twitch, it'll be the do all the Linux, and the other half the time it'll be Ranger. All right. So we found the packages that have SSL in the name. And one of the things to note over here is we have this versioning, right? And I tell you guys, especially early on in your career, you might not know what these versions are. You're like, what the heck is a 2.2.4-1? I don't know what that is. I don't understand what this means. Like, this is too much. One of the things I always tell you guys to go spend some time with and learn is this semver.org. You got to learn your semantic versioning, guys. You got to look at your semantic versioning and how semantic versioning kind of plays into this. So you got a major version, a minor version, and then a patch version typically. And major and minor deal with incompatibility. So if you have a major version change, you will sometimes break things. And this is understood, right? Like, things should not work across major versions. Minor versions typically have a number of versions that you'll step back. Like if you do your CKAD and you work in Kubernetes, you know that API changes are always alerted, and then they still remain around for like 3 more future minor versions, right? And I think we're up on version like 1.3. What are we on right now? Maybe they don't have kubectl on here. Oh, no. Maybe they don't even have, because we're on the one version one. If we were on the other one, we would see, I think we're on like 1.3.1 or 1.3.2, something like that. Yeah, I think semantic versioning is it's one of those engineering skills that branches across if you're a platform or a platform or a network or systems engineer like me, or if you're a software engineer, you have to know these things. These are the ways the industry does it. You may look at that semantic versioning and goes, oh, that's too simple. We could do it better. Maybe, but that's like the way that the industry settled, right? Just like you may look at a container ship and go, containers could be a little more efficient. Yeah, that's probably true, but guess what? Containers in their exact perfect size that they have right now is what the industry uses. So modifying that probably isn't changing for you anytime in your career. You could start it, if you're doing stuff, you can start it. But I'm just saying that the things that are kind of the way they are. It's the same thing with like ISO formats. People, ISO 8601 is like the very common ISO format, and that's probably not going to change in our careers, the time formats that we use, right? So, so suppose you want to know what package installed a certain command. So I've got a command like iostat on iostat-1 on our system. Just do one. And now every 1 second it'll run iostat. But I want to know where that package came from. And I can use dpkg-s to see that iostat, the command here, we'll search for iostat, came from the sysstat tools. Specifically right here, sysstat provided user bin iostat. I can say which iostat to see that is the iostat that we're using, and that maps back to our path in the system of user bin, right? We got user bin / iostat, and that's how we run. Did someone already power off VM with answer? No, it's up. We have there's multiple back-end VMs that can run off of. I could show you guys the script if you want. We actually have it. It's up in the Discord for people that want to take apart what we're doing in that script. So guys, we got a Discord. It's free. Nobody charges you anything in there. But I think it was back here in meeting notes a while back where we were working on what the version of this is, and Colchis was working on it with this one. I think this is the most recent one here. I need to actually get Colchis' version into there so we could play with it, because his does colors and other cool stuff that mine doesn't do. This was from back in May, right? We haven't played with it for a while, but I think I'm just running mine on here right now, my version of the script. But we can look at them if we wanted to, right? Stream answers.orig is mine, and in here I just watch the file, right? This is the file that gets the answers written to it, and then I just watch it to be written to, and then, oh wait, this one isn't mine. This is somebody else's. The one I'm running, I think is... That's not mine. That's not my original one. I don't think my original one's up here anymore. It doesn't matter. The point is, that's how we're getting answers in. So when you guys do exclamation mark answers, that's what's actually happening. Not Fake Amir said, hey Scott, do you have any good practices for making Grafana dashboards? Yeah, so for getting the data to flow, we've got our labs. We're going to be working on those labs today to get the data to flow through. But to make the actual dashboards, what I would tell you to do is steal shamefully. So come over here, right? When I say steal, I mean this. Go to Grafana dashboards. And Grafana has all of their dashboards that people have published up here. I might make this bigger for a second just so you guys can see it a little better. But we might go, yeah, get out of here. Might go in here and say, okay, I'm going to be using a data source of Prometheus. I know that Prometheus is what I like to read out of. Maybe we're using Node Exporter and that's our easy way to do it. So we come in here and we get to Prometheus. Should be right down here somewhere. And maybe there's some other tagging that's weird. So we just grab all of these, right? Come on, get over here. There's all of our Prometheus. And then we come over here and then we find, like, this is Node Exporter full, which Node Exporter is what's feeding out to Prometheus. So what I would tell you to do is find this. This would be my build order of things, not Fake Amirs. I would find what is my audience, who am I showing this to? Is it local admins, us? Is it like a NOC team that's just looking for alerts and stuff? Or is it management that's going to be tracking things? That would be my first question, right? So, you know, if I were to, let me just pull this up real quick. First question. Who are we showing this to? And again, that could be us, admins, engineers, ops, right? Our NOC, they want to see alerts and heads up displays. They want to see like a light go on that something's wrong, like a dashboard light. And then management, they want outages and like usage reports. So that would be my first question. Who are we showing this to, right? And then my next question would be, what are my data sources, right? So that would be this type of thing here. And then I would say, what are my SLOs? SLIs, which are your service level indicators, right? And then that feeds over into our SLOs, which are service level objectives of like, what do I want people to know is a problem? Like, because look, if I'm approaching 75% memory usage in a supercomputer, I don't give a shit. I want my supercomputer to be running at 75%. A supercomputer that's running at like 5% is terrible. Your home system running at 5% while you're doing something is probably good because you want your system to be available for things. But in our world of like big computing and that kind of stuff, I want my systems to be spun up. 75, 80, 85, 90, that's fine. Start getting around like 95%, that's starting to push some limits, right? But anyways, what are those? And then, what are our failure considerations? And then some of you guys know, like there's the SRE books from Google that I really think are a good thing to read about that kind of stuff. But anyway, so Node Exporter full right here. And then this would be, you can go download and copy this. And my point of showing you this is this. It's going to have all kinds of cool visualizations from Node Exporter, and you can rip out every single thing you don't want and only show the one or two things that you do want. So does that kind of make sense for you? My question would, or my answer then would be for, again, not Fake Amir, I'm way back here, but figure out who's going to look at it, figure out what data sources you're getting in, start to build out based on your service level indicators and service level objectives. What is a breach of my things? What are failure considerations? Those kind of things. And then start to build. Never build from a blank page, guys. Building from a blank page is hard. It's very hard to start from nothing. Like starting on a very blank web page, that sounds really terrible. So, okay. So that's that answer to that question, I hope. What else did I miss? Hold on. I'm like way back now. Good old copy and paste. Favorite VM is slimming down public Grafana dashboards. Yeah. VLAN X, I bet that works really good too, because you've got all this noise, all these things that aren't super interesting, and then you strip it down. And a good rule is never show more than 6 graphs. Another rule is if it's like layered, it needs to either be compressed down to less than 20 things shown on any one graph. There's all these rules, right? There's all kinds of things that are rules like that. Do you need to see Prometheus? Prometheus is a time series database that scrapes information, and Prometheus looks like this in my home lab. Hold on. I thought I had Prometheus up at one point, but 191, 181. No. What is it? 188? Is that right? No. Where's Prometheus at? Hold on. I gotta go find him real quick. Hold on. Prometheus 193. I never remember where things are. Oh, maybe I don't need the 80 on there. 90. Is that right? Yeah, 90. So this is Prometheus. It's a time series database that just sits here. But what I can do is I can just do like up, and I can get all the uptime for the systems that it's tracking or whatever. There's all kinds of things that we can do with that. What else did I miss? One challenge I see in remote monitoring is how to identify what data. Yeah, that's fair. Yeah, what I like to do is get as much data in as I can and then parse it down after. And then I worry about the resolution data going forward. And Prometheus has automated things that we can do to minimize chunking and it can minimize the storage long term, but then you've got to consider the resolution you want. Like if you're getting like every 10 seconds, but then out in like 3 months, in the middle of an incident, guys, if an incident happens right now, I would want like to the second resolution of data. But if I was looking back 3 months at like historical data, I would be okay with that being like every 10 minutes, right? I don't need it to be every 30 seconds or every 10 seconds like I would if I was in the middle of an incident. So we think about that kind of stuff. 9100 should be node exporter, right? How does Grafana get data? So Lucky, this is the graph. This is how it happens in my home lab here. We were talking about this stuff yesterday, but this is my monitoring. So in all ways, right? The older way that things used to happen, especially with like tools like Nagios or something like that, is it would do everything. It would gather things and it would scrape the data and it would store it and it would present it and it would do all this other stuff. But the modern way of doing this is to make it very much more modular. And what that means is your ingest components can be anything you want over here. It could be a telegraph tool. It could be Promtail, which is feeding data out. So these are pushing data. But Node Exporter just sits there and squeezes data up so that Prometheus can come and scrape it every 10 seconds or 30 seconds or whatever you want, right? So node export, so your ingest side over here is what's happening on a server and exposing data metrics. However it does it, if it pushes it or if it waits to get scraped, whatever. And then you've got a storage. Your storage is what we call typically time series databases. Time series databases are optimized over time, so you can look at spans of time and spans of stuff, and then also trace of data along servers and all kinds of stuff. I use InfluxDB2 in my environment. I use Loki as a data endpoint for log data, and then Prometheus is how we track long-term metric data in our environment, right? And then Grafana comes in and queries those and does cool little stuff with graphs and stuff. So it's almost like you've just got a building block, or like you've got little Lego blocks, and you're just punching stuff on top of it for either the ingest, the storage, or the presentation in our environment, right? Okay, so anyway, so I'm way back, guys, on chat. I'm way back. So yeah, anyway, so that's that. Let's keep going with the lab, right? I've been talking a lot, but we've got a lot of lab stuff to look at as well. I'll put this over here. Also, if anybody's wondering, on the chat here, when you guys can send in answers and stuff, and they'll chat over here, this is all recorded up here. If I were to, let me stop this. Let me do a new one of these. Make a new logs and app. We keep track of everything in the home lab here. And if I were to change this to like stream answers and get rid of failed, you would see all the times, like when Lucky sent in the Pac-Man -QS and then looks for SSL, all the commands that have ever been put in are also tracked here, just so I have tracking of like what's happening and stuff like that. If it came from Twitch or YouTube, all that kind of stuff like that. All right. So anyway, so there's all that stuff. I track everything, but I'm using that same. This is actually Loki, right? So it's that same monitoring architecture I just showed you guys. It's just doing it from a different perspective. All right. So we're back over here. We're just doing, guys. We're doing super simple commands, and we're just talking to them as we do them. So dpkg is this awesome little tool in Ubuntu that does what our RPM does over on the Red Hat side, right? And it'll tell me how we got iostat onto the system. By the way, if anybody wants to do these labs with me, they're free. I'll link the lab if anybody wants to do it real quick. And there we go. Okay. So then I want to see where PIDstat came from. PIDstat is on our system, and I don't know why that's not showing. Good, PIDstat. So we see PIDstat here, and yeah, so it's coming from systat. So yeah, if I wanted to look for, so like I knew that systat was on our system, and I wanted to know that the tool PIDstat came from it, I could go find that. That's what this is showing here. So we looked for specifically all of systat tools. So systat probably provides a whole bunch of different tools for us. Yeah, look at all of them. And then we searched down for only, does PIDstat come from that? And then maybe I want to use PIDstat for a minute to see what happens with PIDstat. Okay, so every 1 second, because we did it with a 1, it's going to show us all the process IDs and which UID called them, and then what CPU they're actually running against. This would be very useful. Let's say I had a system with 32 CPUs in it, right? And one of my developers, because again, I'm a platform engineer, I'm the system guy. One of my researchers or one of my devs, I deal with a lot of researchers with NOAA and stuff. And they come to me and they say, Scott, I'm sending this tool in, I'm doing it through Slurm, and I'm properly sending it out it's splitting out to 100 nodes. But when it's on those nodes, it's not performant like I expect it to be. I parallelized it so it goes across all the nodes and this and this and this. And I say, okay, let's go take a look. And then we just watch a tool like PIDstat, right? And now PIDstat would only show us what was being run. But what if I just see one CPU? Like these devices that I work with out in the professional world, they're 256 or 512 cores of CPUs in each of them, right? Well, what if I go to that box and I don't see them parallelizing across the CPUs? They've parallelized across boxes like they should, right? Because that's how supercomputers work. You parallelize across all of them. But on each node, they're only running against one CPU. They thought that they wrote it to go across all the CPUs, or all the ones that were available according to Slurm, but they're not. That we're watching the behavior here, and the behavior is that you're not going across all the systems. This is a thing that I often say as an engineer. This is one of my favorite engineering things, right? Is one test is worth 1,000 expert opinions. We could sit here all freaking day and argue. We can go look at code. We can look at how Python has interacted in the past. We can look at how, because Python's a big data science type thing, and right, maybe we go look at RStudio and we're like, well, RStudio's definitely doesn't matter. Let's go look at what's actually happening, and our opinions are irrelevant to all that, if that kind of makes sense. So there's that old saying, like, one test is worth 1,000 expert opinions. There's also an old saying that engineers like to argue. Like, never get in an argument with an engineer, because after a few hours, you'll figure out that they enjoy it. I think they say arguing in engineers like wrestling in the mud with a pig. After a few hours, you realize they're enjoying it. It's true, man. Like, we could sit here and argue all day, or we can go look at what's happening in the actual system. So there's that. Anarchist said, hey, I've been teaching myself Linux since 2009 when my bro gave me a Mac running Ubuntu. I am not understanding anything you do in these labs, unfortunately. However, I would like to. Yeah, well, so Anarchist, the thing I would tell you to do is get in here and start just touching the labs and doing stuff. Because what I'm doing right now is I'm just looking at package manager tools inside of this lab over here on the left. That's all I'm doing. Over here on the right, we just got a bunch of noise. Like, this is just like stuff going on in my home lab and monitors and stuff. Like, this is just fun stuff over here, right? That's normally what all this stuff is. There's a book that teaches you Linux systems admin. By the way, our books are free, guys. Like, these books that are over here, these are free books that the guys put together. They don't cost you anything. You can go download. You can actually go in there and print them to PDF if you wanted to, right on your system, and have a PDF of the book. Now, that being said, We also run a course that's free in our Discord that goes through those books as well. So I think the one book's like 400 something pages or whatever. But anyways, my point in telling you that is this is very attainable for you if you guys want to do this professionally. And if you've been using Linux since 2009, you've got a lot of experience that you just need to figure out how to get, how to get yourself in on an interview probably. So let's go look at, we looked for all these things. We looked at the way that the package manager worked up and down here, and then we go read the manual for it. And maybe we want to find what the default log is. So I do a /log. And it says that maybe the default log is var log dpkg-.log, right? So I hit Q to exit. And maybe I grep-i sysstat from var log dpkg.log. And I don't see when it was installed because maybe it was already installed on this box, right? So I don't see when it was installed. And it's funny, I think I originally wrote this lab when we were still back on Ubuntu 20. And the labs have now moved to 24. And I think sysstat is probably built into it now. So I don't think it shows up like it used to. But that's still really funny to me that's the behavior there. So then we come over here and we've got this tool apt, right, for installing software. And that's going to allow you to install software that we need. So use apt to download the updates that the system needs. And then after we review them all, we're not just going to update them, we're going to review them all. And then we'll go ahead and verify that it updated accordingly, right? So here's our solution. We're starting a new project when we want to run Ansible. And maybe we do a which Ansible in our environment. And we don't have the tool Ansible. Ansible is an awesome tool. It allows us to send data to a bunch of different systems and send in remote commands through like more of a scaffolding of automation as opposed to like the way that we used to do it where we would just SSH over everywhere. And SSHing is fine, but it's got its own limitations and problems with the things that it can do. And Ansible can do a lot more. It can keep variables, it can write reports, it can do all kinds of very powerful things. It can make decisions for us. And we just like it, right? It's good for that. So we're just going to maybe time the install of Ansible on our system. So time apt-y install Ansible, and that'll just answer yes for everything for us. And it'll just install it. And then the question is, how long did it take Ansible to install? And then what dependencies were there? We only told it to install Ansible, but there's a whole bunch of other stuff happening on our system, a whole bunch of requirements and dependencies for Ansible to work. So what are they, right? This is kind of a thing that we can figure out using some of our tools here. As soon as this is done, it should tell us the output, right? The time command is like a little stopwatch around our commands. It just goes like this. It gives us a little stopwatch timer of how long it took for something to happen in our environment. So it's very useful command, especially if you're writing documentation for like some of your junior engineers or something, and you want them to know like, hey, this next part's going to take 12 minutes, so go grab a drink or something. Well, this probably isn't enough for me to write it out for somebody. It's only about a minute. But we got 3 pieces of time. The first one was the real time. That's the wall clock time. We like to call that wall clock. That's real, like, human time that we exist in. Then we had the number of the time that this command was running system calls against the processors right here. That's 35 seconds. And then there were 9 seconds of sys not really doing anything. Sorry, systems calls. So that's 9 seconds of system calls against the system. So there were 44-ish total minutes, total seconds of time. Was that, yeah, 44-ish, maybe almost 45 of time of the 60 seconds that we were running. So 3/4 of the time it was doing stuff, that's okay. The other time it may have been making calls out, like it was downloading stuff and maybe it was validating stuff and whatever it was doing. If you compare that real quick to a command like sleep, we just say like sleep 15. We can sleep for 15 seconds and see what this command does. This command will do with time. It'll show us that the real time was about 15 seconds and the user and the system time will be pretty much nothing. This system literally just sat there for 15 seconds and didn't do anything, right? So time is an awesome command to wrap things in, right? So that you know like how long it took to do something. So how long did it take Ansible to install? About a minute. and we can go look at the apt history and see that when we installed Ansible, here are all these dependencies. Here are all these other things that had to be there for us to get it installed. Yeah, for sure we needed Ansible, right? We need an Ansible tool. But all this other stuff was all just dependencies. Things that help it run better or things that are required, right? And I said, do you see all the packages that you expected to? Yeah, there they are. Now you want to bring the system up to compliance. Maybe you've got a security team telling you, hey, you need to be back in compliance by the end of this month. You've got a normal patching schedule. Maybe this is part of your patching. And what we can do is we can clear all the caches out in our system. So I'm going to just cd in and see that I have 249 megs of caches. And then I'm going to clear out all my caches in this system, all these archived cache things that are there. And I'm going to see that it's now pretty much empty. There's not really anything in it. And I'm going to do an update to go and pull all the metadata from all of the repositories that are configured on our system. But we do not actually download anything from this. We just, we download all the metadata, but we don't download any packages or stage or get ready or anything for patching until we actually are ready to hit the upgrade button. So we can list what's upgradable. And right here we can say, we should be able to say, that there are approximately 185 or so things that want to be updated on this system. There's 185 things found when we go look at the metadata that need some type of update in our system. Okay? That's what we see here. Now, do we know if any of them are super important? Not necessarily right off. We might have to work with our security team for what vulnerabilities are out there and all those kind of things. A lot of times from the Linux and platform perspective, we say, you know what, upgrade it all in our test environment, validate that the system is working correctly, move it forward to our upper environments all the way ready to go to prod, and then when we're ready, we push it into the prod environment with, whatever tools and practices and all that kind of stuff that we have. We have labs that show you guys how to do that in Ansible. But we listed the upgradable. Let's go ahead and look again and see that, yeah, we do need to upgrade some SSH. So we wanted to check for like one specific tool. Maybe we wanted to kick this over to like our security team and say, hey, we are upgrading SSH this week. Remember, you guys were sending us all this crap from SSH, and we wanted to make sure that we were sending over the right stuff back. So we'll do an upgrade on the system. And this is going to take a little while. We did a -y, so it just should automatically take every single thing that we want it to. But let's go ahead and see. Let's watch this happen, because this is good to see this part of this happen. So looks like our whole environment just reset. Almost looks like they dropped us in a different environment here. That's not normal. That's not good. And then maybe we want to remove sysstat. So there's still a cache lock in the background. So this should only go a few times and then it should fail. Should. I think this will fail after a few seconds. But what's happening is DPKG writes a lock so that only one upgrade or transaction like that can be happening. It reset my screen, Robodom. But no, this is still definitely the same server because we've got a lock over here on our front end. We could also probably check. So this is still the same environment. See, it's all our commands. I think what actually happened was the screen reset, the connection reset somehow. I'm not sure. It's their environment, so something happened. Did you hit with hit enter? It might have. I don't think I actually hit anything there. I think it just happened. But if I go and I try to remove sysstat, yeah, we're still getting that cache lock. So now I can do, so we see the process ID. So we could do something like 4760. And we can see what that process is doing, right? This is what that process 4760 is doing in the environment, right? And technically we could sit here and do like a watch on it for a little bit, and the watch would only be interesting if the libraries and the files that we were looking at were changing. If they're all the same, this wouldn't be super interesting. But a watch of LSOF is kind of interesting when you're watching like antivirus and it's opening different files and checking through them and stuff like that. So That's very possibly one that's useful. Also, there's another thing that'll happen is when this process is done, we won't see it in LSOF anymore. So technically, we could sit here and talk, and once that was done, we would know that that process of that update is done. So that's updating the whole system. So that could take like 5 or 10 minutes. So that's possible that that's just going to sit there for a while and do whatever. But yeah. Guys, we have a Discord. You guys are welcome to hang out down there. We're at 4,050 something people right now. We got events going, so there's an event coming up at, it looks like this is 10 o'clock. So this is about an hour and a half. Whatever your time is, it's about an hour and a half from now. We've got the Linux sysadmin course later, so I'm going to be doing the sysadmin course. I actually have to put the chat from today. I want to say we're in unit, what unit are we in? We're in unit, did we do system hardening? I think we're in system hardening today. So I think we're in 13. Yeah. And then we just, we just keep rolling through. Got to get the course done. Also, I need to redeploy. I was talking to Treasure the other day. I need to redeploy our web page. We could do that today here in a little bit too if we want. But mainly we're doing labs right now, right? The labs are in Killer Coda, and we're actually almost done with it. I was just going to let this thing finish. Let this try to let this thing go. It's got to be almost done. Should be almost done. What we're doing. Oh yeah. The Discord is, I think Robodom just put it, but also it's down on the YouTube side. It's in the description of the channel too, I think. But yeah, you guys are definitely welcome. We have a fair amount of people. Sometimes people just hang out and never show up again, and that's fine. The goal of our group is down at the bottom there. We want to get hobbyists and people who enjoy Linux into doing it professionally. So to that point, we try to point you guys towards like what the job is, right? Like, because we can all sit around and play around in Linux all day. That's not hard to do. That's like the easiest thing in the world. But like, why does a company, like, what would it take for us to work in it, and what would it take for us to do consulting in it if we wanted to, right? Not everybody wants to go get a job. Some of you just want to do consulting, which, by the way, I've done consulting work. I own my own business for years. You're now beholden to everybody, right? So you actually end up having more bosses when you're a consultant, but I'll let people figure that one out for themselves. It is freedom, sure, but it's also like a lot of work. So think about where you want to be. For me, I'm perfectly happy with just being the principal engineer I am where I'm at, and then also being a college professor. That's perfect, fine for me. But I mean, everybody's got to figure out their thing. My main thing is like a company wants you for certain reasons, and you need to know a lot of stuff, sure, but also you need to understand how you fit into the company, and that's the main part of our what we're doing around here. And the guys that have been here and worked through this stuff, that's what they'll tell you. Like, that's what we're trying to do. This is, hold on, is it done? Not done. So we'll just keep moving forward in the lab, and then we can go look at some of the stuff that's going on. So we would cd in to etc apt, and in there's a file, there's a directory called sources.list.d. And in there's maybe like a file called Ubuntu sources. And these are the sources that came with your system. So your system came out of the box, right? You got an ISO, or you downloaded a VMDK from somewhere and you're running this. Maybe you're running it in Oracle VirtualBox locally. And you've got an Ubuntu 2404 box, like what we've got here. And as that server came to you, there were a bunch of things built in that were programmed into it for trust. That trust is right here in etc apt sources.list.d and Ubuntu_sources. And down here, this is how we trust things. We have our URL, like our uniform resource indicator, right? Or information, whatever it is. It's like a URL, a uniform resource locator. But this is how we find our archive.ubuntu. Here's the components. So we've got a main, a universe, a restricted, and a multiverse. Those are the components of the repositories. And then we have it signed by some GPG key that has also been installed on our system before we even got a hold of it, right? And that is a GPG key that was downloaded from Ubuntu, and all the packages that are in any of these repositories will be signed by that key. It would be like if you said, "Hey Scott, we're going to go up to the lake house this weekend. We're the red cabin, and here's the key." And I would say, "Okay, we're red cabin, and here's the key." And then maybe also on the key there was like a little a little symbol or something. Maybe, I don't know, we're the lion cabin and we're red. So then when we drive around the lake, I see a few red cabins, and I'm like, that one's got an eagle on it. That one's got some other bullshit. That one's got a lion on it, and here's a little lion symbol on my little thing. And then now I can go get in there. Well, it's the same kind of idea. It's an out-of-band trust that's been given to me that I can believe that those things that I'm downloading and the metadata that's associated with them are signed by the key that I was also given in a different way. It would be like if again, it's exactly like this. If we go to Kali.org, right? We go to Kali, we want to download Kali, we want to be elite Linux hacksaws, right? And I go and I download this installer image, or I download a virtual machine image, right, for my environment. And okay, I'm going to get a VMware so that I can drop it into my systems. And right here is the checksum. So if I were to download this before I ever load it or ever do anything else, I've got this checksum of what this file should be for the... What version is this one? Does it say what version we're on right now? It doesn't say what version we're on. But if we started to download it, we would know what version we're on, right? And then I would be able to prove that. In my home lab, right here, actually, it's right here. So I would then take that checksum, which, by the way, I believe was an MD5 sum, right? Yeah. That's a SHA-256 sum. And if I had a Kali box in here, which I think I got rid of all my Kali boxes, but let's just say it was one of these Rocky boxes, like this Rocky 9. Rocky 9 box right here. Then I would do like a SHA-256 sum for that. It'll take a little bit, like this might take a minute or two to do it. And then as long as those were the same SHA sums, I would know that nobody had changed this between the time that they built it and did the sum on it, gave me the sum, and then when I moved it to my place, there were no problems. So hashing is really awesome to make sure integrity of systems has not changed in between the time it was built and the time it's completed, right? So that's how that works. That's going to take about a minute or two to do, right? And then we'll let that finish, and then we'll go. Let that finish, and then we will go. The sum will always be the same length too, right? It'll always be the same output length, no matter how big the input length is. No matter how much data you give it, hashes always have the same length output. It'll take a little bit of time. These are not going to match anyways because it's not the same file. I just wanted to show you guys that's what we use it for, right? So anyway, so we got that, and it said, do I recognize any of the repositories from our upgrade? Well, yeah, when we were doing our update, we were using main, right? We were using main. We weren't using any of these other ones. You can choose to use other ones, and you can choose to have packages that are not supported, but you always have to make a consideration in the enterprise world. Am I okay with doing something that's unsupported, knowing that I'm not going to be able to call a vendor for it, right? That may be perfectly fine. Like if you're using Ansible or something and you have to install in Red Hat like the extra packages for enterprise Linux, and then you do that, and who gives a shit? That's your tool and whatever. But if you're like using the drivers for some InfiniBand card or NVIDIA, a GPU card or something, and you're using drivers that are unsupported, that's not going to be good. Because if you ever call support, they're going to look at it and go, yeah, I don't know what these are. We don't support these. This is something you baked up yourself, which is another one of those reasons why I tell people in the enterprise world, we don't get to do a whole lot of, we don't get to do a whole lot in the enterprise world of like building our own kernels and compiling our own kernels. And you say, well, why not? Well, you do it all you want in your test environment. You don't run production on it. And you say, well, why? Well, because nobody supports it. And especially in government world, when I do big government systems, they have to have somebody to call. You have to have somebody to go to that's dedicated to engineering on that specific thing, Otherwise, you can't use it in the government. You can't use it in a lot of projects, right? Because the point is, why would we be sitting on something that's unsupported? Why would we be sitting on something that's not going to be, you know, fixed going forward? That's terrible business practice, right? Terrible maintenance type work. So, all right, anyway, see, that thing finished its hash, and I would validate that hash was the same as whichever one I was originally given, right? All right. So I'm curious over here. Still going. Very surprised. I think that thing's one of those ones where it's like sitting there looking for something. But it should have been given all yeses, so it shouldn't be sitting there that long. But it's very possible, right, that we have to just kill it. And we'll probably try to kill it without the -9, because then that'll let it close up nicely. Yeah, closed up fine. So now, by the way, we could go do that other part of this where we were trying to do our apt remove of some tool. All right. So yeah, see, it was trying to sit there and do something stupid. We'll let it fix everything that it wants to real quick, and then we'll go forward. All right, so we've got all that stuff. We got all that. Anyway, so then you can go look at the sources that are there, and then you can add. And in this case, we add a Grafana one. So we write in. We're gonna put in Grafana to there, and then if we go look in there. Here's our Grafana setup. And now if we were to install, if we were trying to download and install Grafana, we wouldn't be able to update Grafana yet, right here, until we did the key. So now we're going and grabbing the key in a separate fashion. Man, our system is going super slow. But we want to apt install Grafana GPG key. Put it down in the correct location that we put inside of the list there. Okay. And then now we might search for Promtail, which is a tool that's only going to exist in that repository. That doesn't exist anywhere else. And oh, we got to do an update. So we got to do an apt update. We'll go get all the metadata information again, and we should see Grafana in this list now. Yeah, our system's going super slow. I wonder if there's something going on with the lab where... Yeah, see, now it's trying to go to Grafana right there. And once it downloads this, then we'll be able to go forward. So, come on, system. Also, these guitars are really dueling in the background over there. So look, it downloaded Grafana stable in release. What, by the way, there's our stable right there. We said to only use stable and main. We don't use any of the other ones. Rodom like watching water boil? Yeah. That music was getting spicy, though. Those guitars were really battling it out. So, also, you guys might notice I don't have my little chair sitting behind me. Normally, I got like a chair. My chair's over there. I got one of those little balls that you can bounce on that is supposed to be pretty good for your core. And I already have a pretty decent core because I'm a wrestler, but like I feel like this is burning like a lot of calories because I'm like sitting here bouncing and like having to keep my weight like up. Yeah, it's like a stability ball, Robodom. Yeah, but it's like it's basically like a stability ball, but it's almost got like a Kevlar on the outside of it. It's kind of fun. So it's got like a shell on it from it was from Amazon. But yeah, I got it because I was like, well, I might as well, while I'm sitting here, I might as well do some extra work, you know, a little bit of extra. Like keeping my core going or whatever. Yeah, Robodom, I could tell in the first 1 hour that I had it, because I used it for an hour the day I got it, my legs were smoked at the end of that, like from like holding me up. Well, no, the thing is I do too, but like I've been using it for like 8 hours a day for like the last 3 days, and it's wild. Like I'm burning a lot of calories. It's kind of funny. Yeah, this is really so. I wonder if they have some kind of like limit on the network now, and like we blew over the top of it. This lab is going way slower than it normally does. So now that it's downloaded, guys, now that it's downloaded this stuff, we can now search for Promtail. And watch what'll happen is It'll give us our, it'll tell us, yeah, hey, I know where Promtail is. I can go install it for you if we needed to. So, Ash Dude, hopefully this stuff's useful to you over on the YouTube side. We are just doing a lab, just working on stuff. I need to do as many labs as we can, right? Show you guys labs and stuff. And then I also need to get a new version of the book out. So I haven't published a new version of the book since earlier this year, but I have updated like nine or 10 labs in the book. So anybody that already has the Prolog lab book, you'll always get all the updates forever. But I'm gonna push a new update and that kind of stuff. Danny said, any strong opinions on Mac OS? I think Mac OS is fine, guys. You'll find like I am very much technology like agnostic as far as like any one version or tool that you use. In the enterprise world, I almost exclusively work on Linux systems, right? Like I get into Linux and I deploy Linux for companies and projects and stuff like that, right? But I do it from Windows. I don't do a lot. I haven't used much Mac in the last probably 10 years, but sometimes from Mac. And I also use it from I also get in from other Linux systems. So I tell people all the time, like, I don't care what tool I use to get into something. Am I any good on Mac OS? Absolutely not. I'm terrible at it. But is it fine to get me to a terminal to do other Linux? It's fine. Yeah. The only things I need on a system are a terminal like this and some type of notepad. As long as I have some type of notepad like this, I don't care. You could drop me in on any environment you wanted. As long as I have like a terminal to get into the system, and then some type of notepad. That's all I really need. And that's not, I mean, that's like not me being cocky. That's just me. Like I know that about myself. I've been doing this stuff long enough. So get rid of those. Those were from yesterday's labs. We're going to be doing Slurm in a little bit, so I'm going to leave Slurm up. But it's almost like the system's falling asleep over here. It's like I am tired. I am tired. Yeah, Robedom, the book on LeanPub, the one for the actual, like, the lab book that's kind of like our journaling book of everything, that's the only thing anybody could pay for around here. That one, I do have an update for that book coming. In fact, I've written it all, but I have to, like, proof it and check it and all that stuff, so I'll be doing that. Oh, that's what it was. Well, it's because I talked too long. All we had to do for the last part of it was to search Promtail, guys. That was my bad. So, look at you learning Linux. You use the tools apt and dpkg to inspect current software in your system. Now, guys, when I do it, I spend all this time talking about stuff. When you guys do the lab, you could blow through it real quick, write down whatever your notes are on, like, you know, hey, that's a new term. I never heard of that. I never thought of that. And then you can go spend time kind of thinking about it. Why can't you update your Kali repository using apt update? Does Kali use apt under the hood? I mean, I guess it is. Yeah, it's probably sudo or you have to make sure. Yeah. So it's probably that, or yeah, make sure that you have the permissions, right? And then if there's an error, look at what the error is. Probably something to do with the repositories. And then update only works first to update, and then you have to do upgrade. Right? Update only update. It's weird, right? In Red Hat, we do yum-y update and just fucking, on the Red Hat side of things, yum or DNF will just update things. Apt, it's a two-step process. Your update only does metadata updates. It doesn't change any packages. And then you can do the list upgradable and see the upgrades. That's back here, right? Where I show that a little bit. Where you can, yeah, list upgradable. And then when you're ready, you say the actual apt-y upgrade. So it's a two-step process in any of the apt type systems, just so you guys know. That's unique. That's, well, when I say, I mean, it's not unique. Other systems do it too, but I'm saying on the Red Hat side of things, I'm just used to just shooting it over the wall, right? I already know what's going to get updated because I've done it in lower environments and I've pushed the lifecycle manager forward, and I know exactly what I'm releasing into my environment. When we're going on just like any old system, we update and then we get the upgradable and then we do yum-y. So that's how apt does things, in case you guys are wondering. I have not used Ubuntu professionally very often though. I'd say I'm like 98% Red Hat or Rocky or Red Hat flavor of Linux, right? I just do Ubuntu because that's what the free labs that we have are. Killer Coda, guys, I think Killer Coda is one of the best things on the web. It's free. Such a good environment. Yeah, I talked way too much in that environment though. So we're going to go to the next lab. So we just did software and package managers. We're going to start doing the next part of this, which is NFS, Apache, setting up tools for monitoring. We're going to start doing like kind of server setup type stuff in our environment, right? And we're going to start looking at that kind of stuff. So we'll get to that here in a second, but we'll probably take a little break real quick. Let me throw my little, you know, it's funny. I don't even have it. I don't even think I ever moved it over here. Let me go to, I don't need that one. Let me go to, I'll just put the hourglass over. Maybe we'll just do this. Boom. All right, let's get a little hourglass up. Let's take a little break real quick. We don't have to work too hard today. Hourglass will tell us, and by the way, you guys can still do answer if you're ready. Next lab. And we'll do like 6-minute break. All right, I'll be back. I'll be back. Go get me a drink. All right, I'm back, but we're still on break. And you guys can still send an answer if you want to send answers into Linux, but you also have the capability of doing !clip, and clip will give a clip of whatever we're working on. Let me just find something real quick in my notes. I have something over here. I know we were working on. I think it's here. We might get to these today, but I thought I had some of these other ones. All right. We got all the book date. So these were all the book updates that we had. We got these all into the book the other day. So we do have to check the book, and then I can get ready to publish one. Maybe I'll publish a book this weekend. That would be really good. But okay, we'll get in. I'm back here, so I can turn my camera back on. Get all set up and ready. I don't really think, like Robodom, I don't think I really bounce on this thing very much. Like, I'm not doing this, but I do kind of move around on it a little bit. And apparently the little creaking of it, because it's got like this sound between the thing, the wife doesn't like that. She sits over here in the other part of my office, and she's like, that's really annoying. And I'm like, well, maybe everything annoys you. I don't know, because she sits in an office with other people. So, but yeah, I don't have any strong opinions on Mac. I think Macs are fine. We'll go in and we'll do NFS, and I won't take as long to talk through it this time, right? Because I was taking my time talking through it. All right, get over here, let that stuff go. I'll stop that, and we'll get ready here in the next 1 minute to go through this lab right here. Yeah, Robodom, I think I move around a lot, but I don't like bounce a lot. Like I move, like I probably move side to side more and kind of like flex and kind of, because I wrestle in the morning, so like my muscles will get all tight if I don't like move. But yeah, I don't think it's that bad. Mirage, can you ping or curl that address? You should be able to ping or curl that address and get a response back. You need to have DNS resolution happening. Yeah. Even though you can ping it. Yeah, that's strange because your name resolution's the next thing. Failed to fetch the repo. Yeah, you should at least be able to curl that thing. I'm trying to think too, like, there's maybe somebody's published like what the default repo looks like, and just got to make sure that you go in and look in Etsy. So it's Etsy apt, and then it's the repo's either right there or it's in the apt.sources.d. It's in one of those directories there, and then you would be able to look at it and make sure that path is what you can curl or hit. So. Yeah, so Colcus, that's what I'm thinking. It's either a resolution thing or it's a configuration in that apt file, right? It's one of those things. Those are the only two places. So, yeah, I mean, those are the only two places unless you had a block in the way, like a firewall or something, which in a home environment, you don't have that. You would have to be mucking deeply with your home environment, and you would know what you had done to stop that. But yeah, no, the only things that would stop you would be, again, like DNS resolution or name resolution, and then the repo itself being changed. Yeah. By the way, Mirage, if you can't get that done, and if we can't help you here, drop whatever you can down in the Discord. Obviously, de-identify. You don't have to put your IP addresses and that kind of stuff in there. But if you do that up in the Discord, somebody will probably help you. And also, if you do it later when I'm doing the Linux, I always do the Linux admin course, and then afterwards we hang out. If you're down there and you want to share your screen, we'll help you through it later too. So I would definitely help you with that. I always tell you guys this. This is, by the way, this is true. I will 100% do all the free troubleshooting you want if I can show it to everybody. Like 100%. Like we'll go sit there and work through something. If I've got time and I'm hanging out, we'll do all that stuff for free. I won't charge you guys nothing. If I'm doing it for your company and it's got to be like offline and you're like, oh, you got to sign a non-disclosure agreement, that's like the wife would kill me if I wasn't charging for that kind of shit. She'd be like, you play around on your computer too much. Okay, I'm using my wife as a scapegoat, but all right, let's talk about this. This is important, right? We're setting up. NFS is a way. It's a network file system. It's a way that we can share resources, specifically disks, across the network. Why might we want to do that? Well, because we want to store things centrally for security reasons. There's good security reasons there around disaster recovery and other stuff. But if you just think of it like this, if everybody in town was required to do their own security, that would not be as good a security, well, at least in like the engineering sense, as if, or everybody was required to store their own stuff. That might not be as efficient as if we had all the storage in one centralized place, and then that system could focus on the storage and the the security of a thing, right? Like we could have big RAID disks and we can have all this other stuff. So centralized network storage is a very common thing that we do. Most of us do it in our home. We push things off to some system, and then that system handles all the backups and all that other kind of stuff like that, right? So yeah, one source of truth, you could think of it like that. You could think of it as just a system that is single purpose. A lot of stuff we do in engineering nowadays is single purpose stuff. We focus on the things that we're good on. We don't do the things that we're bad at, right? So your team has determined in this case that they want to use an NFS share to facilitate file system access across multiple servers from one central location. Maybe you want to be able to push config files there and then grab them. Maybe you want to put all the lab data there from like instruments. This is one I used to use. We would have NFS available, and then the Samba share, we would have Samba open up, and all the devices could push in via Samba, and then the cluster would have access to it, so then we could run against like whatever data had come off of the machines, right? So we're going to deploy an NFS server on node 01, so that's important. We could draw that out in our head if we wanted to. We could pull up Excalidraw and draw on that. We're going to share out the file system /share to any system that can connect to it. And then we're going to verify that the system is being shared out, right? That's what we're going to do. That's our lab. So we SSH over to node 01. We check to see if NFS is there, right? We use that DPKG from our last lab, and we look for NFS. There's nothing NFS related. We happen to know the package. Now you might say, what if I didn't know the package, Scott? Well, you could search for the package, apt search, or you can go look on the internet, or you know whatever tooling you have. Maybe you're talking to a vendor and they're like, well, you need an NFS server. This is our simple NFS server setup for, Ubuntu or something like that. But we happen to know that it's NFS-kernel-server, so we're installing that. We may, if we wanted to, go do the same checks that we just did and see, well, we only said we wanted to install the one thing, the NFS kernel server, but we got this common and this lib NFS ID map. We got all these other tools as dependencies. We can go dig into that, like looking at our package manager and our logs and all that stuff. But suffice it to say, for us, we've got the package on the system now, and we're going to start it. Well, we're going to go see if it's on. We checked it. We see that it's on. We see that it's loaded. It's enabled, so it's going to come up on next reboot, and it's currently active. And then down here, we did an SS, which is going to allow us to hear all the open ports on our system. And we grep for 2049, so we see on IPv4 any, that's the IPv4 any address, we're listening on 2049. And on the IPv6 any, that's the IPv6 any address, 2049. So we're listening. Boom. We've got a functioning listening NFS server that is not exporting anything. So nobody could connect to this because it's not actually sending anything out, right? Yeah, Cole, because the labs are there for you guys. I try to go through them pretty often so people can see them. But also I'm kind of checking them to make sure they work before I republish the book because I want all the labs working. So I always have something else I'm doing as well. But, mainly I like to show you guys these things. So we see the service is running. We see the TCP is open. Good. And we see it's listening. And now we want to make sure that the firewall is not doing anything. Our firewall happens to be off. If we were running the firewall in the system, we would need to enable that port 2049 to be connected through it, but we're fine. We're okay with that for now. Now we're going to make a directory called share, and we're going to use that to share out, and we're going to give the ownership to that to nobody and the group ownership to no group. Those are some defaults that are used for when we want to de-identify things that are being written in. Later on, we would actually take this away and we would use the group ownership, and we would set the GUID bit so that when people write in, they automatically write it as that group ownership, even if they're not in that group. So if some user had permission to write in here, they would still write with the group so that the group still owns all the files in this directory. That's a kind of common trick that we use when we do big shared file systems. The group owner of the share on the server is the one that we set the GUID, it's setting the sticky bits for it, but it causes it to be written as that group ownership as it gets written in, right? So let's go down, look at our VI-etc exports. There's nothing in here. Shift G to go to the bottom, hit O to go to a new line, and we're going to add in sharing it out to anybody. So share is going to be shared to any IP address, and it's going to be read-writable with sync and no subtree check turned on as the defaults. Escape : WQ, right? And then now if we were to just check if it's being shared, it is not being shared. We have to restart the service so that it goes back and rereads the export file. Exports does not get automatically exported. There's no facility to come back through every 5 seconds or something to share things out of here. You must have permissions to restart the service. And then now we are sharing share out to everybody. So anybody that's on this network would be able to, well, anybody that's on any network that could see this can now write into this share, okay? Or into this folder. So we're going to exit back to control plane, and we've set up the server component of this. The server part of this is built. So we've set up an NFS server in share. Now we have to connect to it from another system. So we're going to install the NFS common client on control plane. We're going to mount that share to this location on the /mount. That's not normally where we'd mount it, but just for testing, that's fine. We're going to make it permanent, and we're going to use etcfs tab to do that, all right? So we're going to install the NFS common client over here. And then we're going to mount it just to test. Let this mount. Now when we mount it, we can do a df-h on /mount, and we'll see that it's mounted from over there. If we do a umount on /mount, we'll see that mount is mounted back off of the... So if a file system starts at / and there's anything that's mounted on it, then that mount will take precedence over the file system, right? That's there. But if we remove that mount point, then it goes back to just being in that file system again, right? That's kind of an important thing to understand, because you can hide files on accident. Like, because maybe some process was writing in here and all morning the thing wasn't properly mounted. This has happened to us before. So then you got to move them out, mount it, move them back in, make sure the permissions are right, because you're moving stuff as root. So now you got to fix the permission. It's just, it can be a real mess, guys. Yeah, it's the set GUID thing will definitely, yeah, it'll definitely get you. All right, so let's look at the mounts. We did all that stuff. We're going to make a file in there while it's mounted, and then we're going to unmount it. But unmount is also always umount in Linux. We chose to make it as simple and small as possible. And we're going to make it permanent. So we're going to look at this and we're going to say, Shift-G, do I understand what's going on here? Let's look at this real quick. It's always important to not just copy things, but to kind of look at them. And over here on the left is where we are mounting from. Either the block device by label, or in this case, the NFS share via a resolvable DNS name or IP address. You can put an IP address there if you want to be explicit, but you can't always do that if there's a VIP. If we've got a virtual IP, maybe we're pointing at a DNS name, or we could be pointing at a virtual IP, and that can be owned by different servers over time. There's all kinds of things we do in clustered storage, but for now, we're just pointing it at node 01. Cool. The mount point on the system, on the local system, the type of, over here, we've got the type of file system that we're mounting, so it's NFS. We're going to take defaults, so we'll just take whatever the far side gives us. And then this right here is, do we ever FSCK it? And do we ever back it up? Well, you're never going to do that on network, so there you go. So no FSCK and no backup. And I might have that backwards, but you guys can look that up if you want. But it's FSCKing the file system and backing the file system up, but we don't do that. Again, I might have that backwards. Anyways, now I'm going to show you guys an old admin trick. I do a df-h on mount. It is not mounted. Once I've updated my etcfs tab, I always type a mount-a, because if I do this, right, if I do a mount-a and my df-h is now properly mounted, what I know is when the system comes up, it's going to properly read it and install that. I did not just break my etcfs tab file. If you ever break that file, you are going to have a bad time. You're going to have to go down into like a rescue or like a single user mode as the system comes up. Sometimes it's the rescue shell. You're going to have to go fix that file before your system ever boots properly ever again. Trust me on that. It's a nightmare. One of the things that saves it is when you mount NFS, You can always, instead of the defaults here, you can set it to soft. So soft is one of the options we normally do, and it will continue trying to mount it and let the system keep going. But I'm going to tell you right now, if I had fat fingered something like up here, like if I had messed something up here when I was putting this in, I could have broken my whole system from booting. And that's happened to people before, and there's all that kind of stuff. So anyways, that's an old admin trick. I have it right here. It's our way of validating. Mount-A is a lot like how the system comes up, and is it reading and mounting our system properly? Very important. All right. So anyways, maybe we touch a final check and we come down here and this is done, right? So boom, we built NFS. And in our head, if we were to close our eyes, we could say, okay, I built it over on NFS 01 or Node 01. I built the NFS server. I came to control plane and I mounted it and I made it all work. Now, for fun, I'm going to back out of this lab. We're done with that lab. But we're going to back all the way up one. And we're going to go to the Ansible labs. And I'm going to show you guys how we would do that in Ansible. Once we understand a thing, then we can automate it, right? So let's go find my NFS server and client. All right. So I want you guys, if you could visualize for just a second, just hold it in your head for a second what you just did. I set up a server. I set up a client. The server had some share and some other things that were added as configurations after we built it. And on the client side, there were some things to change, to tweak, to allow it to all communicate. Okay, good. And I think you guys can all understand that. So then we come in here, and it says you deployed an NFS server by hand over in this lab. That's what we just did. Now your team is to deploy the NFS server and client mount points to a bunch of servers. Well, you're not going to go do all that crap by hand that we just did, right? Yeah, that's going to greatly cut into your Netflix time, and that's greatly going to cut into your num-nums and nap time during the day as an engineer, right? So, yes, I just said num-nums. That's going to waste your time, right? I mean, you could be doing so many other fun engineering things if you don't have to do all that stuff. So Colchis, soft and hard are the two settings for how NFS works. If you have a hard wait for an NFS, the system will not continue until that's mounted. And that will absolutely break boot up with certain. So if I am going to start servers up and I don't always know, like let's say the only time this server would ever reboot in a, sometimes this is actually sadly true in older systems, only if the power went out in the whole environment would this ever come up. And it's kind of like a game of like you've got all these sticks and you're trying to pick up all these other and like all these dependencies and stuff. If you don't have soft boot set, you might be booting individual nodes out of like 30 nodes, and that's a nightmare, dude. So just trust me on that. It's terrible. So you use soft to just make it bypass. They'll all just come up and then they'll connect as they can. Yeah. So let's see if we can do this, guys. Let's see if we can do this without the without that other stuff. So verify our root host file and see that you have defined variables for this type of system. All right, so let's go look at some stuff. So we look at root hosts. We have to have a good inventory to do Ansible. Now, this isn't an Ansible day directly per se, but everything we do in the administration world is easier if we understand our automation tools. And I try to tell you guys, cultivate an automation mindset. When you watch me do something, even if I don't show you how to come do it directly in Ansible, you should be thinking like, oh, how could I do this? Okay, in this case, I have the nodes that we're going to touch, control plane and node 01. And then I have an arbitrary variable. Guys, I made this variable up. Type is not, this is not a standard thing. This is not a even standard for like companies I've worked for or anything. This is just a name that I came up with for a variable. And I said the type is either going to be client or server. Those were things I made up. Scott Champagne right now on Discord or whatever, right? I made them up actually a few years ago. But the point is, this could be server. This could be Arc. This could be all kind of, don't do Arc because Arc means architecture typically. But my point is it could be anything you wanted that made sense to you in your environment. The cool thing about Ansible is if it's not there, Ansible's going to ignore it. So if I had other servers in this list and I didn't give them type server or type client, by the way, maybe I use server and client already, so maybe it makes a lot more sense to say NFS server and NFS client. That may be a better thing for me to do. But anyways, I didn't think about that when I did it. But client and server are going to be in my definitions of my host files, right? Once you see this work the first time, I want you guys to understand, if you needed 29 more clients to this one server, all you would have to do is update your inventory file in Ansible with all of their names and the client variable, and then they would be deployed the same way. This is the cool thing about Ansible or any automation tool. If you understand your inventories, the execution is separate. You just so once you see this run and you go, oh, that's stupid easy. Yeah, okay. And then now you're part of the cult of Ansible because you see it's easy to do the deployment and the inventory super easy too. And by the way, these files like this, I could input these. There's all kinds of ways to get variables and hosts and stuff. But for now, let's do this. Let's make an Ansible role. So we're going to say root Ansible roles, and then we just make up an Ansible directory with roles in it. And then we're going to go over into there. So we CD'd into Ansible roles, right? PWD, I'm down in root Ansible roles. And I'm going to make two directories. One is, and real quick, let's see. Do I have tree on here? Okay. Sometimes it's nice to have tree on here to show you guys what's about to happen. You don't normally use tree as an admin or an engineer, but it's good when you're first learning this stuff. So let's say tree real quick, and there's nothing in here, right? Do you guys see in root Ansible roles, we have nothing. I like using Ansible Galaxy to build these. Could you build them by hand? Absolutely, but watch what happens when I do Ansible Galaxy init. I'm going to build two fully functioning, they're fully functioning playbooks, but I'm going to inherit them as roles. And when I type tree now, watch this. This is what happened. NFS client has a defaults, a files, a handlers, a meta, a tasks, a templates of tests and vars. The cool thing about Ansible is, like I was saying earlier, if you don't give Ansible something, it literally ignores it. So for our NFS client and our NFS server, we're going to be doing business down in the tasks main directories. Okay? Just know that for now. And I'm going to then also do one other thing. I'm going to copy in answers NFS deploy into here. And, up one. And in here, let's look at what NFS deploy is going to do. It's going to go against all the hosts that are in that host file. So as long as I point to the root host file, we're good. And it's going to inherit, there's no tasks here. We could do tasks. By the way, tasks always happen after roles unless you do a thing called pre-tasks. So pre-tasks will be before roles. It doesn't really matter the execution here. It'll always be roles first and then tasks. That's just the way they execute. That's a good important thing to know. I could take tasks out of this because there's no tasks being defined, but we normally leave these. And then the roles, check this out. If the role is NFS server, it's only going to happen on a server if it has the type client. So I was just making a big deal about your inventories being right, because once your inventory is right, server, type equals server or type equals client determines which path this goes down. No matter how many servers you drop in at the top, like a little Plinko machine, if they have server, they're going to go this way, well, only one, hopefully, and then all the other ones are clients going that way. That's how easy this can be. All right, so let's go look at the, we could cat it out and look at it, right? We just did. But now let's copy in some other stuff that's going to kind of be important here, and we're going to actually then go look at them. So here is the playbook. So cat root Ansible roles, NFS server, tasks, main. That was what I was saying was the server side. And to deploy the NFS server, there's our apt install that we just did from our other, remember in the lab we just did an apt-y install nfs-kernel-server? There it is right there. Boom. Exact same thing we just did. Then we're going to create a share for it. That's exactly what we just did. Exactly. It's just the syntax is a little different, but you just did it. You just had it in your hand, guys. And then we're going to go add a line into Etsy exports, and we're going to then notify restart NFS if we need to. And then we have a handler. Handlers only occur if they're called. It would be like if I was like, hey, Colchis, reset the server. And when I call Colchis and reset the server, then he resets the server, right? Well, we notify restart NFS, and then down in our handler section of the role, right, of that inherited role that we just built, we have restart NFS, which is called right here, and the systemd restarts that NFS server. That's it. Now, one thing that's really important is we only have one notify here and one of these. And the way notifies happen is very important to understand from an execution standpoint. Notifies act kind of like, have you guys ever seen in like one of those movies? There's a good example in the movie. Have you ever seen the movie Swingers? Has Vince Vaughn and I don't know, the guy who did all the Marvel movies, right? He was like Iron Man's buddy. He was like Iron Man's bodyguard, kind of. That guy. Anyways, if you ever watch that, he calls the girl like 100 times and like leaves all these messages, and obviously she never calls him back because he had just met her. John Favreau, that's exactly right. Favreau, I don't know. What I'm going with this is, if I told Colchis to reboot a server, if I called him and I left like 100 messages, like reboot server, reboot server, reboot server, reboot server, and then he finally got that message at like 5 this afternoon, so like in like 5 hours, how many times do you guys think he's going to reboot that server? He's probably going to reboot it once, right? Doesn't matter how many times I called him frantically saying reboot the server. I want you guys to understand, notifies are a lot like that. So have any of you ever like walked into a classroom and you like flick a light and all the lights turn on? Well, what if the person behind you also flipped that light up? It's already up and you flip it up again. You can't flip it up any harder, right? Well, the notify is almost like setting a bit, or like what we call setting a flag in scripts. And then at the end, we look at all the flags. We don't execute the flags throughout. That would be a freaking nightmare and a mess. We set flags as we go through a script, and then we get to the bottom and we execute and look through all our flags. And if the flag is at least set to true once, we're good. But we don't care if it was set to true 100 times. Hopefully that makes sense. Notify only happens at the end, no matter how many things notify it. That's very important to understand. That's a very powerful thing for idempotency, what I'm explaining right there. And if it doesn't make sense yet, that's fine. Don't worry about it. It'll make sense to you one day in the future. Only if we change etc exports do we restart the NFS. Meaning if I ran this, like if I ran this once and deployed on these 2 systems, and then I added those other 29 systems, and the first system was running as a client, and it didn't have to take this new file, like it didn't have to edit this file, it would not restart NFS. And then if 28 of my systems passed, but one of them failed, and I had to go fix that system and then rerun the playbook, but I didn't change the inventory, the other 29 systems would not restart NFS. They would be perfectly safe for the users, because only if this had to be added would that change. And I'm hoping that makes sense, because that's very important to the concept of idempotency. Does something need to be done or no? Don't bother doing it. Nobody needs to slap that light switch on. It's already on. Okay. So anyways, come down here, and we can execute the playbook right now. Now you might say, Scott, you never set the other side up. You never set the client up. That's fine. It's going to ignore the client. It's only going to do the server right now. Because when Ansible is inheriting roles, if there's nothing to do with a role, it just ignores it. It's actually one of my favorite things about Ansible for testing. I can build my playbooks in pieces, and it's almost like it doesn't even care about the function calls that don't exist. All right, so look, the NFS server is set up. The NFS server just built all that stuff we did on Node 01 just happened here. It deployed the server, it created the NFS share, it made the etc exports, and then it restarted that service. So I should right now, in theory, be able to SSH to Node 01. I should be able to systemctl status NFS. I think it's common server. Is that right? Let's just go like this. Because I can never remember, right? NFS-server. I see it running. I can do show mount -e. We can reset the terminal if we don't want to see that crap anymore, right? Show mount -e sees that. etc exports sees that line at the bottom. That line also triggered the restart, which made me see. Okay, so everything's good, right? Everything's working like we expect. Hey, how's it going, Enzo Bear? Yeah, so here were all the things that we could have done. So I exit and I just type that in. It shows us that it's exporting. Okay, good. So now we're going to go do the server. We did the server side. Now we're going to do the client side. But here's the thing about the client side. It doesn't really matter if the server side gets run again. It's just going to be ignored. So you need to deploy an NFS server and now need to configure the client portion. So let's go do that. And in this one, we're going to copy this over to the other side. And then we're going to cat that out and look at it. And what does the NFS client have to do? It's got to install the NFS common. So we have the client. And then it's going to go make a mount path of /mount with the source node 01 share with the file system type of NFS, and the state is going to be mounted. So it's going to build this and put this in the etcfs tab for us, just like we needed before, except we don't have to do it by hand anymore. Now we're going to run that. We're still running against the original server. Watch, all the server stuff's going to skip because control plane doesn't Sorry, control plane doesn't get any of the server stuff, but node 01 is already set up, so it doesn't need to do anything. Also, you're not going to see that handler run again because there's nothing that changed. Yeah, Enzo's over on the other side, Chris, yeah. All right, so now control plane did change. And if I do a df-h on mount, it's there. If I cat at the FS tab, it's there. All those things that we did before, we don't have to do, guys, we don't have to do crap by hand. We have to do stuff by hand to learn it, right? There's a value to like touching things and typing them out and putting them in our notes and like learning how they work. But once we do, we can run the playbook. And here's the even better thing, right? Oh boy, here's all the pieces, right? Is the file system mounted? Does it look right? Yes. It's all good. So if you were to do that lab, right? And you were to say, this is really nice. This is perfect, exactly like it works. I'm going to take all of it. Good. Take all of it. I think it's excellent. You could use that against as big a set of servers as you had, as long as you properly defined the type of client and server and knew where you were going to connect things to. Those would be the only things you have to change. And then later on, we learned about templates, and you're like, wait, so I could use this to deploy like 20 mount points? Yeah. Oh, yeah. And I could, I could use this to delete older mount points and also unmount them from all my clients at the same time. Yeah, you can use Ansible for all that crap. Yeah. Anything you can do with the command line as a normal admin, you can also make Ansible do for you. And that gives you that. Everything you do, guys, just feeds you one step closer to having more Netflix and nappy time during the day. Oh, did my thing break? Hold on. My thing broke. Yeah, Netflix and nappy time. Very important part of being an engineer. All right. I'm amusing myself, but I think it's important that you guys know that like there's some value in some of this stuff. Where's my... There it is. All right. Oh, I'm not even on the right box. You guys can always do exclamation mark answer, and it will drop stuff in there. Also, hold on. I need to be in this other mode. If you guys have any questions for me, and you do exclamation mark ask, and then your question. It'll do one of my favorite memes ever. So feel free to do that. Like Enzo Bear, say the same thing you just did, but put an exclamation mark ask in front of it. How often is Ansible used for each? Oh, fuck, all the time. I use it all the time, Enzo Bear. I literally just all the time. So, but Enzo, before you, but do that same thing, but with an exclamation mark in front of it.
I can answer that for money.
Do you guys hear it? It said, I can answer that for money. I'm bouncing up and down in my chair over here trying to get my chair set up right. It goes away after a second. That's one of my favorite ones right there. I set that up a few weeks ago. All right. So guys, the tool we use, I mean, Ansible's a great tool. You can do almost all the same stuff with Bash and Python, but it's just, you know, I know Ansible well because Ansible has, again, I'm full on in the cult of Ansible. Like you're like, Scott, what could save me a lot of time at work and make me look like a rock star while doing the minimal amount and still keeping all my nap time? I'd tell you Ansible. I'd tell you Ansible is one of the reasons that I'm on top. I'm not as fast. I'm not nearly as fast as I used to be on hardly anything, but I have a lot of stuff I've written that still works. So all right, so that was our NFS session. We're gonna set up Apache. Some of you guys probably came from this. This is funny. Like I came from the era, the early 2000s of doing Linux, where we set up LAMP stacks, right? Linux, Apache, MySQL, and before it was PHP, it was Perl, and it was, I've heard it Perl, Python, and PHP over the years, so I've heard it all three of those Ps. But the LAMP stack was Linux, Apache, MySQL, and PHP at the end, all on one box. That is not really the best way to do things anymore. The common modern architecture that you guys are going to run into are going to be definitely much more.
Has really grown on me.
I like that, Colchis. Yeah, thank you for the Prime. You guys can use your Primes anywhere. You choose to use them here. That's always nice. I think Perl's an excellent tool. Perl still holds a lot of the world together. A lot of people don't realize, like, financial markets and stuff are still built heavily on Perl. You can still have a good career in Perl, guys. Don't let anybody tell you, like, oh, that's a dead language or you'll never use it. I told you guys in 2016 when I started at AAA, and I came on as the team lead. My manager brought me on from another company where we had worked at. He wanted me as his team lead. Me and one of the other guys were the two guys that wrote Perl. And then the reason I stopped writing Perl was we were sitting on that team. We had like 6 other like junior and a couple of mid-range, like mid-level engineers, and then me and this guy Jason were kind of like he was kind of the de facto lead, and then I came on as kind of like the official lead, but he knew the most stuff still. And he and I were talking one day, and we're like, are we going to make all these young guys learn Perl to work with us, or are we just going to do everything in Bash and Ansible? And we were like, well, we both like Bash and Ansible, so we'll maintain the stuff that we have in Bash, and we'll write all new stuff in Ansible. And that's what he and I decided. And then that's what we kind of did with the team. So I haven't really professionally written Perl probably since about 2016. But I used to do, I mean, that's the language I cut my teeth on, right? That's the language like that I probably had written at the time the most automation for. Anyway, so where I'm going to go with this is, I said all that to say Apache is not going to be, it's not going to be Linux, Apache, MySQL, and PHP. You're probably going to have Linux and then maybe Apache as a front end doing reverse proxy stuff back, or then Linux and MySQL, or Linux and PHP. You're going to have your applications and your load balancers and your other things split out nowadays, right? Hey, Stephen Vetz, how's it going? We are just working through labs, right, doing Linux. I'm sitting on my little bouncy ball. Although I'm not really doing too much bouncing, but you guys can send stuff in with ! answers. You can do ! ask and ask me questions. If any of this stuff is super useful to you, do ! clip, and we can go that route. You guys can see that stuff. But let's set up by hand an Apache server. If we've never done it before, this will be great. And then we'll go and we'll look at other things that we can do inside of Apache that kind of bam it up a notch, right? We'll use Ansible to deploy it, and then I've got a lab. I think I got a lab in here on securing it a little bit. Did I do one of those? Maybe that's the one that we did in the home lab. I don't remember. I have to go look at the notes for that. But let's do our Apache web server. So here's the lab. If anybody wants to do it with me, I will link it. Boom. No, so Chris, I got the little ball just the other day. I was like, well, maybe I'll kind of sit on it and kind of I already wrestle, so I already have a pretty good core. I think I probably have, like, you might not look at me and think I had like a great core, but like from wrestling I have like good back bridging and that kind of stuff. But I just kind of wanted to like sit and get a little more of a workout, like burn some calories and stuff. And by the way, I feel it a lot in like my calves, because my calves have to like hold me up a lot as I'm kind of like moving around and stuff. So I actually like it. I mean, I don't think anybody has to do it. I still have my chair sitting over there. This is just in my home lab or whatever. I'm not going to like make a huge deal out of it or anything, but it definitely, like, I can definitely feel like the difference in like how I like am holding myself up and stuff throughout the day. And I jumped right into 8 hours a day of on it. So I've been on it for like 3 days now, like 100%. I only hop on that ball like when I first get back from wrestling, or not the ball, the chair. Like when I first get back from wrestling in the morning and I'm absolutely smoked from wrestling all these young firefighters and shit, and I'm just like sitting back, like, and that's when I'll use my chair for like a half hour, and then I'll get on this thing. So, yeah, Chris, yeah. Yeah, it's actually funny. Like I have pretty good, I mean, I have decent posture, but like even then, like I do sit at a chair, you know, fucking, well, I don't know, 16 hour, however long a day I sit at this desk, right? It's a lot. So I figure I might as well like at least get on the ball and get a little bit of energy burned as I'm sitting here or whatever, you know. So, all right, so guys, we're in a lab. We are going to, here's what it says. Our team has determined that they need a website to test deployments rapidly. Maybe it's our team, maybe it's some dev team that needs it or whatever. So what's going to happen here is you've been tasked with installing a web server on Node 01. Okay, got to put a web server over there. We're going to deploy an Apache 2 web server on Node 01. We're going to capture the version and install packages. We need that for our records. We need to give that to our security team. We've got this team that's always coming after us called the GRC, Governance, Risk, and Compliance team. So we got to make them happy. We're going to verify that the server is doing the things it's supposed to, in that it's listening on port 80. The type of check that we're doing here is a functional check. Functional checks are when we can check a box. It is running an Apache 2 web server. It is running on port 80. Boom. It is serving a page out. Those are all functional checks that we can do. They check boxes and they say our engineering part of this is done. When we do, there's non-functional checks, which are, if I connect to it 100 times and then connect 101st time, does it still serve a page? That's a non-functional check. That's like in the wild. We call those non-functional tests or non-functional checks, right? But for now, we're not going to load test this. We're not going to do any of that stuff. We need tools like Burp Suite or K6s for that. And those are tools that those are all free tools that we can play with and stuff. But we're not doing that in this lab. Also, I found in these environments, if you spin up a lot of load between two nodes, that is one thing that they have on the back end that like cancels out the lab. I've actually had labs stop because I've spent too much data between them with load testers and stuff. So anyway, so I don't have any labs on that, but let's go to node 01 and let's look to see if Apache's there. Well, predictably Apache is not there, right? So this is a lot like our last lab. Let's install Apache. How do we install Apache? We'll just let it install with apt-y install Apache 2. We'll just install it. There we go. Then we're going to look and see if Apache 2 is installed, which it should be, right? I mean, we've just installed it. So it'll be there. Let's let it install. All right. We have Apache on the server. There we go. Hey, Rob, how's it going? How was the morning? Are you still moving? I saw earlier when you popped on, but me and the wife didn't get in bed until midnight last night, so I didn't. When you popped on, it was like, I don't know, maybe 4 in the morning for me, I think. So, yeah, Rob, but I appreciate you raiding by. I always appreciate when you bring people by. You guys are welcome to hang out with us as much as you want. You guys have a few commands you can use if you want. You can do !ask if you want to ask me questions directly, and my notification will let me know that you asked a question, so I can't ignore you. You can do !answer if you want to send stuff right here into a Linux. Looks like somebody just did. If you do !answer, it'll send a question in. So Kolkis from Twitch answered with ls-lah, and then that sent that into our lab environment, and that back ends to a few different lab systems. I can show you guys that process if you want to see it, but otherwise we're just hanging out and we're going through labs. Here's the lab if anybody wants it. And what we're doing is we're doing Apache by hand. Why are we learning Apache by hand? Because we crawl before we walk or run. And the idea is we're doing Apache by hand so that then when we go and do Apache by Ansible, we understand what all the component pieces are. It would not make much sense. Like if I was sitting here and I'm like, all right, guys, I'm going to build this cool little Lego piece, right? I'm going to build this cool little Lego Death Star. And you guys are like, the Lego Death Star is way bigger than that. Okay, it's like this. And I say, okay, now real quick, I'm going to pull all the pieces out of the box. And they're all mostly gray, right? And then I do this and I turn around like this and I pull the Death Star. And I'm like, and then we're done. You guys would be like, this fucking asshole right here. This guy have you guys ever heard the rest of the effing owl? It's actually a Reddit subreddit. It's called the rest of the... And they say fucking owl, right? The rest of the owl, right? And what it is you're giving steps, and you say like step 1 is like take everything out of the box. Step 3, sell it for $3 million. And you're like, what are all the steps in between, right? Well, anyways, my point is that it wouldn't do for me to just drop you guys in and be like, okay, this is the thing. So we're doing this a little slower. We're starting with a base Linux system, and all we did was SSH to node 01. Before you guys got here, we checked to make sure Apache wasn't there. It wasn't. Apache 2. And then we installed it. That was all we did. And then now, for our security team, or for somebody else, for our own records or whatever, we've done a change to our system. So we probably had a change record in a dev environment. Maybe we don't have a change record, but I would still highly advise you go and grab all your versions of whatever you just did and throw it in your notes. Hey, we added on this day. Because then when you in the future come back to see what you in the past did and you don't remember it, one of the worst things you can do is go, oh shoot, I got to figure this whole damn thing out again. I hate that, guys. I absolutely hate that. So I always have like a notepad open, right? Notepad++ is one of my favorites. And then I know what I need to do. Now I have this open to a page that we're going to be using here in a little bit where we have a bunch of questions when we get to the security part of our labs. But we're doing Apache for right now. And I would grab this and I would throw it in my notes somewhere. Yeah, did you like that dashboard? Hold on. This one is, this one's actually a cheat. Where's it at? Right here. This is guys, I stole this off the interwebs. I steal everything off the internet. If you guys ever use Grafana, you can get everything you want for Grafana right off the internet. Yeah, this is called my XCP NG lab monitoring, but really all it's doing is pulling data in from Prometheus. This is literally just a Prometheus scrape from Node Exporter right here. And then it's all the boxes that I care about. It's their CPU and their memory usage, and then it's a bunch of information about them if I want. And one of the things we were talking about earlier for you guys is like sometimes, there's a lot of visibility here. It's almost noise, but it does give me what's going on inside of my system. It gives me a quick HUD, like a heads up display of nothing's bad. Now, guys, I am like wickedly colorblind, so I know these are green and red, but I got a real hard time. Like if that's red and that's green, I hope so, but I'm not like. My eyes do not work as well as other people's, trust me. Like, I think these are all red and these are all green, but I think I might be guessing because of the numbers. Trust me, my color vision's terrible. That's well established. So is my vision, right? It's terrible. But, that's well established. But yeah, that's an awesome dashboard. You can get that. If you need that dashboard ID, I can get it to you. That's right from their dashboards. And guys, I tell you guys, get the dashboards, get the tools in, and then pull out the things you don't need until you just have the visibility you want, right? So, yeah, that's one that's out there that's pretty good. So we've got Apache on the system. Let's see if Apache is running. So we did a systemctl status Apache 2 service. We see that it's enabled and active. So active means it's running right now. Enabled means if we were to reboot this lab, it would come back up. Those are two things that are different and very important. Enabled or disabled are the state of the service on next reboot, what we call the persistence. And then active or dead, it's active or dead. Those are the state of it right now on this active system. So if I were to systemctl start Apache 2 on a server, but it was disabled, and then I got everything running and everything was pretty, and then I went home for the weekend and that server rebooted for some reason, but I had not made sure that it was enabled right here, I'm going to get a call out. I'm going to get a call out because my shit's broken. I didn't understand that my system was not set to persistently come up again, so I broke everything. So, anyway, so yeah, Rob probably had to go, but I do appreciate Rob stopping by. Oh, there's Ranger. That's our Ranger telling us we're doing Linux out back. Okay, so that's up. We see on port 80 that we're listening, right? HTTP listeners are there. And right here with our ss-ntulp on grep 80, we see that we're listening for all IPv4 traffic on port 80 for TCP. Perfect. So we've got a working system as far as that goes. And then the last little thing, check that the UFW is, the uncomplicated firewall is off. We'll exit back and we'll curl that page and we will see a basic little Apache 2 page. Okay, Apache's on the system. We're happy. Yeah, and Zobera, I appreciate that. Yeah, Ranger is resting peacefully now. So, did you see the default web page? Yes. Once you set up that first part, let's go see what else our team has for us. So you've done a good thing. Now your team's going to break all kinds of stuff and ask for the impossible, right? Yeah, Chris, a lot of times when I'm setting things up, I'll turn firewalls off, get things running, and then I'll turn firewall functionality back on. Especially in dev. In dev environments where I can get away with it, I'll do that. You can't do that in prod environments, but you're also not building things in prod, so you probably won't ever have to. The disciplines will never overlap because you're not building stuff in prod, right? Or you shouldn't be building shit in prod. Now, you gave them port 80. The team says, nope, we need 3 different environments, and we're going to put stuff in each of the different document routes. So now you need to figure out what a document route is, and you need to figure out what a port is, and you need to figure out all this other stuff. Port 80 is the default, but they want a dev, test, and QA on port 8080, 8081, and 8082. Well, at least they defined them for us, right? That's nice. So I know what I need to do, and I can come down here, and I'm going to SSH back into node 01, and the first thing we might do is cd to var www, and in here there's this HTML. HTML is, SE Linux is a problem too. Sometimes we'll turn SE Linux to permissive mode, watch things happen, and then we'll turn it back to targeted, and then we'll run like a audit 2y, and then audit 2y will tell you how to fix things. audit to why and audit to allow are ways that'll show you how to build from the logging that you're seeing in SE Linux. They're these nice Python scripts. They'll actually tell you the modules you have to load up and stuff. And I've had to do that a few times. It's not terrible. I do have to do SE Linux sometimes, guys, for government systems. Yeah, ellipses. These are negative 11. These are negative 1075. My classes. So yeah, they're really bad. You said you're negative 725. So yeah, these are negative 10 something. Yeah. All right. So we're going to make a directory in here for each of these other document roots that are going to exist right here. If we were using SE Linux, we would have to set the SE context to them. We would check, and there's no context set right now, so we don't need to worry about it because SE Linux isn't on this version of Ubuntu. But now we're going to go into Etsy Apache 2 ports, and in here we're just going to come right here and we're going to say YPP, YYP, and we'll just go ahead and hit 80 YYPP, and then we're just going to hit R1 and R2. So now we have all the ports that we're going to listen on in our system right here. So that was in Etsy Apache 2 ports. We're going to configure 80, 8080, 8081, and 8082. Now that's going to align with what we need here. So we've also made the document roots for each of these. But now we've got to map every listener together. And in Apache, we do that with a thing called a directive, right? So Apache has these things called directives. Directives look a lot like HTML in that you turn them on and you turn them off. So let's go look at what our directives are going to look like. We're going to go and, if we were to cd from Etsy Apache 2, in here there is a, let's cd into sites enabled. The only site that's enabled right now is this really long, I'm going to make this smaller so it fits on the screen a little better. Hold on. Is this one directive, and it says virtual host on port 80. Anybody coming in on port 80. This is a bunch of noise right here. Is server admin here and document root here. So there will be a definition for document root. The error settings and then the closeout. Everything else in there is noise. It's just comments. It doesn't matter, right? So watch this real quick. We're going to make a file in here. And in that file, I'm going to hit I. And I'm just going to go copy in all of these 3 virtual directives for hosts. And when you see them, you're going to be like, Scott, that's stupid easy. Watch this. Port 8080 right here. We're going to listen on port 8080. We defined that in our ports that are open a second ago. And then we're going to come over here. Enzo Bear, I'm super blind. I'm like super blind. And in here, we're going to say the document root is not var www.html like it normally is. It's going to be dev because that's 8080 maps to dev, right? So we're mapping it over. We're going to give it a specific dev log. Then we're going to say 8081 goes to test. That's the test environment. And then we're going to say 8082 goes to HTML QA. That's it. That's all we're doing right here. That's it. So escape : WQ. It's surprisingly simple what we're doing for this. So let's clear this up. Cat testing team. That's what our testing team needs. They need dev, test, and QA on port 8080, 8081, and 8082. Now, how did I make that? Well, just the first time I built the lab, I wrote it out, and I did it by hand, but now it's all there. Okay, so we come down here. Yep, the last thing we got to do, and for safety, systems do not automatically restart and their services. They do not reread config files by default. But there's one other thing I actually have to do. Well, we don't have to do this, but I'm going to do it. We're going to give a basic little web page for each of them. So in this index.dev, we're going to go, so in the dev one, index.html, we're going to give it a dev page. And then in our test, we're going to give it a little test page. Just super simple. This is like the easiest HTML that you can muster, right? This is like the most simple HTML that can possibly be done. And then we're going to do a little QA page. That's just going to help us when we're doing our tests here in a minute. There's our HTML, right? It's not an HTML course, but then, yeah, the last thing I'm going to do is restart Apache. I could have restarted Apache before I loaded the index. That would be fine too. Now, are we listening on all the ports? Yes. We see that we're Listening on port 8080, yes, there's open files. We're listening on 8081, yes, and we're listening on 8082. And then we could just real quickly run a loop over all of these tests, and we can see that we've got a dev page on port 8080. Right, the port number is going to be 8080 the first time, 8081, 8082. I can make this a little bigger again so you guys can see it easier. And then here is our dev test page, or dev page, our test page, and our QA page. Now that's fine to do by hand when you're first learning how to do it. But one of the things, let's hit check here. Look at you learning Linux. You set it all up. You did all those things. Let's back out of this lab. Let's get completely out of this lab. If you've done it or if you're still working on it, keep working on it. And we're going to go back out one, and we're going to go into our Ansible labs, and we're going to use Ansible to automate that. So Ansible. And I will link this to you guys. Where's our Apache one? I thought I had one that was just web server. Here it is. All right, so this is the Ansible for this. This is the same lab, same exact lab we just did, but we're going to use Ansible to do it, guys. So if anybody wants to do it with me, here you go. I have linked it on both the Twitch and the YouTube side. And now it says, your team was so happy with your work on deploying a web server, so that's from the other lab, that 10 other teams have come to you and asked you to do the same deployment for them. Well, I'm not going to be dipping into my Netflix and nappy time to do all their web servers for them, right? But I am the root user on Linux, so I do have to deploy things like that sometimes. So we're going to make a web server available on node 01. We're going to set up the directive and web pages that identifies each of the following pages with the right port numbers. We're going to do all the things we just did. We're just going to use Ansible to do it. And then we're going to make sure each HTML page exists and has the name, dev, test, and QA on the page. And that'll be provided by the individual teams and put in the answers directory. So what they want in there is given to us in this answers directory. So I might go to dev index.html, and that's what they wanted to see on that page. By the way, it's the same thing from the other lab, so that there's literally nothing changed, guys. There's no, like, look, I'm not even wearing sleeves, but if I was wearing sleeves, there's nothing up my sleeves. I'm not tricking anybody. I'm not anything. Yeah, Robodom, the Netflix and naps times are in the offer letter before signing. Sure. I was saying this the other day, and I think some of you guys probably thought I was being a Chad, but this is 100% true. I have not been late to work in the last 22 years. I'm an engineer, man. Like, I show up to work when I want to. Now, do I have to get all my work done if I don't want to get fired? Sure. Do I want to, like, be there my 8+ hours a day? Sure. But, like, the act of, like, getting to work on time is a foreign concept to engineers. Like, we don't have, like, a be in by 8. I normally get in earlier than that, but my point is, like, be in before your first meeting. If you have a physical meeting, obviously you have to be there for a meeting or something. But you're not late anymore when you're an engineer. You're like a wizard. You show up when you intend to. So Hetflix. I need somebody to exclamation mark clip that for me. That's pretty good, Hetflix. All right, so let's check our host file. In our files, we can have definitions of things, right? So control plane and node 01 are sitting here. And now we've got these, again, arbitrary variables. They're just made up variables by Scott for the purpose of my deployments. And the environment was prod and the environment was dev for this environment, whatever I want it to be. The app was DB and the app was web. And these are actually, thinking about it, these are holdovers from a different lab that we did. What matters for this one is web servers. We're going to actually hit web servers. And the only host defined in the host group for web servers is node 01. And he's been given the environment dev and the app web control plane. That's because there's not an extra space. Something in Git in the last few years, because this wasn't how these labs were originally set up, stripped the trailing character off of all of these as it put it in. Doesn't affect your lab in any way. You just don't get the automatic. We could just go in there and add another line, add another one to each of these, and it wouldn't affect the execution. It's almost like I'm being defiant by not doing it. But anyways, it's like a thing that's just ugly, right? Like that should be on its own line because that's the command prompt. But all right. So we can go in and look at all those things and see what each of these different virtual hosts look like. And in these files, in this one, I have chosen to, or the devs, not me, the devs, have chosen to write a different virtual host file, so dev virtual host, QA, test, whatever, for each of the environments. So earlier in the last one, we did everything in test team and we wrote all 3 directives in there. But guys, it's a directory. The directory gets slurped up into the config, so I can have multiple different files. So it doesn't matter if this is on its own file and this one is on its own file. They're different than what we. I can answer that for money. I didn't mean to turn that on. That one turned itself on. Well, it was because I did Control-Shift-V, I think. But if any of you guys do !ask, it'll automatically pop that up over me if you ask any questions or anything. So, all right. And that'll also let me know that somebody asked a question in case I'm just like driving on and not listening. So then we've got a component file, so we can go and look at what's going on in our web environment YAML. Right, that's also down here in answers. What happened? Thanks for the follow, that Mechanator 69. Hopefully this stuff's useful to you. Might be Mechanator. I don't know. Hopefully it's useful to you. If we're over here, this is the setup for our web environment to only hit that web server's host group that we wanted to look at. So we should be able to see that in, where's that at? Web environment. What the hell happened here? Yeah, there it is. And here's the web environment. And then here's our tasks, right? We're going to install an Apache server. That makes sense. We should do that. We can make all of those different directories like we did earlier. And then now I'm doing a little bit of a loop. So now we've got the file module right here, which is going to make a directory with item. And then it's going to loop over item each time. So it's going to say dev, test, and QA. Now, when we did it earlier, didn't we just glob and we used the wildcard expansion inside of Bash to just say web test and QA or whatever? So we did this a little more efficiently, I guess, in Ansible. And then we notified to restart Apache because we've changed something. Then down here, we went to the listeners, and in Apache2ports.conf, we said insert after the word listen, state present with item, and then we looped over item and we added in each of those lines like we did in the last lab. All we're doing is taking away us having to do stuff. That's all Ansible's doing right now, is doing the stuff that in the last lab we did by hand, right? It's automating it. It's doing all our stuff. So we're doing some looping, and then it's going to notify, hey, if this happened, restart Apache. But again, this said to restart Apache, this started to restart Apache. It's only going to happen once at the end if it's been set to go. Then we get down here and we push all those virtual directive files over. For each of the things in that answers file, so dev, QA, and test, move them into sites enabled by their exact name. So now in sites enabled, we're going to have 3 different directive files with 1 directive each that look like those virtual directives that we saw to set both the document root and the port number for the listener, right? That's going to tie back to here. And then also the error and all those other things, right? So we've got all the things predefined, and then we're just going to go use Ansible to push them so that we can watch our Netflix. I want you guys to see, this is the one time I did something weird. We get from answers, and we split now. So we took 2 variables out of this. For the environment dev, we have the name dev-index.html. So when we find that file, dev-index.html up here, when we drop it down here in this path as index.html, it only gets this shorter environment name. So that's a way to kind of be sneaky, where up here in answers, we can grab the dev index HTML, but all of them, when they're actually placed where they belong, will all be called index, but the document root file will change in the document root path, right? So that's kind of a, again, if it sounds like I'm being overly technical, guys, one of the reasons I do this, one of the reasons I talk like almost pedantically about this stuff, is because this is how engineers are going to talk. Maybe this is the only time some of you guys get to hear an engineer talk about stuff like an engineer, or an admin talk like an admin. So I'm giving you guys that, and I do the same thing. I tell the guys in my I tell my students this, right? My college students, If you break rocks all day and I come in here and I just talk like a guy that breaks rocks all day and I don't give you, I feel like I'm robbing from you guys at that point if I'm doing that kind of crap. Anyways, we get down to handlers, and the handler will only work once. It will only execute once, even if it was told to work each time. It's going to be told all 4 times the first time to execute, but it's only going to execute the restart once, and that's smart. That's a good way to do it. Plus, if we rerun this later and all these are set, which they will be, it will not restart again. We can just keep safely running this over and over again, never affecting the execution of Apache. Okay. Every time I kept stopping talking, this thing has like a cricket sound or something, and it sounded like I was the one doing it. I was like, wait a minute, I'm not the one making that weird cricket sound. Do you guys hear that? It's like somebody running a thing down one of those like little spiny, they run the little stick down like the little soundboard thing or whatever in like your 3rd grade music class or whatever. All right, anyways. So this shows what all the components are, all those things I just talked about. And we get down here at the end, it does the handlers. We're going to copy that into our root environment just so we can execute it. And then we're just going to run that. That is a super annoying sound. Hold on, I got to go change it. Pretzel Rocks, you have failed me for the day. Oh, God, it's halfway through that song. No, we can't. It was like, you guys ever seen that? You know what I'm talking about? Like your music teachers had like a frog with like the little things on their back, and then you would rub the little wood thing on it. You guys ever seen that? I think I don't know what the hell that tool's called. It's a musical instrument, but it basically just sounded like I was ribbiting or something. That was weird. I said ribbiting, like a frog. Ribbit. Not rabbit. Who said Rhode Island? All right, I quit. That's it. I'm done. All done doing. No more. I'm leaving. One of you guys is in charge. All right, yeah, no, I don't care. Yeah, I see them on frogs or like the back of like little like alligators. They'll have like little alligator ones. Yeah, like every music teacher in America had one of those, right? And it's the only instrument I could play. No, I'm just kidding. I've played music my whole life. So let's go Ansible playbook. Let's run it. This is one of those things where let's just see what happens. Let's run it. We have all the pieces. Everything should be there. We just saw it happen by hand. We just built this lab by hand, guys. Now we're letting Ansible do it. It's going to take a little while to install Apache. And then we're going to see all the pieces happen. And then we're going to verify that the handler worked. And then it says right here, run it a second time. So look at all these things that have to change the first time. It had to create the directories. It had to move the listeners in. They had to change all these things. It had to run the handler to restart Apache. Let's see if it's working before we run it again. Everything's there. Everything's there on the right ports. Cool. Let's rerun the Ansible playbook. This is why there's a cult of Ansible. If anybody's ever told you, oh, Ansible's a fucking bunch of cultists, this is it right here. This is why. I can run this all day, and it's not going to change anything. It's not going to restart that service. Look, it's finding everything good. Everything's the way that we expected. Everything's good. You don't see the handler right here. You see all the last tasks are good. Nothing changed, so nothing triggered the execution of the handler. So the handler was not run to restart Apache. Nothing was changed. Why would we restart that Apache? So you say, what does that mean, Scott? Well, if I went and added 4 more web servers here for node 02, node 03, 4, 5 in the environment, I could just and I just copied this and I just made those hosts and then I reran this. It would not rerun or restart on node 01. It would still go check node 01 and make sure it was good, but it would not make any changes if it didn't need to. Now, we're not getting into it right now, but I'm going to tell you guys there's a very important concept here that then you might say, well shit, Ansible sounds really powerful. It is. There's a tool right here. There's a thing called configuration drift and remediation. This is a balance that always happens from the time that we push servers off into the world. From the time that I first build a server or a set of 1,000 servers, whatever I'm building, and I push them off into the world, from the time I do that, they immediately start changing. Admins get tickets on them, people break stuff, disk file systems fill up and we got to rebuild them. Things change all the time on a set of servers. In fact, I tell people like a week later, those servers have gone different paths. And then in our configuration drift and remediation section here, we did a lab where somebody figured out how we could change these, right? In fact, I think There's another part to this lab. Let's see, check it. And then I've been extremely successful, but now teams want the ability to turn off or redeploy only parts of the environment. So now we got to change the way that this works a little bit. We're going to break out the playbook and use some other things called blocks to execute certain code only when certain types of things occur, right? By the way, when I first wrote it, I wasn't going to give you any answers, but then I did write the answers file, right? So you have to do this one on your own. You can do it manually, or basically know that you're going to do a lot for all those developer teams. All right. So I did become weak and then just write the answers for you. Well, also I thought because it would be fun. By the way, guys, if any of this is useful to you, one, I couldn't even stop you from taking it, but two, I would highly encourage you to take it and use it in your test environments, because I'm a firm believer that if you find something that's useful to you and then you get it to work like that one time, it'll be yours forever. You'll be like, oh, yeah, sure, I'll do that, boss. I'll do that before lunch. It'll be easy. And you'll look like a rock star because you understood a thing, and then you could take it apart and change it for your purpose, right? All right. So anyways, let's view, you can view or VI or Vim or whatever, individual web. This is the same thing, but now we've got some requirements here that I want to make sure that you know. You have to run this a certain way, because now there's these blocks that are only going to happen when deploy is present, or at the bottom here, there's another block when deploy is absent. So if we're removing things or adding things, we can do it. Wait, Chris, is Microsoft like in the ads or something like that? That would be really funny. If Microsoft was popping up in the ads, that would be kind of funny. Please tell me they are. I mean, I don't care, but that's kind of funny. And also for people that have ads, I apologize. Some of you guys, you've heard my little spiel. If you're in Twitch and you use and you don't want people to get pre-roll ads, you have to run ads. By the way, look, when we do everything, when we either add or remove stuff, we also have to notify Apache to restart. So at a high level, right? Like let's say you didn't know any Ansible. I'm just going to tell you this. If you did, you at least know logic. The thing that splits this to one of the other blocks, one or the other, is whether deploy is equal to absent or present. That's an important thing to understand. So up here, when you first deploy this, you're going to give it an argument at the command line. You're going to give extra variables and set it to do one of the things. Oh, when I was ribbiting? No, so that was actually Pretzel Rocks in the background doing it. But that was actually kind of funny. Like every time I would stop, it would go ribbit. I'm like, what the fuck is going on here? Am I having like a... Am I having a, like, stonk? Am I... Somebody called the bondulance? Like, am I... That's a meme I posted in Discord the other day. All right. So anyway, so we copy that over. Let's copy that over. Boom. Oh, whoops. Don't want to change anything. Let's just copy that over. Cat the file out, look at it. We looked at it. It's either adding or removing things, right? And then when we go to run it, we're going to add a deploy absent. So we're going to remove environment test on port 8081, right? So we're going to give the things that we want to remove out of the environment. And then you'll see down here where it didn't remove things that it didn't need to. And it did delete the environments that it was supposed to down here. So instead of pushing things, it skipped all those. That was the one block. And it did delete the ones it was supposed to. So now to test that, if I go just back up to, right, go back to my curl, 8082 should be there. 8080 should be there. But Pobre 8081 is not there. We have removed it. So, well, or our dev teams have, or whatever. Now, if you do our admin course, or let's say you're like, I don't want to do your security engineering course, that's fine. If you want to do just the lab is over here. Whoops, I messed that up. I want to go to 8 lab. It's in Unit 8 lab. And did I make it its own lab? I make you change it a little bit here. But this is the page if anybody wants it, right here. Boom and boom. If you do the challenge, it'll say that your team has kind of basically effed this up, and they keep doing the deployment, but could you keep just fixing it? Could you run the original one here? Right, so if I did, watch, I'll do history. Ansible. Could you bang the first one, which is exclamation mark 16 in my case, and would that set back the environment back to correct? Fix the one, saw that was still there, fix it, restarted Apache, and then I go and I rerun my 8080, 8081 should be there now. Yep, and 8082. We're also back. We're checking that nothing else is broken. Yeah, everything's back up. So the question was like, could we just keep fixing the environment that somebody else broke? Sure. Would that probably break other stuff? Sure, probably would, right? So you really have to think about, part of the course when we did the security engineering course was thinking about, like, do we really want to just break things sometimes or no? Oh, by the way, guys, the Discord should have, this event should be starting right now. So if some of you guys are like, oh, hey, I want to go do something or hang out or talk shop with people, they will get more people in there. But you guys should definitely get in there and watch them and work through that stuff if you're interested in doing Linux, right? All our courses, everything in our Discord is free. You guys, if you ever see somebody down in a channel, you can go down there and hang out with them and watch and whatever. I do ask, there is one little rule about the server, only because we've had problems with it. You know, if you're in an event and they're doing something, don't just be like dicking around and doing other stuff. That's not really... By the way, that's not what you would do professionally, right? Like if your manager or somebody else was sitting in a conference room, you wouldn't just go in there, put your feet up and start talking on your phone or something, right? That would be... I think everybody here understands you wouldn't be there very long if you did that, right? Same thing here, right? Like let people have their fun and feel free to enjoy it as well. And Colchis does a really good job of running that group. So he has a lot of bash stuff. He has little challenges for you guys and makes you practice and makes you think about things you might not normally think about. But if you're trying to get into Linux tech, that's a good way to start doing that stuff. Yeah. People do a lot of stuff, man. I've been surprised with stuff people have done in the server. You know, we try to be a pretty laid back place, but sometimes people just want to test the limits of what's possible, right? All right, so look at you. You did Ansible. You created a playbook to deploy a web server. We weren't even doing Ansible today, right? We're doing Linux. And then as we're doing some of these things by hand, I'm also walking you back and showing you guys how the Ansible side of it works as well. So let's go back over to our Linux labs. And our next lab, we're going to skip off of, we've been doing Apache. We're going to start getting back into monitoring, right? So we're going to shift gears into doing monitoring and system, looking at things in the same way that I kind of do over here, where, let me put this back on the course syllabus. Right there. That's our course syllabus for that. And we'll get down and we'll do some Grafana monitoring with Loki and all that kind of stuff. So that'll be our next one. So let me take a break again. Go wander around a little bit. So let's pull up our hourglass. And again, feel free to walk around. We'll say break. And then Grafana and monitoring. We have a lot of stuff on monitoring for you guys if you wanted to do it. But we'll come back from break and then we'll do some monitoring of systems and stuff. All right. If you guys have anything you want to send into the lab environment, do an exclamation mark answer. And other than that, I'll be right back. Just gonna go take a little walk, check my phone and stuff. All right, guys. I'll be back here in a minute. I'm just wandering around, stretch my legs out a little bit. All right, 3 minutes left. 3 minutes and some change. Do we need to change the course syllabi with the new lab environment picture? No, I think that's fine, Chris. I will probably in the future we'll change the way that people connect. I've got a new way that people can connect. For people that aren't familiar, in our course we have a way that people connect with this user Streamer 1, and that was a user that I had originally built. But the jail currently, and the way that you come into the environment, can be accessed through I think it's just Prolog. The user's just Prolog now. And then I've just added to the jail as we've went. So for people that have never seen that, you know what? Actually, it might be easier to just see it this way. Let me cd to var chroot. I might have changed it to, yeah. And then we'll cd into bin. And the bastion.sh is now either admin course or security engineering course, and then you get dropped into one of the systems, either Rocky 2, 3, 4, or 5 right now, because somebody's on Rocky 1. So if somebody's on Rocky 1, it doesn't show up in this list after a minute, and then it'll only come back if it's up and if it's available. So this is a template being generated every minute by Ansible, and Ansible goes and checks to see if anybody's using any of the nodes. The break stat, that would be funny, Hayes. Yeah. Although I don't want my management to ever see my break stats, because I take a lot of breaks throughout the day. Nobody's using any of the first 5 Hammer servers. So the reason I wanted to do this was because if you guys remember when I first built out the labs, I didn't know what our capacity was going to look like, and I just assumed everybody was always going to be in our labs. I was like, oh, everybody's always going to be using them. So I built 19 Rocky servers and 25 Hammer servers. So we had 44 servers sitting out there, and when I would check them throughout the day, there would be, I don't know, nobody on them. And then maybe even when we were like in the height of our first time doing the Linux sysadmin course, we never had more than like 5 people on them. So what I wanted to do instead was, in the theory of somebody never logging in within the same minute as anybody else, I decided to just have it where Ansible would go and find the nodes that were open and then generate this host file each time. This is the Bastion shell for the users that log in. And if you hit 1 for the admin course, you would just go to whatever the next open one was. And these would, again, be less and less if there weren't. And if you got all the way to the end, you would get no capacity for the admin labs found. It would just kick you out. And again, you're only going to hit some of these other ones if you bypass these first ones. So this was a perfectly fine poor man's way of doing it, right? And then down here, it was the same way. If you picked security engineering, you would go into case 2, which is security engineering. And if you didn't pick anything, you'd get kicked out in 10 seconds or whatever. And then was there anything else to this one? No. I think if you hit 3, it was like have a good day. And if you hit anything else, it would just kick you out. You've not entered a valid input. So that's, I mean, yeah, we should probably update that one of these days, but that's not, I don't think that's too big of a deal. Next time we run it, we'll probably want to change everything over to Prolug. And then I'll do all of our capacity and all of our jailing right through Prolug. And then that's easier because then everybody can just have that. I think that's a good way to do it for now. So, yeah. Hayes said, "Are we using Grafana to display the break stats?" I don't want anybody to know the break stats. There's lots of breaks being taken right now, guys. I don't want anybody to know all the different breaks that we're taking, especially management. All right. So let's go do some Grafana monitoring. If you guys have never done any monitoring, the lab looks like this generally. This is what the environment that we're going to be building is. We're going to do, the first one is going to be Promtail, Loki, and Grafana. And Promtail is going to track logs in our environment. We use this in all kinds of different labs. And by the way, in the future, I think we're going to need to change Promtail over to Alloy because my understanding is, I think we need to check in the Discord, but my understanding is Alloy is going to be supported going forward. Promtail is not. So Promtail is a tool that Grafana supports as well as Loki. So this is actually all native tooling. But the point is, something is pushing logs into an open API called Loki. Also, by the way, yeah, Alloy is supposed to be really good. I've seen good things. I was looking at how the configs change for it. It doesn't seem like it's going to be super hard, and I think it would be kind of good. Anarchist, thank you on the YouTube side. I think that may be the first time I've ever seen that happen live, so I appreciate you becoming a member. Hopefully that's useful to you. I don't really have like super special stuff going on the YouTube side, but I will definitely on the YouTube side eventually be doing stuff where I release some things that are going to eventually be generally available, but they'll definitely go to like the members first. But I have it all planned out. I just haven't started doing it yet, and that's going to look heavily like each of these individual labs, and then like with all of the book and everything, and like what notes I would be taking. So it'll be like really straightforward stuff. I think that helps people get into doing this stuff better. So anyways, hopefully that all makes sense. But yeah, I don't think we necessarily have to change it yet, Chris, but I'll probably do a pull request because I don't mess with the book stuff a lot because I let the guys do the book. I want everybody that's working on the book to get all the experience of doing all that stuff, but I can do pull requests and open issues with the book and stuff. I am technically the owner of the repos, even though it's really Treasure. Treasure's really the guy that's driving a lot of that stuff, so that's kind of his thing. But he has told me like put in issues when you know about issues, and I'm like, all right, I'll do it. I just haven't had a need for that yet, but I'll do an issue when I do a new version of that picture, and then we'll standardize those, and that'll be good. All right. So let's get our heads back on straight. And here's the lab. If anybody wants to do the lab with me, labs are always free. They do not cost anything on Killer Coda. I think I can do this and then pin the lab over here on the YouTube side. So we'll pin the message on YouTube. And this lab says that your team has determined they need to offload and monitor Linux logs in your environment. Why do they need to do that? Well, it's very important to get logs off of a Linux server in real time. You do not want to be waiting for a server to come back up to be able to get at the logs. You need to get them off in real time. There's a lot of like real-time data analytics reasons to do that, but there's also a lot of resolution of incident reasons to do that. So the point is we need to get logs off of servers in real time. You know that Grafana can do that as a visualization tool, so it can look at stuff. So you plan to deploy it on the server as a daemon. So we're going to start with Grafana, and then we're going to build all of these component pieces together. I'm going to tell you guys one other thing before we start. If anybody wants to do this as a project, if you say, hey, Scott, this is fun, but I want to like have something to put on a resume or show somebody, let me back up. If you're in our Discord, right? By the way, Discord's free. Everything's free. If you come over here to presentations. Yeah, let's go to presentations. Pretty sure I got it in presentations. And you go up not too far, because it's not very far back in presentations. In fact, I think it might be the first thing in presentations. Nope, not the first thing. It's not there. Might be in projects. All right, it's not in presentations, it's in projects. I apologize. But if you go to the very beginning of projects, this is actually what started the projects channel. I do remember that now. This started the projects channel. This is why we started the channel, was for this lab or for this project. There is a thing called the Monitoring Deep Dive Project Guide and the Monitoring Deep Dive with Labs. So if you download both of those, they're PDFs and or PDFs. They're PowerPoint, right? You can open them with like LibreOffice or whatever. But this one right here is a template for you to go through all of this, do notes, and build a little project, like a little 10-page project thing, that if you had nothing in your portfolio to show that you knew how to do sysadmin stuff, you could at least use this to show. Do you guys want to see it real quick? Let me show you guys what it looks like real quick. Hold on. So we go to Prolog presentations, and here's the project guide. Get rid of that. And here's what the project guide looks like. Here's the questions and your notes as you go through these things. What are the things we monitor? How would we define them? Where are they used in the systems world? And then what are time stream databases and all these kind of things, right? Hey, thanks for that, X, over on the YouTube side of things. Thanks for all your hard work. Yeah, I appreciate it. Hopefully this stuff is useful to you guys, right? And then the first one is Lab on Telemetry, and it walks you through that. And I have some pictures in there that you could also add your own pictures on top of. Lab on Logs, that's what we're doing now. So where does the data start? How do we collect it? That's Promtail. And you're going to understand these things as you do this, but you're also going to write them out so that you can then explain Lab on Tracing. And then where do we, what did we not know? What do we now know? And how are we going to apply it, right? So I think that's very valuable for you guys. And that's at the top of the Prolog projects thing, right? And then, yeah, there we go. So let's go in here. Your team has determined that they need to offload logs and monitor using Grafana. So we're going to start with Grafana. There's a Grafana docs page that you can go spend some time with, but we don't care about that. We're just going to install a couple of dependencies. These dependencies are needed so that we can run Grafana on our system. Is that first one not needed anymore? Oh, it's already there. So app transport is already there. We don't need it again. That's nice. Now we're going to make sure that we have downloaded the Grafana GPG key from them and put it in a file called user share keyrings grafana.key. We need that because then that's how the repo is going to know what it can trust. And we're going to echo this value into etc apt sources.list.d grafana.list, and that is going to make a place that our system now trusts for us to go download software from, provided it's signed by that key. That's all we did with those two commands right there, right? Come down a little bit. Now we say apt update to get all the metadata information, and then we're going to update Grafana, or we're going to install Grafana Enterprise in our environment. So we're going to put Grafana on the server. We're going to put a full server of Grafana to run for us here. All right. And again, this is a whole like presentation that I did, and other stuff like that, and you can go find that. I think that's somewhere online. I think it's definitely on YouTube somewhere, but it's definitely down in the Discord if you guys want it. So yeah, Robedom, I'm a big fan of having some. I mean, if you have nothing on your resume, have something there. I did a project where we monitored everything in Linux, and while I don't know everything, I do know how to monitor stuff. Somebody might hire you as a junior and throw you in on their Grafana system and say, try to make it better, right? And then you start asking people down in the Discord, what would you do? And people will help you with that stuff. That's what we do, right? That's what I think people enjoy doing that, So we're gonna do a daemon reload. We're gonna start the server. We're gonna check to make sure that the server is running. It is. And then we're going to make sure that it's sharing on the right ports, which it is not yet. And that makes sense because it takes Grafana a few minutes to come up, a few seconds, probably about 10, 15 seconds. So we're going to give it a few more seconds. And then when we run this again, we're going to see that we're listening on port 3000. That's super important. If we're listening on port 3000, that means that we are ready to move forward with Grafana. Now all of your systems are going to have a different link right here. It's going to be unique to your environment. And when you press it, it's going to drop you into that shell for Open Grafana. So watch right here. It's going to pop up. And we're going to do admin on Grafana and take over this box and change the, we're going to say admin. And we're going to change the password. And the password, something real easy to remember. And now we are in Grafana. We're happy. And we're just going to leave that open. But we have set up that last part of it that looks like this right here for Grafana to be able to monitor from Loki and Promtail for this lab. Okay? All right. Hold on a second here. There we go. All right. Let's move this out of the way. I say check. I move forward. Your team has decided the log aggregator will be a tool called Loki. So we're going to use Loki for this. And Loki looks like this. We're going to make a directory for opt Loki. Opt is a place where we normally put third-party tools and applications on our system. Since Loki is going to exist as a third-party server, it's a third-party application and it's going to be a server, we're going to make a directory for Loki, and we're going to cd in there, and we're going to download a version of Loki that is 2.9.7, and then we're going to make it executable in our environment, right? Now, if you have an executable, you have two other things. Well, in this case, you have two other things you need to be able to run it. You need a config file for it. So we're going to have a config file for it. And then we also need to have a daemon file or a service file, they're .service files, that can be used by systemd. Systemd needs to know how to start it and control it and stuff. So let's go look at first the config file. Here's the config file. I just hit enter on a cat of it. And if we go up here, there's nothing that's different from the original config file that I downloaded. Nothing up here that's different. Port 3100 is going to be our listening port. If we want to use gRPC, we can do that. But we're listening on 127.0.0.1. Cool. And then we come down here, and we don't change anything else in here, except we turn off the reporting enabled. So we don't want this sending. This is our lab environment, so we don't want this sending off to Grafana. There's no reason to do that. So we're just going to turn that to false. That was already set to false by us. And then the other thing is we're going to go look at our service file. And service files sit in etc systemd system with the name, Loki service in this case. And they've got a unit component, a service component, and an install. And the start of this is super simple. It calls opt Loki and the executable. And then it calls the config file option for the config file that we just looked at. That's it. Nothing else going on. If that's all there, we should be able to do a reload of the daemon, which we did, and then we should be able to enable and start the service, and then go see that the service is listening on port 3100. Cool. If we did those two things, we now have Grafana working over here, and we have Loki working right here. Now we need to feed data into Loki so that Grafana can pull it out of Loki. That's what we need to do, right? So we hit check. Come over here. In your research, you found that Promtail tool can push logs over to Loki in real time. Cool. Your task will be to deploy and configure Promtail to push logs into your Loki server. Now, out of the box, Promtail is set to work with Red Hat. So we had to modify the configuration a little bit to work with the different log formats that we care about. The log files are different in Ubuntu than they are in Red Hat. So let's go look at that real quick. So we made a directory opt Promtail. We cd'd into opt Promtail. And we download the package for 2.7.1 Promtail, right? And it should be that when we unzip it, it's got the file right here, and it is already executable. Yep, there's our Promtail already executable. And we're going to copy in a local config file for it, and then we're going to look at that config file. So we copied it from our answers file that I made. And all of these things are the default up here. If we were going to send them from here to a different server, we would change this IP address right here. But the port number, 3100, would not change unless we change the port number for some reason. And the Loki API v1 push would also not change unless we had dramatically changed something in our environment. That's the default API, right? Come down here, there's two scrape configs that are very important. We're going to scrape our varlog syslog, which is a default logging. It's like our messages in Red Hat, but that's how Ubuntu does all of our system logging. And then auth log, varlog auth log, is how we do all of our auth or anything that deals with users trying to log in or creating users, any of that kind of stuff. So we're going to do this in our environment. And we've got that set right. So now we're going to go ahead and copy in a service file. And the service file is very similar to the other service file. It's just calling the executable against that config file. It's complex at first, but as you guys start doing this, you're like, oh, that's all it is. I just make this thing look like this thing. It's all chutes and ladders. Everything points at everything. It becomes a lot easier as you keep doing it, right? But once you see it work once, you can modify it for your environment, right? That's the important thing. When you see what's important about this, that's when you go, aha, I could modify that to work with Loki in my dev environment. Yeah, it's easy. I think you guys can do that. I'm cutting a childproof container of legal adult flowers with a dangerous utility razor. Hayes, I had a friend in school. We were cutting frogs in 7th grade. My buddy Joey. I have a few friends named Joey, so I'm not saying exactly which one, but we were cutting frogs, and I don't know if you guys remember cutting frogs with scalpels. And they were dead, right? But we were like opening them up and looking at the insides of a frog. But does anybody here remember cutting them with scalpel? Yeah, did it? No blood this time. Okay, no blood for you. Joey definitely got some blood. Do you guys remember, like, I mean, I don't know what it was about these stupid X-Acto knives, but I thought mine was dull too, because like you would go in to cut like parts of the frog and like I don't know, and it just didn't work well. Like you'd go cut like one of the tendons on its leg or something, it would just be like, and it wouldn't cut it. So Joey was like, this thing's not even sharp, and he went, and his hand just opened up. It was brutal. We were in like 7th grade, and he was like, and I was like, you better hold that, and it had like formaldehyde all over it and stuff, and I was like, you better go to the nurse with that crap. But yeah, we did frogs. We did frogs in 7th grade. I remember doing owls in like either 9th or 10th grade. We did owl pellets, so like owls had eaten whatever. I don't remember doing cow hearts, but yeah, I mean we had frogs readily available, so we did frogs. But anyways, yeah, it did not seem very sharp, and then I remember he cut himself pretty good with it. But then he also, another time, same Joey, he was stabbing an X-Acto knife down into glue to try to open the top of the glue, and he stabbed it and he sliced his finger right open. We're like, God damn, you can't have knives. Anyways, let's do a daemon reload on that service and check to see that the service is running. We see that the service is running on our box. Cool. So now, we've put all the pieces together, guys. If we look at what we just did, we put Grafana on a system. Then we put Loki. Then we told Promtail to send stuff to Loki. So stuff should be getting sent over there right now from our boxes. Area 51 summer camp. That's funny. That's actually pretty good. So we come over here, and we're gonna create a dashboard. But we're gonna use an existing one, guys. We're not gonna make stuff from scratch here. But let's go look at what we need to do. So we need to make a connection, right? And the connection is Loki. We know we want Loki. That's the tool we're using, right? We're going to connect to Loki. So we're going to configure that as a data source. We're going to say Loki. We could call it Loki Prolog, right? We can call it whatever we want. But down here, it needs to be 127.0.0.1 on port 3100, because that's what port we're using for Loki. That is configurable if you only had certain ranges that were allowed in your environment, or you wanted to do certain things. Hayes Anderson, you know what I watched the other day, Hayes, was I rewatched Cowboys versus Aliens, and that was a fine movie for what it was, right? Like, I mean, I'm sure I told my wife it was terrible, but I tell my wife all the movies are terrible, but it was a fine movie for what it was, right? It was Daniel Craig and a bunch of aliens and a bunch of cowboys, and had like all the archetypes of like villains of the West and good guys, and good guy that doesn't remember that he's a bad guy, and amnesia and all that stuff. It was like all the things you need. And then it was powerful guns and stuff stuck on his arm. It was fun. It was a pretty fun little dumb movie. Anyway, so we got this. One of my favorite things, guys, about Grafana is when I hit save and test, it will tell me, hey, yeah, I connected to that data source. That's cool. What we have not done in this lab that we are going to do in future labs is we are going to use TLS. So we're going to connect only to things that are allowed to connect, and we are only going to allow things to read from Loki that should. And I think that'll be a fun lab. I just haven't gotten around to building it yet, but we will do it one of these days. But we can set a different type of authentication if we want as well right? But TLS is going to be an important one, because then we can say we have set up a zero trust monitoring solution where logs are being sent over TLS to this server. Logs are only being read via TLS, so meaning that nobody else could get on our network and eavesdrop, because Loki does exist as an open API as it is. So that's an important thing to know. That movie was also directed by Jon Favreau. Nice. It was fine for what it was, for sure. All right, so we've saved that. We're going to come back here and we're going to make a dashboard. And the way we're going to make it is by importing something. Again, stealing is better than starting from scratch. And we're going to paste that dashboard that we found on the web, but I gave you guys the name of the dashboard. It's right here. There's the 13639. And we're going to say, yeah, go ahead and select that Loki data source, because it's a Loki-based dashboard. And immediately we have the auth and the syslog. So I can go right here to syslog. Watch this. And I can change my refresh to every 10 seconds. And I can come back to this lab. And on this box, I can say while, let's just say for user, we'll say for I in, and we're going to do sequence, and we'll go 1 to 100, right? Do echo I am creating user $I. Done, right? So boom, that'll do that. And then we're actually going to create the users. So now it's going to create the user 1, create the user 2, create the user 3. Those logs are going into varlog auth on the system. And then we come over here and we're watching this reboot, restart, and I go to auth log here, and I start to see those users being created in my logging. And maybe I want to track them, and maybe I want to see. It was no swingers. We were talking about swingers earlier, Hayes, because I was saying something about I was talking about Jon Favreau for something. What was I talking about him for? Oh, remember the scene in Swingers where the girl gives him his phone number and then he calls her like 300 times that night? And I was talking about like messages, when you call and leave a message, and if you told somebody to reboot a server or something, even if they got 30 messages, they wouldn't probably reboot it 30 times. They would just do it the one. You're so money. You're so money and you don't even know it. That's Vince Vaughn's like main line in that movie. He keeps telling Jon Favreau, you're so money. You're so money and you don't even know it. Because like Favreau's having a real hard time with it. I think his girlfriend broke up with him, so they go to like Atlantic City or Vegas or something like that. I don't remember exactly where they go. But all right, anyways, so over here, guys, look, we're watching those users get created, and over here we're seeing them being created via this loop. But that's going into the varlog auth log, and then that varlog auth log is being scraped by Promtail, going to Loki. Loki is being pulled. That information is being pulled out of there into Grafana and being presented to us like this in the dashboard. I could also look for a string match to see certain things that are happening or not happening in my labs. It was Vegas, yeah, you're right. Been a long time since I saw that movie. That movie's like probably what, late 90s, early 2000s, if even. That's an old one. Old. You know what I did watch last night that was kind of fun? Me and the wife a couple weeks ago, we went over and saw a play called the Scarlet Pimpernel. And you might go, what the hell is a pumper? It's Pimpernel. It's Pimpernel. And you might say, what the hell is that? What the hell's a Scarlet Pimpernel? Well, it's a play. It's also a movie. It's also about 15 different books from the early 1900s. It is also the basis of the story that both Zorro and Batman are based on. And you say, Zorro and Batman? What the hell? Well, Zorro was a nobleman who fought for the common people, right? Against like unjust magistrates. Batman was this guy. But in all cases, nobody ever suspected the main person of being the hero, right? Yes, Scarface Pimpernel. Man, I'll tell you what, it's a lot like Scarface. I mean, the guy is, it's like got sword fights, and he's like kicking people's asses, and he's like saving people from the guillotine, right? The guillotine was employed in France quite a bit in the late 17, it's set in 1798. But my point is, the character is never suspected. Oh my God. First off, my wife wants me to dress up as this guy. Second off, the way he acts is so funny in the movies and in the book and all that stuff is, to not be detected, he makes everybody think he's very foolish. And he's got this saying that he keeps saying, and me and the wife were saying it to each other all yesterday. It's "sync me," so it's like it means like oh behave, or like you remember how Austin Powers was always shouting "oh behave," right? It's kind of like that, like almost like you can't believe or you're incredulous. It's ridiculous. But then he's got this little, like it's on like a stick, like an eyepiece, and he's always like looking at stuff. And he just acts like an absolute fool. But yeah, it's "sync me," and he's also very much like, and you know, just because of the times, right? He was also very, very foppish, and he wore like very bright colors, and he was very giddy and like. But that was not him in real life. Like when everybody left and it was just him and his men, he was all business. He was all action. So it was. But it's the story of is from like 1905, and then like Zorro was written 15 years later, I think, and the first Batman novel came out in like 1929. So all those characters are basically, I wouldn't say directly stolen, but the scenarios are exactly the same. Like everything that you think is original from like Batman and stuff comes from those stories. It's really interesting. It's really well done too. Getting two birds stoned in a bush. Yeah. But he's like, "sync me," and then he can sword fight and he can do all this other stuff. But you would never know it by looking at him because of how he acts. And it's all carefully crafted. And it's even like there's some interesting things. Like it causes a lot of stuff between him and his wife because she doesn't know that he's the Scarlet. You know, it's the Scarlet Pimpernel. That's how you say it. But I was saying it so wrong yesterday, so long that I can't even say it right now. The wife heard me say, because she was getting mad that I kept saying it wrong, like the Scarlet Pumpernickel and the I was just saying it wrong. I got in a sword fight once. You died. Yep. So guys, let's review what we did, because this is important. If you're like Scott, I want to be able to show a company that I can do this stuff. I just did the lab, and the lab worked or mildly worked or got close to working. Maybe you need to do it again. Maybe you need to play with it a little bit. But the point is, and these are look, that's the same exact thing I have in my home lab. That's the same exact thing that I use in my home lab for everybody logging in, or like LS, as somebody did. I think Robodon did LS, right? Oh, he might have done it while we were not. I think I might have had it off. It's back on, so if you guys did an LS, it would do it again. But, yeah, what did you do? You go back here. You look at it. Sometimes it's useful to look at stuff from a high level. Your team wanted to offload all your logs in your environment. The net effect of that was going to be Promtail agent pushing logs, authlog and syslog, into Loki, and then your Grafana monitoring was going to pull those logs out. Then the question might be, well, what if I wanted to use the logs from Apache that we did in the other lab, and then I wanted to feed them into Loki? Well, I would have to modify the config for the Promtail agent and restart it. Then I would need to set the Grafana monitoring to pull those from Loki, which would just automatically happen as long as it was going into Loki. And then you could change your monitoring to track that as well. So you can do all of this stuff. You could track all of these things. Yeah, Robodon, it doesn't look like it executed, though. I don't see your LS executing. I see Colkiss's command executing. Oh, wait, you did LS earlier. Let me see. Oh. Not popping up. Didn't show up. All right. So that's that whole lab there, guys. That's the whole thing. So we keep going down, right? And this is the third version of this. So if you guys are watching this on Twitch or YouTube, and you're like, oh man, like he started off and he was down here. We did all the other labs in the other ones, right? We started at the beginning of all these labs, but now we're all the way down to, we just did the Promtail. We're gonna do Grafana monitoring of telemetry data with Prometheus and Node Exporter. So this next lab, the other ones have unpinned themselves, I believe. So I'm just going to drop these here if anybody wants to do this lab with me. And this lab starts the same way. Your team has determined they need to monitor telemetry in your environment. You know that Grafana can do that as a visualization tool, so you plan on adding it to the server. So we're going to start with Grafana. We can close this one because that's an old one. And I'll make this a little bigger for you guys. But we're going to blow through the first part of this. But now we're going to do Grafana, Prometheus, and Node Exporter. These are going to be the component pieces that we do right here. Okay. So, let's start it. Here's our solution. We install transport and we install software properties so that those two requirements are there. We're going to download the keyring for Grafana. It's all the same stuff we just did, but it's good to practice. And then we're going to build the repo for Grafana and tell it to go look at that keyring. And then we're going to install Grafana Enterprise in our system. Robdom, I appreciate you showing people over on the YouTube side, the do all the Linux site. Yeah, we've been making more stuff for that. Me and the wife have been messing around with that a little bit. We've got more ideas for that. We need to keep updating the labs and the stuff over there. I need to make a nice little one for Ranger, right? Like Ranger will be like the patron saint of, what is it? Patron saint of something. We need to figure out what Ranger would be. Oh, Robodom, you're still drinking out of the Linux mug? Nice. Yeah. Okay, so we've installed Grafana. Now we go and we do a daemon reload. We look at the server, and we make sure that it's running. And when we run this, we're not going to see it listening yet for 3000. We talked about this earlier. It takes 10 seconds or so to kind of start up. It's like an old Oldsmobile. Like, it takes a little while. But now it's listening on port 3000. And your lab will have its link correctly to your device. So here it is. And then we're going to get in there and we're going to do admin. Actually, I did make a new one of these the other day. There. Yeah, just the do all the Linux. Just a big old do all the Linux lab. Just a desk mat. I thought that was kind of fun. Do all the Linux. All right. Yeah, I thought that one was fun. All right, admin. Change the password here to the right password. Boom. And then now we've got Grafana set up. We're not going to do anything with it yet, but it's set up. So we come back over here to Linux configurations. That part's all done. Feel free to look around the UI and all that kind of stuff. And it says now that we've decided to put all the data for Prometheus, exposing it through the node exporter. So we're going to build that piece first. Node exporter is running and exposing port 9100. So let's go over and make a directory for node exporter. We'll cd over in there. And then we're going to download node exporter and run it in our environment. So now we've got this node exporter that's executable in our environment. Right? It's executable. So we're going to copy the service file for it over into services, and then we'll cat out that service file, and it says we're using opt node exporter 1.50. That's right there, Linux node exporter, and it doesn't need a config file. It's just going to expose the service, so that's fine. We'll do a daemon reload and start up the service, and now if we go and we look, we should see that it's running, and then we should see that it is shared out all of the service on when we look curl HTTP localhost 9100/metrics. It is properly showing and squeezing up all the metrics from the server on a web page that can then be scraped by Prometheus. I say, what data can you see exposed? Don't worry if it's not well formatted, it's fine. Let's look at it and we can maybe grep for memory. Maybe I just want to see memory stuff. Look at all this cool memory data that's coming out of there. I don't know what all that means yet, but I know that we have it now. And we can start to scrape it with Prometheus and start to look at what's going on with the system. Robdom, that, yeah. Oh, is the mug, hold on, is the mug being shown? Is that the mug you have, the pseudo one, Robodom, or what's the mug you have? I forget which one you got. In the collections, I think it's under Office. You got the Linux is the way one, don't you? Yeah. Well, you got, I mean, you guys are, or you might have do all the Linux one. I forget. Yeah, we have dumb stuff. Like, it's really just made for people that want to, have something to think about doing all the Linux, right? Well, I'm definitely going to make some stuff up for us, Robodom, before we go to the Scale Expo. Oh, by the way, we need to make sure we're ready for that. When is Scale Expo Cali? When is that coming up? So they only have the old one. They don't have the new one up yet, right? they have 23 up yet, Robodom? Okay, when they make the formal announcement, I'll put in a talk this year, Robodom. Robodom's been telling me to talk it the last 2 years, and I just haven't put in. So I'm definitely going to do it for this next one. But scale's going to be, we're going to meet up there because we're always talking about going to that, and Robodom's been volunteering at that one for a while. So. Do they have the one for next year yet? No. 2002. They've been doing this thing a while. Pasadena. They've been at the Pasadena Conference Center. Okay. Okay. We'll figure it out, Robodom. I think that'd be cool. All right. So let's keep going forward. And then in our research, we find that Prometheus can be in between these two. It can read the telemetry data from Node Exporter, and then it can have it read from Grafana. So it, like, Prometheus fits perfectly right in here where it's going to pull data, right? P-U-L-L or P-O-L-L. It does both, technically. From Node Exporter, it's going to pull that data. Scraping it is what it calls it. And then Grafana is going to come in and query it and build its little web pages on what's going on in our environment. So we have all these pieces here where now we just need to get this piece in here. So we're going to make a user for Prometheus. We're going to make a directory for Prometheus. And then we're going to... What's going on with my environment? My environment looks a little weird. We're going to download Prometheus and extract it into that environment. Right? That's what this all does. We're going to give ownership to that directory to the Prometheus user that we've created. And then we're going to make another directory for Prometheus and copy in our little config file. And then we're going to look at that config file. And really the only thing that we change is we have it scraping the Prometheus node right here as 9100. So we're scraping Node Exporter right here. We're going to copy in the Prometheus service, and that is going to show us a little bit more complex service file than our other ones. In that, when we do our start, Prometheus is going to be told where its config file is and where its storage time series database path is going to be. Varlib Prometheus. Sometimes people use shared storage so that it can be out there away from the base system. You can do all kinds of things with this. And then the web console templates, that kind of stuff. And then web console libraries. If any of this is messed up, this is going to break all over the place. So just make sure that if you change your paths, you have the ownership correct to the owner Prometheus, because that's the user. It's not root anymore. We're running this as the user Prometheus, because if anybody compromises our Prometheus service, this is just a user that exists but does not have any permissions to sudo up or do anything. Okay, so that's important to understand. It doesn't have any permissions. All right, so we're going to start the daemon, make sure it works, and then we'll go and look, and we see that Prometheus is running on our system. It's exactly what we need. Now we've got all the pieces there. Prometheus is going to scrape our Node Exporter. We're going to set up Grafana to read from Prometheus, and all that's going to be happy. We can look at Prometheus right here as a time series database. And what I might tell you is if you said, Scott, hold on, full stop, I want to get better at Prometheus, but I don't know how. Well, I would tell you to come over here, and there's a tool here called Prom Labs has the PromQL cheat sheet. I'll link this to you guys that want to do it. And the cool thing about this cheat sheet is this. You can go find any of these things like node CPU seconds in total, and they will drop you in their own instance of Prometheus with that query. But now that you know that query is a thing, you can come back to your instance of Prometheus, right? And you can drop that in there and go, oh, that's cool. I can see them on my local host node. I don't have to be over here in this instance. This is an instance they let you hit, right? And then you can start to go, okay, well, I just wanted to see the CPU 0 mode idle, so I want to grab this and I want to query this in our lab. And now I start to understand how we can do from the node CPU seconds total, I can do only one CPU and only when the mode is idle. So I am using labels to target down data that's more close to what I want to look at. That's useful, guys. It's very powerful too, right? As a systems, if you're going to be building dashboards and monitoring dashboards, what data are available for us, and then where do we get it and how do we query it? Okay. These queries you could then use in your Grafana, but we're gonna use a default one. We're gonna use a default, and we're gonna get everything from Node Exporter out. And it's gonna be, guys, it's gonna be an overflow of data. We're gonna have too much data here in a second, and we may have to carve it down to only useful data. But first, we got to get it all flowing, right? It's like anything. Once you get the data flowing, then you can worry about paring it down to the least thing. So, what does the last lab say for us to do? We've got all that there. You've set up all the pieces. Now we have to create a dashboard in Grafana. We are going to use the dashboard 159. It's been around a long time. And we're going to point to our Prometheus data source on 9090. So let's go in here. Let's say connections. Set up a data source for Prometheus. Right? Because, well, if we're using Prometheus, we got to use Prometheus. I almost feel like that doesn't need to be said, but I'm saying it just because hopefully if anybody was going to trip up on it, they won't. Prometheus is what we need to read for Prometheus, so we'll add a new data source. Prometheus, we can call it Prometheus Prolog. This is our name of it. It doesn't matter. And then down here, we're going to say 127.0.0.1 on port 9090. That is the right port. If Prometheus was somewhere else in our environment, we would point somewhere else. If we had TLS and certs and stuff set up, we would have to point to that. And this is one of my favorite things. When we hit save and test, it'll tell us if it hit the Prometheus API and worked. That's awesome. So now that's good. We'll go to our dashboards. We'll say a new imported dashboard. And we're going to use 159 because that's one that we found before that we know should work with Prometheus. Now, name could be Prometheus System, sure. And the link is our Prometheus plug. That's our data. Then we set import. And look at all this tasty information for the last 15 minutes in our environment. Look at all this information. If I wanted to, I can grab this and make it even bigger. Our system's been up 1.3 hours. It's got that many virtual CPUs. It's got 45% of its memory available. Here's its CPU usage and some other stuff. See how much of its network is being used. I can see all kinds of cool things about it, right? Move this back over here so it's just on the environment like we want. Boom. Okay, that's pretty good. Change the refresh if we want. We can change the time. It doesn't really make sense to be watching it for the last hour or last 6 hours if we've only been monitoring for the last 15 minutes. But over time, this will start to be really useful, right? And then we can come back over here and we can do all kinds of stuff with this now. We can then we can close the PromQL. This is an awesome. This site is so good for understanding the types of queries and histograms and all these other types of things. But maybe I come back over here and I clear this up. Right? And I come back over here and I say, okay, well, I want to find... what might I want to do over here? Oh, let's watch this and let's make the refresh every 5 seconds. So this will be a pretty good refresh. And let's go over here and let's just say apt-y install stress. So we're going to get this package stress on our system. Stress is awesome. And we say nproc, and we see that there's only one CPU. So we're going to say stress -c, so CPU. We're going to pretend there's 4 CPUs in this. And we're going to stress it for a time of, let's say, 300 seconds. So that's going to be 5 minutes of this system getting super stressed. Super high amped up load. And let's see what happens to our system right here. Also remember, the system we're loading is the same system that's acting as all the other components. So it will lag a little bit. That would not be true in the enterprise. You would typically have Grafana separate from Prometheus. Prometheus and Node Exporter would be separate from the individual devices that are actually doing the load. So we would not experience the same type of lag that we might experience on this dashboard right now. But no, this node's getting hammered right now. You're seeing the 5, and the 15-minute load averages over here. 1, 5, and 15-minute load averages of this box. The 1-minute load average is going to shoot up the highest and the fastest because that is the smallest window of time that's being looked at. So the 1 has a spike in it, so the 1-minute average is about to be full of time under load. The 5 and the 15 are not experiencing the same load as an average across them, so they're going to take longer to get up there. they're also going to take longer to load back down at the end. So we're seeing massive CPU usage, way less idle. There's very little idle, very low wait, but we're seeing our system massively spike up right here around everything that's kind of going on in our cluster here. So look at that. We just leave it run for a little bit. Then we're going to see it after 5 minutes. It'll stop, and the system will all go back down to chilling and kind of just hanging out. RAM available. Oh, did it break? I don't think it broke. Nope, still running. Okay. We should see it for, that was from 10:54 all the way up to about 10:59. Should be running all the way up. We should see high CPU load average the whole way, and then we should see it all drain out. So we can just sit here and watch the system under load. We could go try to figure out what's going on with it. In our case, we know what happened to it, but the point is we see an incident occurring. We see some high load on one of our servers, and we start to ask ourselves why. We go look at connections that are happening. We go look at work, maybe use the command top to see what's the high workload. You can also use other tools like atop or htop to find what's using the most memory. I'm a big fan of using like SS to see what's connected in and out of your system. That's a good one. SS is it came after netstat, so netstat also works, but a lot of times, like in modern Linux, it's not always there. You're not always going to see netstat anymore. SS is always there though. All right. I'm going to keep watching. I mean, look, the load just keeps going up on that box. But the 1 minute load average will always spike higher than the 5 or the 15, especially over a 5 minute incident that's about to happen. You might start to see, right at about the time that we hit 5 minutes, you may see 1 and 5 starting to converge. So these two lines might converge right at that time, because they'll have the same size window at that point. We'll see. I think it'll be pretty close. 15 will still be much lower because it won't have existed for the whole 15-minute window. And then it'll immediately start draining out. So you're going to find more gradual slopes for the 5 and the 15 because they're not experiencing the same window average as the other stuff. It should still be running. Yep. Let me get this back to spinning. But yeah, that's a lot of our monitoring labs do this kind of stuff. In the security course, we dig more into some of the monitoring stuff and when we send alerts and that kind of stuff. So if you guys have ever been in our Discord and seen like in the sandbox channel, you go down in like our sandbox channel and people are like throwing alerts in there, then you'll see that that's actually when people are doing some of the labs that we have. And you can get a hold of a webhook that'll throw stuff in here, right? It'll throw stuff in only this one channel. But then you can see when Grafana's firing for, in that case, we're using a tool called fail to ban. And whenever you have a failure and a locked out IP address, it triggers an alert. So that, and by the way, that would very quickly be way too chirpy. So we would probably turn it off. But that is a good thing to kind of understand. Oh yeah, and they're still down there. I forgot, guys. They're still down there doing the Bash study group. So you guys are welcome to go hang out down there. And I highly advise you guys spend time with the other engineers that are doing the same stuff as you, maybe. And look, there's the end of our load average. So our load, it's finished. We see that. Come over here, and you see the end of that time. So if somebody were to say, hey, there was an incident for about 5 minutes today at this time, do you see anything happening? Yeah, I see a really high load on this one box for sure. Maybe other boxes too if I was kind of looking at it. Yeah, Robodom, I think it's pretty cool. Like, Robodom, I've always wanted people in the environment. I tell people all the time, this isn't the Scott show. It's not supposed to be the Scott show. It's supposed to be all the different members that we have that are doing these things and getting into these spaces. I'm trying to get people to like be, I don't want to say like be the leaders, but I want people to work in these spaces, right? Like the guys that have done it and gone before, to show the next generation kind of what we're doing and how some of this stuff works. So that's yeah, that's kind of the goal of a lot of this stuff, get people into doing it. All right, so when we're done with that lab, we could start closing these components out. I think that that's an excellent way to see this right here. So what you just saw in that lab was the build out of Grafana with Prometheus with Node Exporter, right? So what I might do is I might just skip the Telegraph InfluxDB and Grafana one, because I think most of you can probably figure that out. And if you needed more help with it, you know, we got plenty of videos on it, and also, you know, you can talk to me down in the Discord about it if you want. But we'll probably run that one another time, because I've done these labs many times over the years for you guys and showed you guys how they all worked. But let's go jump over here. Let's go to another one. We'll jump past that lab, right? We'll jump past it and go a little further down. And let's see where we're going to. What's our next one? So we did NFS, Apache, Grafana. We're going to get down to some of the the last of our few little configuration ones here before we get down into and we got failed to man monitor. So this is some of our security engineering stuff, right? We're starting to get into this is still configuration stuff here, and then we start getting into some of our security engineering stuff. So yeah, let's do our Clam antivirus on Linux, and we'll go work on that. I will link this one to you guys real quick. So here is Clam antivirus and Linux. I think this is a fun one. You may in your career have to put antivirus of some type on your Linux boxes. I remember over the years we tried to fight it. We always pushed back on it, and then the PCI DSS standard was changed. They went to like version 4 of the standard, and it was changed. And when they did that, it kind of forced it all on Linux boxes anyways. It used to read, the standard used to read, on systems that are vulnerable or susceptible to viruses, you must have antivirus running. Well, we used to always argue that Linux wasn't highly susceptible because there's only a few viruses for it out there, and you basically have to put them on the system yourself. Well, you know, right? Or you have to be a privileged user to even get them on the system. So we used to argue that that wasn't that big of a deal. But I digress. We'll go ahead and look at this a little bit. Your team is determined they need to run an antivirus program on your servers. Again, how we got to this decision is not for us to worry about. Your team has to satisfy the PCI DSS requirement, and you've installed or chosen Clam antivirus. Your company's being a little cheaper, so they're using an open source and free version. Or maybe they plan on testing it. A lot of times we'll test it, and then we'll think, oh, okay, Clam antivirus does have a support model through Cisco, who bought them. Cisco owns them. If you guys didn't know that, they do. And you can see it at the bottom of the web page. And we are going to install Clam antivirus for Ubuntu and then get it running. So let's just install it. app-get, I don't even know why I have a -git in there. But we're just going to update everything. And then we're going to install Clam antivirus and Clam antivirus daemon. So we're going to get that on the system. Just install it. Make sure it has all the links. It's going to install Fresh Clam and some of these other tools. Okay, good. And then we're going to say which Clam scan and which Fresh Clam are on our system. We do have those tools. So now we have a Clam scan antivirus, and Fresh Clam is your signature database updater. So some of you guys know, but as a general rule, there's two ways that antivirus works. As a general rule, there's two ways that it works. One is by signature scanning. Does everybody know what signature scanning is? It would be like, well, this virus looks kind of like this and has these executable names and has this file structure, and that is a signature that we can look for with our scanning tool for these executables. And if we find that executable, we just flag it and pull it out of the system. That is what we call signature scanning. Signature scanning can look at the size of binaries. It can look at the names of binaries. It can look at the size of tarball images that haven't even been taken apart yet, and it can use checksums and hashes, and it can do all kinds of things to look for things that look like a virus. Okay, so that's one thing. Then the other way that we scan things, which most free antiviruses don't do and ClamScan does not, is like heuristic or statistical scanning, where it looks for things that are anomalous in such a way that like either a person couldn't do them, or they're trying to do things or access things on the system that they shouldn't, or they try to install themselves or do other things or talk to things that they shouldn't. There's all these other things, but that's like more heuristic and behavior scanning, right? So those are the two ways that we do it. The most common by far is signature scanning, by far and in a way the biggest. The other one is very hard to define. Like what does bad behavior look like from a program, right? Well, that's a lot of things, right? So anyway, so that one you pay specialized tools for, right? That's not a normal scanner, right? A scanner that's free and open source is going to be a signature scanner. But ClamAV does run like I think 8.6 or 8.7 million signatures, so they've found a lot of crap on the web. And also, just don't think because something is 30 years old that it's not still floating out there. It may be inert, but I guarantee you people still have it for lab work. I've put stuff into lab environments before that is like every virus that some buddy has ever seen or whatever, and we've released that in like lab environments in college and stuff. I remember doing that. This is not something that isn't available for us to do if we want to, and it's not something that you may always be inoculated against. Your system you may get a brand new somebody puts an ISO from like CentOS 7 to be funny on the system and it's completely unpatched. And you better hope that's like in a lab environment that doesn't get scanned by something, right? Anyways, all right, so we're talking about antivirus. Let's stop the fresh clam service. So we make sure it was running, and it was running, and then we're going to stop it. And the reason we're stopping it is because we want to run fresh clam by ourselves. And when we run fresh clam by ourselves, we get this little bit of an output here. That's kind of nice to see. And we see the daily database is up to date. And it has a bunch of signatures. The main database is up to date, and it's got that's like 6.6 million virus signatures. I thought it was 8 something, but it looks like it's 6.6, almost 6.5 million signatures. And then it's got these byte codes. The byte codes haven't changed much since I started using this tool, but it looks like there's 83 signatures of what the byte code things may look like. But again, these are all signature databases. That's what all of these things are. There's a daily one. There is a main one that's probably codified down, and then there are 83 or so, bytecode ones. So this is going to scan and look for stuff. And now we can turn the service back on. We'll let that go. This is a lab, so the server dies after we're done with it anyways. But let's say we wanted to scan. We're going to use a time command around clam scan to look for infected and remove any infected files. We're going to recursively go down into the etc directory, which is mostly just config files and flat files. I think there's like 1,700 files in there. And we're going to log it out to var log clamav.log. That's what we're going to do. All right, so let's run it. That was weird. The music, you guys probably didn't hear that. The music just had like a sound of a rusty old door opening and closing. That was freaking weird. All right, let's go find some... Let's find something more fun. I'm listening to chill guitars right now, but let's go find like... You know what ones I like, but I don't think everybody else always likes them? I like Spooky. Let's see if Spooky's any good. I don't really listen to music when I work, guys. I only listen to music when I stream because I think it's fun. All right, look at this. This is a cool little scan summary. Known viruses. So we do have 8.7 million known viruses. The scan engine right here was engine version 1.43, so here's information that we might need. We scanned 273 directories. We had 904 files. Here's all the data we scanned, and we didn't find anything. So one of the things this is very important to think about. If I'm just trusting that ClamAV is doing something, aren't I? I mean, I scanned and it said looks clear. Anybody here ever remember the very first Riddick movie was called Pitch Black? Anybody remember this? Came out in like '99, and he looks in, and remember he's got the eyes that can see in the dark. So he looks in, and the guy goes, "Is it clear?" And he goes, "Looks clear." And the guy starts to walk out, and the alien like rushes out and like flies away. And he goes, "I thought you said it was clear." And he said, "I said it looks clear." And he goes, "Well, how's it look now?" And he goes, "Looks clear." Well, what if the antivirus was just doing that shit to us? What if the antivirus wasn't telling us the truth? Yeah, I actually really like that movie, Robodown. I remember I was in the Army basic training when that came out because I got a little pass like at the end of basic training, and I went and watched that. So, like I had like a weekend or something. Like maybe it was a weekend after basic, but before my next school or whatever. Well, where I'm going with this is, what if Clam Antivirus isn't actually doing something? What if we went and did something fun that's not? I actually don't have this in the lab, and the reason I don't have this in the lab is because I didn't want it to trigger. This will trigger antivirus. So let's go to eicar file. So look up this. I'm going to send it to you guys real quick. It's eicar.org, or you can just go find it on Wikipedia. I'm just going to send you guys to Wikipedia, right? If anybody wants to, if anybody's doing this lab with me, go drop into this in Wikipedia and grab this line right here. This is the test string right here. And then I'm just going to go somewhere in my system in Etsy. So I'm going to CD to Etsy. And maybe let's go Etsy apt, right? Maybe that's where I want to go. And then CD down into preferences.d. And I'm going to vi sumfile.bad. It doesn't matter the name. And I'm going to drop that standard antivirus text from eicar in there. So if I cat sumfile.bad, it's going to be that string. Hold on. I didn't mean to turn that back on. Okay. It's going to be that string. Do you guys all see that? Is everybody tracking? We grab this eicar string, and that's an antivirus, trigger. And now I hid that up there, and now I'm tricking. I'm not tricking anything. Let's just CD back to where we were, and let's rerun. Let's CD back to root. Let's rerun our clam AV, and let's see if it finds that file, and let's see if it tells us about it. So this is like, earlier we proved that our system had no viruses, well, if it's working. Now we're going to prove that it does find a positive test that we've put in there, right? So we've set, there is down in that Etsy sources, wherever I put it, Etsy apt sources.list or wherever I was, or preferences.d, it's, oh, it found it right there. So in this scan, it found one infected eicar signature. It doesn't care what the signature was. It found a signature of a virus, so it rips it out of the system. That's very useful. Because what if this was just sitting there? What if this was just sitting there like, oh yeah, we're done. No, we're good. We're good. We scanned all the files. Nothing in there. Oh, that'd be fucking useless. So we wanna put something in there and see that it did what it was gonna do, right? All right, so anyway, so we did that, and we can verify that the file was written out. Yep, look at this. It tells us that it did the things that it said it was going to do. Looks like our logging is there. It looks like we could report out to auditors and show them. Like if there was a PCI requirement to have antivirus on our systems, we could prove that we have an antivirus scan running on our system doing things. So, it's one of these things, we assert things that are true. Like we assert things as security people. But then sometimes we have to also prove the assertion, and that would prove the assertion right there. Right? Unless you're like, well, maybe you faked that. Okay, well then run your own tests, right? You're the auditor. I was asserting it was true to start, and if you believed me, good. But if not, please run your tests. That's what you're here for. You're an auditor, right? We don't argue with them. We just say, well, do it. Let us see our methods between each other. I know that I'm doing something. Now, you can do your thing too, right? And this is the thing we do. It's not combative. It's just, okay, execute your search. So it says we've installed and updated our antivirus. Now it's time to make it run on a schedule. We've got a script that I wrote in answersclamscan.sh. So we're going to execute that script daily. We're going to play with that script a little bit. By the way, I might move back into here, right? And I might go back in here and, oops. I might go back in here and go recopy my eicar, right? I might go put that back in there just for fun, just to make sure that this one also finds something, right? I don't know, maybe I don't trust my own test. I just want to see it happen again, right? Right? So it's in a slightly different location. And now we've got a file that's in answersclamscan.sh, and we can go look at it and see that it's executable now, right? 755 is the permissions. And we can go look at that. And when I originally wrote it back in 2019, I wrote this for a big insurance company I was working for. And I did some very, very simple things. I make a daily log file, and then I have the log file. This would very much be, just so everybody knows, this one right here would very much be like the scratch log file for every day. This one would be the one overwritten every day, if you will. And then this one right here would be the persistent one that slowly moves back in time. Basically, it's like I'm making a log file each day, and one is the scratch that we're doing the work in, and then when we're done, we're going to copy it back to that one. That actually happens down here. Copy the scratch file. If I called that like scratch log file, it would probably be more clear. But daily log file is for retention because it's always going to be one every day going back forever. Does that kind of make sense? And then this one here is going to be the scratch one that we're working on for today. So anyways, we're going to clam scan everything with removing infected and then throw everything that we get out into log file. Then we're going to copy log file to daily log file so we have it. Then we're going to read a bunch of stuff out of there. And normally I would feed this up through like a curl up to InfluxDB, or we could put it in JSON and send it up to like Loki. And then just for fun, we echo it out to the screen with something like this, right? So now it says how many log files are created? 2. What directory or path is being scanned? Root. Execute the script with a timer and see how long it takes. So we would then run this, and it takes between 10 and 15 minutes to run in your environment. So feel free to go grab a drink or do whatever. And then we come down here and we think, how long did the script take to run? What values do you see in the output? Did you find any viruses? Well, we should find at least one signature, right? Set the script to execute daily. How would you do that? Well, that's a cron tab, right? I'll show you that here in a little bit. But this is what we're doing, right? We're setting up this. And I think if I don't have this for an Ansible playbook, that would be a good lab to do with this, where we just use an Ansible playbook to deploy this everywhere and then set it to run and report back to us. That would be super easy to do, right? But again, in the constraints of all the other things we built, this isn't super challenging. Just something that we need to see done, right? Jose Sosa said, "Do I ever worry about log files taking up too much disk space?" I don't, Jose, just because normally my log files are pulled off the servers in real time. And then that storage is the pertinent storage, and then that storage is monitored all the time. Local disk storage of monitoring, we use a tool called log rotate, and we set that to log rotate them off. And then we don't really worry about the logging of a local machine ever again. Once we get data off of a machine, we never really worry about that ever again. That's way too bright. That was way too bright. Hold on. I looked up and it was super bright on the screen. That's better. That's less bright. All right. That's less bright. All right, good. But yeah, we're going to let this run for a little bit, and then maybe I'll take a little walk again, a little break. I'm just kind of wandering around since I'm sitting on my ball chair and getting all this it's like one of those stability balls, so it's like a lot of good core. Let me go to Hourglass. I'll pull that up again, and we'll do like a 10-minute one. That's gonna run for a while anyways, so I'll leave this over here. Break and watch the antivirus run, right? So the antivirus is doing its thing. It's running down there, and we will stop the camera for a few. Robodom, I'm telling you, man, this thing's great. It's actually really good. So, Uday said, "Is this use case we use for daily bash scripts running and saving them for history purposes?" Yeah, sure. I mean, it depends what you're doing, right? I like to send things up in real time to like Loki or something, because you can push stuff directly to Loki. I didn't even show you guys that in that lab, damn it. We might have to go back to a lab for me to show you guys that. But yeah, we have ways to do that. All right, take a little break. I'll be back. Watch your Clam antivirus run if you want. Watch everything else run. I'll be back. All right. Few minutes. Robedom, you gonna get a ball chair? Yeah, I think they're fine, man. I like the stability part of it. I think it's fine for what it is. Not the best thing I've ever owned, but it's fine. Also, Robedom, you probably know this, but I'm leaving town for a week and a half. I'll be down in Mexico next week. I'll be down to Mexico, guys. I'm going to Mexico for wrestling. No tournaments or nothing. Just down there grappling, and then I think we're gonna go check out like Chichen Itza and like some of these other places that are kind of out there. So it's kind of cool. Yeah. I appreciate that, Robedom, the follows, the likes, all that good stuff. You know, I think most people know, but you know, not everybody always knows that stuff. Yeah, I'll be doing wrestling down there, but also just hanging out. I can't. It's funny. The main project I'm on for work, I can't even work on outside of the country because it's a U.S. government thing. So the VPN connection you're not allowed to connect to from outside of the world. Could people do it? Sure, but why would you do that on vacation? I wouldn't do that. And then the only other job I have is my college, so I can teach college from anywhere. So I think I'll be hopping on like one day, but I don't even think I have to teach that night. I think I'm just going to be there for moral support, because if you guys don't know the online modality that I teach for my college with, we have, it'll be these huge classes, but then we'll have like 10 professors and we'll break up all the students into like little cohorts. And then the way it ends up being is we have one on-site, one big meeting. It's all online, but it's one big meeting. So the students can come to the meetings, they can talk, they can, do it like a normal classroom. But then also all of the teachers have huddle hours, so you guys can, or my students can huddle up with me on the weekends and talk shop and work and whatever. But they don't have to just come to mine if they're my students. They can go to any of the courses. So it actually ends up being like you have like 20 hours worth of office time each week with the college professors if you wanted. And I really like it. Yeah, but I try not to work on vacation. But I will still do my teaching stuff. I'll still be running my college classes and stuff. But other than that, I'll just be kind of hanging out down in Mexico for like a week and a half. It's like 10 days or something, so it's not too bad. I've been down there twice before. Well, I've been to Mexico hundreds of times, I think. But yeah, probably over 100 now, yeah. But just because I grew up in Arizona. So it's not that far to go to Mexico. We're pretty close. All right, let's go and when we were younger, excuse me, when you were younger, you could just cross over and come back. Like I even remember going to Mexico when I was like 17. Me and my buddies would just go down there, but it's not really like you can't do that anymore. You have to have a passport and all this other stuff. It's much more locked down as far as that kind of stuff goes. So, all right, there's our EICAR file. It's scanning. It's doing the things. We're ahead of ourselves because it's still going to sit there and run no matter what we do. But what we can do is we can jump over to this other screen while it's waiting. We can go in a new tab, and we're just going to set the cron. So we're going to make sure cron's running. The cron tab runs out of everything that runs with cron has to have the cron daemon up. The cron daemon goes to sleep every minute. It checks between the first and the 5th second of the minute if there's anything to run. So cron is a perfectly fine service for like systems admins and stuff. It's not a great service for like super precise instrumentation for sure. But if, I don't give a shit if something starts at 1:01:05 a.m. or 1:01 exactly. I don't care. But I do care if we have this running. So if I copy that script into etc cron daily and I cd to etc cron.daily, and now I have this clamscan.sh that's going to run. That's going to run at 3:14 a.m. every morning. That's when that kicks in on modern Linux, right? So that's going to run at 3:14. But if I want to set in cron tab, and my editor is going to be 2, we're going to use Vim, and Shift G and O to go to the bottom, I can add in this file. Well, let's copy this and paste. So now at the 0 minute of the first hour of every day, that's every day of the month, of every month of the year, and every day of the week, we're going to run answers clamscan.sh. So that's going to run at 1 a.m. all year. If you ever wonder where you would find that, if you're like, Scott, how the hell do I find that? Well, you have it in Etsy cron tab typically. Typically right there is what all the things are: minute, hour, day of month, and then day of the week, right? Yeah, I think that's what I said. And then here's the things that are in there running in this system. We could comment them out. We're root. We don't need those things running if we don't want. But also you have a pretty good little Wikipedia on that as well. So Wikipedia's got a pretty good little write-up of that as well. And then now if I look at cron tab -L, I see that at that time every morning this should run. That's perfect. That's every morning all year. All right, let's go back over here. And that thing took 10 minutes to finish. And it did not say... Oh. Something killed this. Which is weird. Answers clam scan line 10 killed. They must have something running. Look, hold on. Kind of interested. I'm kind of interested. They have something. There's something on here that must be coming along and killing, or something. Something has killed that process, right? So something killed it at 10 minutes. I've never seen that in this environment before, but we could start to go figure out, I mean, what happened with it, right? I don't know if there was any... Yeah, I said it happened right in here. So, yeah, that normally takes about 15 minutes to run. So something's killing that now. So, we'd have to dig in on what's killing that and why that did the thing it did. Because something killed that specific process and then still let the rest of the cron job run, or the execution that we had ran. The script finished, just that process was killed. So I don't know if there was something else running on this box that I don't know about. Like if they've got something custom that's running to kill things, or things that are long running. You know, is there something that goes in there and tracks it down? We'd have to go look and see if there's anything in here that's doing that. But that wouldn't be, that's not necessarily for now, right? That's not necessarily something that we need to do for right now. Yeah, Robedom. Well, no, Robedom, I am going to go, before I leave, I'm going to have a new published version of the book. So anybody that's got the book already from LeanPub will have the new published version of it. So that'll be awesome. I've added like 10 more labs at least. And maybe I'll build another lab here and then put that in as well. But I'll have the labs up. I need to probably spend like another, I don't know. I already did one pass and made sure it's pretty good. But I want to make like one more pass where I like just look at the book, run through everything. I'll probably even do that maybe even on stream tomorrow. Where I'll just like open it up. We'll do all the labs. I mean, we're going through the labs now. But we'll get that in there. And then I'll publish that new version of it before I leave, because I had meant to do it before July. So I wanted to do it in June, but I have everything all updated and done. We did all the work already. We just have to do that. So, all right. So anyways, we checked this. Look at you learning Linux. You installed an antivirus solution. We did that. We updated signature database. Well, we tried to do that, but then we looked at the signature database so we knew we understood. We set up a logging script on a cron timer so we knew that it would log, and then we made sure... It failed, but it failed because some other new thing in the environment that I don't understand yet. But we could go figure that out eventually, right, if we wanted to. I just don't feel like doing that right now. Continue on to a sandbox to continue. So you can use this as a sandbox and keep playing with that environment if you wanted to. All right. So we've got all these things. We did all this. Let's go to our next lab. So that was 105. I think the next lab is Slurm. And I had questions about Slurm yesterday, specifically kind of around, I think, like what we're doing with it. So... if I was to tell you guys that we were going to build out a HPC cluster, like if we were going to like do all the work to get an HPC cluster running, One of the things we'd have to determine would be the scheduler we wanted to use. And what the scheduler is the idea that, like, if we had one big supercomputer and everybody just had access to it however they wanted willy-nilly, users could log in wherever, they could do whatever they want, we would very quickly have a big old mess. So what we use schedulers for, schedulers are almost like the little turnstiles that let users in, or if you want to think of it as almost like the users stay outside and they send their little jobs, they submit their little jobs, and then they go in through the little turnstiles and get on and run in the supercomputer, and then they get their reports back out and their information out in a way that they can use. That would be, I think, an acceptable way to think about it. And then if the users get clogged up or do dumb shit on this cluster, they're doing it on the login nodes, kind of on the kiosks outside of the main cluster. They're not breaking the main cluster. So a scheduler, like Slurm, is a tool that allows us to submit jobs into an environment and then runs those jobs and gives the output back. Okay, does that kind of make sense? So let's look at like how Slurm might work. We have a Slurm documentation right here if anybody wants it. I think that's the next lab. Whoops, get out of here. I'm pretty sure that's the next lab. Let me just do this and make this will be our official background here so that we have our sound going and all that good stuff. All right. Here. And here. And my stupid terminal at? There's my terminal. Okay. Remember, you guys can still do !clip if you find anything super useful. You guys can do !answer if you want to send something into Linux right here. You can do !ask if you want to ask me questions. That will interrupt me, I assure you. So that's all fair game. Let's go look at the next one we were going to do, which was, okay, so we're going to install Slurm on Linux. So I just want you guys to not think Slurm is something from like Futurama or something, right? With Slurm McKenzie trying to keep us in the party. What was he doing? He was like, he was always partying and he wanted to die because he's never allowed to stop partying. So here's what it says. Your team wants you to set up a POC, a proof of concept around scheduling jobs across multiple nodes. The end goal is running a compute cluster that functions like an HPC cluster, right? So we want to maybe take some smaller set of systems that we have and install Slurm and have the appropriate daemons running. So we need to get Slurm running on a system. So if you've never done that before, that might be a bit complex, but that's what the lab's for. And right here, hold on, what's our music doing? All right, we gotta get out of there. That one's a little bit much. Trying to find good music. We also have chill. I will leave it on spooky for now. Okay. Hey, thanks for the follow, by the way, Larger. Hopefully this stuff's useful to you. We will be working on Slurm now. So the first thing we need to do is update our repository so that we have the most recent version of whatever metadata comes from the provider here, right? Our trusted security. And we're going to go over, on this system, we're going to install Slurm and Slurm control daemon. Is that right? Are we doing it on this node? Okay. Yeah, so we're going to install Slurmd, that's the Slurm daemon, and then Slurm control daemon on our primary controlled node. And then one of the things that's going to get installed with that that's not explicitly called out is a tool called Munge. Munge is a key tool, and it allows us to communicate over other protocols. Munge is useful. You could write your own protocols and use Munge to authenticate them and that kind of stuff if you wanted to. It's just a pre-shared key outside of the normal methods. You can SSH and SCP it and all that kind of stuff. So let's go over to node 01 and install just the Slurm daemon. That's all we need over there. So we SSH to node 01 and installed Slurmd. And then now, just because when we did both of those, we installed them separately, the Munge key is it would have to be different. It was generated on one node and it was generated on the other node. But because we want them to talk, we're going to copy the Munge key from this primary node here over to the other nodes. Typically, if we were running a real cluster and we had a tool like Werewolf would keep the Munge key and it would push it to all provisioned nodes through its provisioning process, which is the easiest way to do this. Revisualize said you're lurking in the background, had a coffee shop. Had to work on NF in your life using ChatGPT as a life coach. Nice. Well, hopefully you're doing it, revisualize. Hopefully everything's working out for you. Well, I mean, I can't give good advice in that space. All I can tell you is just, grit your teeth and work harder and be a better engineer, and hopefully everything falls together, right? But I mean, it's obviously not always going to be the case, and that's not always the best advice. So I don't give life advice, right? Like my best advice I can tell most people is get into Linux, and hopefully it changes your career path, right? Some of you guys are already in Linux though, so then my advice is like, well, don't follow me for advice. That's my. All right. So, anyways, we got to restart the munge daemon, because if you put a new key over there, that doesn't change anything. Let's restart the system over there and let that work. Yeah. I think all my life advice should be with a grain of salt, because honestly, a lot of my stuff has just been try harder, right? And that's not normal advice for people nowadays. So we got munge working, and now we're going to configure Slurm. There's a link, and this link is interesting because it will give you this configuration tool. This configuration tool will be very bright, by the way. I have a dark mode browser, otherwise this would have been very bright. And you could put in a bunch of information here, and it will pop out the very basics of a config for you. So I can submit that, and it will give me the most basic config in all the world. But I don't want that. I already have a config set up for you guys. So we're going to copy in that Slurm. Uh-oh. Uh-oh. My lab's busted. And I think my lab's busted because Slurm has changed in some way. So let's just put it here then. And then we'll go fix the lab. But I think that this is probably just a difference in the way that they do it. We'll go look at the config file. Config file is super simple. I only changed 5 things. I changed the cluster name and the ID of the host that's in charge. That's our control daemon host. So he's the one in charge of all the cluster. Then I changed 3 lines down here. The node name for control plane is one specific set of information. The node name for node 01 is also another one. And then the partition name that work will be done in, and how that kind of looks like, right? Like what that kind of sets up as. Your lab is busted. Yeah. Okay, so hold on real quick. Let's see if this actually will restart. Damn it. I don't know where they have Slurm now. So I swear they've changed all this crap around. So now I need to go fix however this has changed, because it's obviously a newer version, right? And then this is why we check our labs. Slurm is busted here. Yep, that's all changed now. Oh, come on, man. Super annoying. So they're changing, man, they changed all this shit. That's annoying. Super annoying. That's super annoying. All right, so where did they put? So we gotta fix that whole file and that whole path because Etsy default Slurm Control D. Slurm D. Etsy default Slurm D. Ah. So we can do that conf. Alright. Oh, damn it, dash. Oh, well. Okay, so let's go fix our file. This is annoying. No, Robodom, it's the paths. That makes sense. All right. Here's God, that's fucking annoying, man. Really? Varlib slurm. Varlib slurm. And it's actually, there's a directory under each of these, but screw it, I'm not going all the way down that directory. This is going to be my end file. Make sure. Yep. But let's do our copy. Okay, Slurm's running, that's running. So logs are all bad. All right, so I'm going to fix the lab. Hold on. For people who've never seen this before, this is how we fix labs around here. In our... Where the hell's our... Get up here. Linux lab... Slurm... Asset... Slurm.conf. Control A. Control V. And it'll fix that one, that one, that one, that one. We're going to hit Control S. We're going to come back over here. Slurm. Fix Slurm bullshit. And push it. I don't care who can read my my open commits. I don't care. Right? Like, Slurm. That was legitimately Slurm. I never got why, because I use professional, like I use the paid for version of Slurm. I never got why that one was Slurm LLNL or whatever the hell they did. Like, that was like some made up thing. I don't understand. Okay, the lab should be fixed. We're going to give it a minute, though. I'm going to see if it can still go forward with the other stuff. Oh, yeah, look at this. This is... I got to fix that, because that's not going to be real. And then it's just going to be the Slurm, slurm.conf right here. So I need to change that in the lab. And then we'll restart it over there. And then we'll make sure Munge is running, and we'll make sure that that's working over here and over there. Okay, I gotta go fix the lab. I gotta go push one more thing to the lab. Oh, you know, fuck it, we'll just do one more fix here. Hold on. Step 1, text. Our copy is here because it's not. Wait. No, hold on. That's there. And then that is to Slurm. I have no idea where they ever got the -LLNL from. I never understood that. It didn't make a lick of sense to me why they did that shit. But somebody finally wised up over there and got rid. Because like it doesn't make any sense. Like why were you? Anyways, all right. Fixed more Slurm BS. All right, commit, and then sync all the changes up. Okay. That should be right. That should be right. Get rid of this. Get rid of this. Get rid of this. Now we got to fix. This is why we do the labs, right? To fix them every now and then. So if I've done that part, all this other stuff should be. We should be able to show the config. Yep, that's right. Should be able to S control show the config. That's all right. Yes. Sinfo dash. Don't worry if I'm going fast, guys. We're gonna redo this whole lab again. This is what happens when stuff breaks. Okay, partitions are right. We're in a good state. Okay. We can run a host name against it and see a host name. We can run against 2 and see a host name. We can run against 10 and it'll break. We knew that because you don't have 10 nodes. You only have 2 nodes. And then we go and run, we'll cat root submit, which will try to run a job. We'll submit that job and look at the queue. And then we will cat out the result.txt when it's done. So, oh, I've run that too many times now. And then cat our root results.txt, and then there's, now that's something written in there. If I were to just keep doing SQ, we would see that for a little bit, all the way up until that submit got to, what, 1 minute? Oh yeah, there's a sleep 60 on there. Yeah. So after 60 seconds, this one will go away. We'll be almost to the final thing. Oh, what happened? Hold on, revisualize. I've been missing stuff. Sorry. I don't know if you learn Linux is good advice these days. Don't get me wrong. Learning new skills pay bills. The problem is that every even 20 years of IT experience, ops experience, system network, senior enterprise NAS, technical support, been selectively applying for jobs about 800-ish in 14 months and 30-minute screening interviews, then ghosted. Yeah. Revisualize. It's definitely hard for people. I see a lot of people trying to get into this space right now. Oh, this will be gone. Yep, it's all gone. All right, we got to back out of this and redo this lab. So I'm going to redo that whole lab. So if anybody wants to do it with me, you can. But yeah, revisualize. We're just, I don't know, man. It's definitely hard work. Yeah, Quartz. Yeah, Rangers. You know. He's not in pain anymore, so that's good. That's probably the main thing for him. He was in a lot of pain. I took off Ranger Cam earlier because it's just it's just empty now. I'm probably gonna go through. I was going the other day looking at all the Ranger pictures that we have like over the years. I need to make like a little montage for him or something, but. All right, let's try this Slurm lab. Let's see if this lab, now that we fixed it again, should work. I don't know again what Slurm was thinking with their other bullshit. But here's the lab if anybody wants to do it with us. Labs are free up on Killer Coda. Free. Do whatever you guys need with. All right, your company wants to run, your team wants to run Slurm. They want to give people access to run jobs against a set of nodes, but within the parameters that we can kind of define within the cluster. So I can give these partitions, I can give access to only certain slices of the system, I can limit things, and then with one of the other labs that I haven't built yet but I need to, is we can start to audit how much people have used the environment, and that starts to be like a really kind of useful and powerful thing for us, right? So install Slurm and have the appropriate daemons running. So let's see if now this will work. So apt update. And let's install our Slurm. Let's install Slurm over there on node 01. Except we need Slurm control daemon on this node. This is going to be the node running in charge of things. And then over there, Slurm D is just going to be, they used to use the terminology master slave. Now they use main and worker, and there's all kinds of terminology changes in the industry. Just, okay, whatever I have to put into my scripts to make them work right is fine. I don't care, right? So here's our SSH node 01, and it's going to run, it's going to do that. Get rid of that one. We don't need that anymore. That was when we were doing Prometheus earlier. Copy over the munge key. So this is important. The munge keys were generated separately between these two devices, but they must be the same for this to work. So we're going to copy the munge key over there, and then we're going to restart munge over there. And then now we could go generate our own system, but we don't need to generate it. We're going to copy this one into the right place. Go look at it. It should have the right permission, or should have the right values. Now Slurm, yep, these are all right. None of that LLD crap or whatever the hell that was. We're going to copy that over to the other one. We're going to restart Slurm over here, restart Slurm over there. Make sure that munge is talking and working. Good. And then make sure that we're talking and able to see the ports. And if that's working, we should now be able to make sure that Slurm is working between those two nodes. We got all the component pieces up. They've both restarted, they've both checked in, and they're talking to each other. Let's make sure that within the config, we see the things like we expect. So in the config, we'll come up here. A lot of information here. One of the main things is if you ever come to a Slurm configuration that's already set up, you're an admin, you get dropped in, is you can come in here and you can see when it was configured, and you can see most of the things that I care about are like the logging of the system, like where are things happening. And I don't see any of the logs here. So, oh yeah, here's the log. So here's where logging is going to happen on the primary Slurm control daemon node. So if I needed to pull those logs or something, that's where I would go. I would also very, very much, if I was using Prometheus, if I was using Promtail and Loki, this would be something that I would be scraping with Promtail and sending off my system in real time. Again, get the stuff off your system so if anything catastrophic ever happens to your server, you know what happened. You don't want to have to wait. Guys, I'm telling you, you do not want to wait until the server comes back up to get it working, to figure out, like, okay, we got to do all this hardware shit just to turn on the server to see that it did maliciously go down. Oh, and by the way, we just infected everything. That's not a good idea. It's best to have the logs off in real time, and then you know, hey, there were indicators of compromise. We need to bring this up in a quarantined environment before we start it. Go ahead and pull all the networks. I'm going to get in over the console. I'll go ahead and let you guys know in the data center when it's time to plug those devices back in. And you say, well, isn't the console dangerous? Console's not nearly as dangerous I/O and getting stuff in and out as being able to scan and jump around on a network. Console is a totally different type of connection somebody would have to be able to make and understand. And, let's just put it in the realm of it's not impossible, but it would be some real next level. You'd have some real types of enemies on planet Earth if that was the case. So anyways, we can look for just logs. This is the way I like to look at something like this. I just want to see if there's any special logs, if there's, where the normal logs are, that kind of stuff. Got them. And then I come down here and, what happened here? Did I miss anything? So, all right, we'll keep going down here. Where are your logs writing? Why might this be useful? Just because we want to know what's going on with our systems. Right? If we don't have logs, then we don't have much without logs, guys. Also, Quartz, you might notice I'm a little more bouncy today than normal. It's because I'm on I don't have my chair. I'm sitting on like one of those stability balls. I've been using this for like the last 3 or 4 days, and I love it. I told the wife, I was like, I'm going to get one of those because everybody always tells me they get tired in like 15 minutes on them or like 20 minutes. And I'm a wrestler, and I'm like, I bet you I can sit on this thing all day. I've sat on this thing all day for like the last 3 days. I love it. But do I feel it? Oh, absolutely, I feel it. But I was telling the wife, I was like, I bet this would burn a bunch of calories for me because like I'm a wrestler and I like, I like moving around and I wrestle in the mornings. So then I come here, I chill on the other one for like 15 minutes, my normal chair, and then I just hop on this little ball all day. So that's all right. But I mean, I don't have to like bounce around. Tone of those exercise balls. Yeah. It's like a big. I ordered it. It said it was like 400-pound max, and I was like, well, I'm under 400 pounds, so that's good. And then it was like, I don't know, I've just been rolling around on it, and just mostly I can just sit here, but like I'll also like kind of, move around on it or something. I think it's funny. You're not stationary on the ball chair. Yeah, fair enough. I think I'm definitely moving around a lot. So, okay. Now we can go and start running some commands. So sinfo is great for knowing like the number of nodes and what partition are they in by default and what state they have. Now all of this definition of things that we're seeing here comes from our Etsy slurm.conf that we made. And when I first showed this to you guys, I made 5 configuration changes to the base Slurm configuration. Here they are. This is the important things to know if you're ever going to do this for yourself. I changed the cluster name, Prolog cluster. I changed the control daemon host, which is control plane in this environment. You would have to change that in yours. You can change any of this other stuff, but this isn't super important. And down here, there are the node name definition for control plane and node 01. If you are working in a HPC cluster and you have like node 01 through node 100, you do not have to make 100 lines of this. You can wildcard right here with like square brackets and dashes, and it'll count 01 through like 100, right? You also probably would not be using as few CPUs in real memory as I would, but you do need to limit those down to whatever the system configuration is for the actual system that you're working in. And then you can have as many partitions as you want, but only one can be the default, obviously. And then you can put different nodes in there based on, so I have this is a super basic config for me. I have one partition. But a lot of times we'll have stage 1, stage 2, and stage 3 queues where when a server gets busted, if a server throws any type of error and breaks in any way, we immediately move it out of the primary partitions and we move it into stage 1. When it's in stage 1, it is hardware. They're fixing the hardware and stuff. No real jobs work over it, but they can do some burn-in and some testing on their own with their own tools. When we're ready, when they're ready with hardware, they move it up to stage 2 in the queues. We often call these queues, but they're actually partitions. But you'll hear us call them queues in the industry. Then we'll move it to stage 2 partition queue. And by the way, the commands are all SQ, so that's why we call it queues. But we then move it to the like stage 2, and this is just our workflow, but this is one that works across NASA and NOAA and other big companies, like big government stuff. Once it gets stage 2, we do burn-in tests on it. Burn-in tests might take a few hours. Make sure that it's within 5% of the average of all the nodes in the cluster, so that it's not high or low or too fast or too slow, and make sure that it's not indicative of any full RAM being missing or something like that. Whole RAM stick out of, you got 2 terabytes of RAM in a system. You don't want to be high or low on the RAM in that. And you say, did you just say 2 terabytes? Yes. The average node I work with has 2 terabytes or more of RAM. And that's a lot, I know, but that's the average in big supercomputers nowadays. So anyways, you got these big systems doing whatever, so we define it all here, but it can be wildcarded. So anyway, so then we go and we do an sinfo-n, and we see control plane and node 01 are both ready to take work. They're idle. They're not doing anything. So then I run, that would be if there were more errors, and then we go look. There aren't any errors, though. So now we've got everything up. We're going to run a simple job against one node, against both nodes, against many nodes, and watch it break. And then we're going to run a batch job, which is much more the way that we would submit work into the cluster. So I give you a very basic one when we do it. So we would run a command. srun will just run a command against a node. And then maybe I do an srun against 2 nodes. And then, that makes sense because it's both the nodes in the cluster. And then I try to run it against 10 nodes, and that's going to break immediately because, well, it's got to queue up to wait for 10 nodes to come up, but there's not ever going to be 10 nodes. And srun happens in a synchronous fashion, meaning it waits until the execution's done to give you your command back, and we don't want that. We want to do something to move this forward. So did this behave differently than you saw in other commands? Yeah, well, this broke because there wasn't enough hosts, right? So we scroll down a little bit, and here's a way that we would maybe submit a job that we had. So this is just a submit.sh. And then we are going to use bin bash. We're going to give the job name test, and the output is going to go to root result.txt. The partition that we want to use by default is it's a default one, but if we had other ones, we could use them. Prolog. It's got 10 minutes to execute. It's going to run on one system. It's going to be allowed one CPU per task, right? That n task is also how many nodes it can go to. And then how much mem per CPU can it use. So this can't ever overwhelm this for the most part because it can't use very much memory. It's going to do two things. It's going to do srun hostname, and then it's going to sleep for 60 seconds. The dumbest little thing. But then I'm going to run it, and I'm going to do an SQ, and I'm going to see that it's sitting there in our system. And maybe I watch SQ for a little bit, and we can see that system slowly go up to 60 seconds, because that's its sleep time. And then when it's done sleeping, it's going to end that job. That job's going to be finished. And that node is no longer going to be in use, right? And we can kick off all kinds of other things with this, and all kinds of Python and all kinds of different stuff. And then Jones said, did I download that RAM? No. I am familiar with that, though, and that was silly. People were using Gmail, Google storage as like their extended RAM partitions in Linux, and I thought that was silly. But it was funny, but it was silly. All right, can you see the job ID? Sure. Right, job ID. We can make this bigger if we needed it to fit better. And it's gone. It's gone. He's done his task. He's completed whatever he was doing, and he's done. And then what was the output? Well, I can control C this, and I should be able to go look at the results.txt, and all it did was, right, all it did was run a host name and then sleep. So it didn't really have to do anything else. We could make it curl something. We could make it do all kinds of... It can do all kinds of other things, guys. But that's what it does. So look at you learning Slurm. You installed a job scheduler called Slurm. It's a very, very powerful, very common tool inside of high-performance compute. You ran informational commands to see node readiness, and you scheduled simple and batch jobs against the system. Those are very common intro-level admin tasks for that type of tool right there, right? So, all right, where are we at here? Oh man, we're almost at 5 hours. Jeez, where'd the wife go? I think the wife's coming back soon. I better text her. I think she'll be back in a little bit. Okay, so what's our next lab if we were going to start going? I think that's the last one. Yeah, so Slurm on Linux. That's the last one we really have before we pivot over into... so there's that last one there. Semantic versioning, still important. I think that's the last one we go into before we really start to get into a lot of the stuff that goes along with the security. Some of the server startup and Kafka and fail to ban alerting. So this starts to get into the security concepts around this. So I guess our options are we keep going. Let's see what the wife says. See if the wife pops on and tells me. But if she's coming home, maybe her and I are going to hang out. But I did tell her I was going to stream a lot today, so I could just keep streaming. But we'll shift gears a little bit and get into some of the security stuff here if we kind of go that route. Also, real quick, just for fun, let me open up my downloads. Let me pull this over here so I can go grab, my downloads real quick and see if I have, so 617. It's interesting that this is not in open with Chrome. Our actual book here, and I need to see, whoops, nobody's using that, so I'm going to make this a little bigger here. I need to see, or one of the things I need to do as a task for myself is start to go through these process, Kafka to Loki logging. Failed to ban with log monitoring, failed to ban with metric alerting. Okay, so we got all those, and then we got the normal ones. Okay. So I do have to go through that, but I don't know if anybody would be interested in watching that. But this is the actual book, right? That we work through these labs and then get ourselves more time. Basically, as we do the labs, it gives us more things to think about and to work on. But the next one will be the server startup process. So we could sit over here and determine how servers were built, and then figure out all of the information about how the system was started. So maybe we'll do that here in a second. But let's see. Gotta think of what else we're doing. I mean, we gotta clean up all the labs, make sure all the labs are good. Then the other thing I need to work on a little bit, which I probably won't work on today. I think I really want to focus on getting the book out this weekend, so we'll maybe start doing some of that check stuff here and start pulling up those pieces and showing that. And then the other thing I kind of want to do is start working on the Ansible, or it'll be the automation work. And I think I'm going to release that course a little differently. It's still going to be week by week as far as the discussions go, but I think I'm going to have most all of it prepped up front. So I have most everything done, and then it's really just, actually that reminds me of another good thing. I need to get for our Discord here, I need to get the week 13 discussions up. So in our discussion posts here, right, like we only have through 10, 11 for admin. Do they have 12 yet? They should have 12. Man, maybe I got ahead of myself here. Hold on. Where is my... Shoot. Somebody help me out here. What's wrong here? Did we not do 12 last week? Could have sworn we did. June 14th. Yeah, we definitely did one in between here. Thanks, admin. Okay, there's a unit 12 for admin, unit 12 for admin. Okay. Yeah, I switched. I think I pulled the admin part off because it's all admin, but there's all the unit 12 stuff. Okay. All right, so now we got to do the next discussion. So I'll do that real quick here. If you guys never seen this, this is what the discussions look like. So we're in unit 13 this week, right? And they should have them right here. I hope they have them. So here's scenario 1, right? Security comes to you with a discrepancy between the production security baseline and something that is running on one of your servers in production. There are 5 servers in a web cluster and only one of them is showing this behavior. They want you to account for why something is different. So this is the start of our talk around hardening a system. So admin course, we're going to make a new admin. Yep. And the title will be 13. There we go. Unit 1. How would you validate between the two systems? How are you going to look at, what are you going to look at to explain this? And what could be done to prevent this problem in the future? That's actually the crux of one of the other things that we do in the security engineering course, right? So some people are going to be like, this stuff's all over the place. Well, I mean, we gotta learn the part that we learn, but then there's other things that can help us, right? Obviously. So that'll be admin 13, and then we'll make new post admin 13. And this one will be this one here then. Where's he at? Your team has been given more and more engineering responsibilities. You're being asked to build out the next set of servers to integrate into the development environment. Your team is going from RHEL 8 to Rocky 9.4. That does present an interesting challenge. How might you start to plan out your migration? What are you going to check on the existing systems to baseline your build? That's actually going to be the next lab we do, something that you can check. What kind of validation plan might you use for your new Rocky 4 systems? Go. Post. There we go. All right, so now those new discussions are there for people that want to start getting involved with, like anybody that's doing the course, you kind of have to try to follow along as best you can, but that's the kind of things that I make you guys do, because you might just say, that sounds like a bunch of busy work. No, this is for you. Like, if you're trying to figure out, like, hey, I already do Linux and I already feel like I understand Linux, the course is about how does Linux fit into the enterprise, right? How are the things that you're doing as a Linux admin working with the other components, right? And in this case, system hardening is something that we have to do. We have to keep our systems defended and protected, but we're always getting asked questions by security. It's not just, gone are the days where somebody just calls me up and says, hey, Scott, are all your Linux boxes secured? And I go, yeah, they're good. No. There's risk management. There's a lot of real money riding on things. So there's a lot of stuff that has to happen, a lot of risk tracking. There's tools that people use. We don't necessarily need to use all those tools, but what we do need to be able to do is describe and defend the things that we're doing in the environment. And there's things that we kind of focus on this week for that. This is not the purpose of what we're talking about right now. In fact, I'll probably get off here in the next half hour or so, because at 3 is when we run that course. So that course is starting up in the Discord in a few hours, right? Also, if anybody's new, welcome. All these different things. But yeah, that event is coming up in, I don't know, that's about 2.5 hours for me. A little over 2.5 hours. So then we'll talk through that stuff. There's always the recording for people. Like, so now you've got, if you come to the meeting, you've got that, and then you've also got the recording, and then you can also say, hey, I'll go through the whole course if I want. Course doesn't cost you anything, just costs your time, probably about 10 hours a week or so, but it's good for you. It'll show you Linux in the enterprise. That's what we wrote it for. Okay. Then if this is the last one I'm going to do, this is actually focused on this week anyways, so that'll be good. We'll look at some stuff around configurations. But let's get this one done. Maybe we'll look at it in context of the book, because I do want to verify how accurate the kind of system startup is with that. And yeah, I'll pull this up and show this to any of you guys that want it. Here's the lab for anybody that wants to do it with me. And yeah, let's get going here. So here is, you are a new system administrator at a company. That's common, right? That's kind of a theme through most of our stuff. And I say, then you've been tasked with the process of building out new servers. Fair. You would like to gather information about the current system and see how they started it up and what is currently running on them. You find yourself at a command prompt and need to find out how the system started, what processes are running, and how they were started, and what ports are exposed. So you're just gonna like basically take a notebook to the system and figure out what's going on. This is maybe just some vanilla server build that you have that doesn't have any app or web or database components to it, or even if it does, you're ignoring those and you're just looking at how the base system was built out, right? Hold on. Oh shoot. Okay, wife will be back around 3:30, and then go until 7:30, and then we're going to a farmer's market. Okay, I did tell her we were going to a farmer's market, so that's on me. All right, but that's not till later, so I got time. What kernel version and startup parameters were used to start the system? Very important if you've never done that before. What hardware does your system currently run on? Processor, NIC, virtualization, and use the solution if you do not know the correct answer. So we could sit around here and find a bunch of this, but I'm a big fan of, if you're new to this stuff, just drop down in here and figure it out, right? First, what version of the Linux are we on, and what kernel do we have? All right, we're on 2404. When I first built this lab, it was 2004, right? So we're on 2404. We're on a newer version. It's Ubuntu 2404.1 long-term support, so we see that. I come down here and we're on version 6.8 of the kernel. That is like, man, like, I feel like the kernel versions, and maybe I should go look this up because I'm pretty sure we can find all the release dates out there. I want to say like, I feel like 3, 4, and 5 released way faster than the first ones did. In that, like, they have jumped a lot of major versions even just recently. But that's something we can go look up when the releases were. But the point is, that's the version we're on. This is exactly the information that I would probably, if I was having a problem with the server, or me and the team had already worked on stuff as much as we could, and we were throwing up something to Canonical, which is the Ubuntu vendor, right? And we needed to get in there and actually look at maybe send in a trouble ticket or something. These are the pieces of information they would 100% want about the system that we were on. Then I want to know how this system was booted. I want to know when it was called by Grub, what were the things that were actually passed on the command line to this system. And in this case, here's the kernel that was called. Here's the exact boot image that was used. Here's the root operating system that was called as it started. If somebody has switched the root since then, I would like to know that, because maybe that informed some of the stuff that was configured. And then the console sessions. There's not really anything special going on right here. A lot of times we would expect maybe some other module parameters to be set here. Maybe we would have FIPS turned on for Federal Information Processing services, right? Like anything, or standard. I think it's standard for FIPS, right? It's the security though. Yeah, FIPS. Yeah, it's a security standard. But anyway, so we can go look at all this stuff right here, right? And then we drop down here, and we can also see that same information right here with dmessage. Dmessage will show us that command line, and it'll also show us everything that happened in the kernel as the kernel first started to work, right? So the kernel started to pop out to the screen, and or as the kernel started up, here's all of the information. So if I just add, as a real quick thing, I could grep any errors, see if there's any errors that happened. I could look for anything with the kernel, right? If there's any interesting kernel stuff that I wanted to know. It looks like kernel did a whole bunch of module loading, and maybe module loading is something that I want to limit in my environment. So maybe I streamline the way that this kernel loads modules, right? Maybe I go blacklist a bunch of modules so that they don't start up. And then after the system has come up and passed whatever check I want, maybe I manually load back certain modules only. Not, well, I say manually, but I mean my process does it after the system comes up. Because maybe I just want the system to come up fast and clean, and then with checks that we've written and our own things, then we load things back into the kernel module. Maybe that's the only way we found stability in whatever we're doing. Sometimes when you work with like high-speed systems, that's a truth. That's a thing that ends up coming up, right? But you know, again, however we got here, these are commands that we can start to use. I can look to see if we're on a virtualized system. We are in a virtualized environment. We kind of knew that already. If somebody's giving me access to a server, it's definitely a virtualized server nowadays, right? I can go look at DMID code and see that I am definitely on KubeVirt, right? Kube virtualization, and I can see that that is my within DMID code. That's the hardware that I'm on, right? And then we could dig more in with DMID code. We used to be able to see, and I am actually curious if I can see this. We used to be able to see what the underlying OS was, right? And you could start to dig in a lot. If you have root power on a system, yeah, we're still on RHEL 8.6 on the underside. So the box that is our virtual host is RHEL 8.6. Now, we're not attacking anything, right? We're just gathering information. We're not even reconnaissancing it for attack. But what I'm saying is we have a lot of information here about the system that we're on, right? And maybe I need to know that to be able to properly build out the next set of systems that are coming down, right? So where would you use this stuff? What's interesting over here? What version of the OS and kernel are you using? Well, we were using Ubuntu 24.04. And then what is the root volume of this system? Well, I saw that when we first booted, right? Here is the root label cloud image FS. That's our root right here. But where is that found, right? So if I cat etc fs tab, I see that label cloud image root fs is where the root is. But then I go, well, how do I find that? Maybe I cd to dev, and then I go device or disk by, and maybe I want label, right? And then in here, I do an ls, and I see there's that cloud img.rootfs, and I do an ls-l, and I see that that is actually pointing back to dev vda1. So now I know that dev vda1 is how it was mounted. Could I have gotten there other ways? Oh, absolutely. Block ID. Block ID should show us dev vda1 right here. There's his label, cloud image rootfs. So that would have been another thing that would have pointed us back there. And we would also have seen this. We also might have gotten away with lsblk. lsblk might have told us that dev vda1 was also mounted here, but it wouldn't have given us that cloud img rootfs piece. But there's a bunch of, so the thing is, it's almost like, again, especially if you come in and people have left the company that originally built this stuff, you may be picking up puzzle pieces off the floor to try to make sure that you have enough pieces for your puzzle. Yeah, you may be forensically doing this. Now, you say, well, Scott, hold on, this is a brand new build you're talking about. I'm going from rel 8 to rel 9. I can just wipe this and go clean. You can, but sometimes, especially in like a poorly documented environment, sometimes you don't even know what all the security standards are that you're going to be, hit on. So, somebody might not even be able to tell you if you're using CIS benchmarks or STIGs. They're like, well, I don't really remember anymore. Can't you figure it out? I guess I can. I can do anything, right? That's got to be, I don't want to say that has to be your attitude, but that's a good attitude to have in the Linux world, because first off, everybody already thinks you can figure out everything in the first place because you figured out how to do Linux. But, all right, what type of virtualization is this running? It's KubeVirt, we know that. What is the OS of the underlying host? That was rel 8.6. What kernel module do you see virt.io net using? So I might do lsmod and grep for like net. And do I see virt.io net? Oh, guys, these might be slightly different now that it's changed the version. But yeah, so virt.io.net, I don't even see that in there. Yeah, I don't even see that module anymore. Yeah, so that's probably been removed or deprecated or whatever, so it's gone now. Yeah, I can do anything for money. Actually, if somebody does an exclamation mark ask, you'll see what my little meme is. Some of you guys have seen it, but how long does it take the system get to graphical target? This is an interesting question. So when our system first boots up, one of my favorite commands in all the world is systemd analyze blame. So we did dmessage more and we saw information.
I can answer that for money.
All right, dmessage eth. We can see, oh, here's the virt.io net. So what kernel module do you see virt.io net using? And it is, should be virt.io 0. Yeah, there it is. So that is there still, right? And then this is one of my favorite commands coming up here. So we can see lsmod virt.io net. We don't see it in there, though, anymore. That's kind of interesting. We did see it when the system first came up, right? And maybe... No, we don't even see it in there anymore. But we definitely saw it when the system first came up. That's interesting. Maybe it got pulled out. We can use systemd analyze time to see how long the system took to get to a graphical target. So how long did it take the system to get to graphical target? That was right here. Graphical target reached after 10.709 seconds. That's interesting, right? And maybe we don't want to go to graphical target, so we don't care about that. Our server shouldn't be going to graphical target anyways. That's run level 5. That's a little bit much, right? We don't need that. We want run level 3 for servers, typically. What's the longest to complete when you did your system? This is one of my favorite commands ever. Systemd analyze blame. This is just funny. It's a funny command. But we're going to run analyze blame. And we're going to go to the bottom here. And at the top, these are in the one that took the longest time. So what took the longest time to come up? 3.880 seconds is container D. Now this is not in, these are not in chronological order, and they are not serial. And you say, Scott, how do you know they're not serial? You're eating cereal? No. I mean serial one after another. And when you look at it and you say, wait, hold on a second. It took to finish, start up finish total was 15 seconds, right? And if these are not in order, but also 3, 3, 3, that's 10 seconds there with the extra. So that's 10 seconds. That's 15 seconds there. That's 17. That's 19. That's 21. That's 23. That's 24, 25-ish, 26, 27. Right? Like, obviously, these aren't happening independent of. If they were serial, this would have been a much longer startup. But the point still stands that while none of these are along what we would call a critical path, they're not the ones that are holding the door open before the next one can get in. They are still maybe these 5 or 6 things shouldn't be happening on my system. And that would, by getting rid of these, theoretically move this down, even if they weren't directly related to the longest critical chain. I'm going to show you guys a critical chain here in a second, and we could determine what took the longest to come up. But what right here, I love systemd analyze blame. It's just like one of my favorite commands, just the name of it. It's like, I'm blaming you for this bullshit, right? All right, so anyways, so systemd analyze blame. And then we can check if a service is running. So, whoops. Is SSH running? Yes, we see that. There's many other ways to check if a service is running, but this is one of them. And then we come down here and we say, if it's running, is it set to run on startup? Yes, we see that with, you know what, this is weird. Super weird. We're going to make this smaller, and then we're going to rerun that. And yeah, we see that it is super annoying. No pager. We see that it is set to. It's disabled. This is not set to come up when the system comes back up. This is disabled. So that's kind of an interesting setup for SSH on this server. It must have been started by some other means, right? That's an important thing to kind of know. So then we come down here and we see, is it enabled? We could do that as well. And again, SSH for some reason is disabled on this server. It's started up by some other process. That's an interesting behavior. We can look at one of my other favorite commands here. Let's clear the screen up. We can SSH cat SSH service. So systemctl cat will tell us this is where the service was started from. User lib systemd system ssh.service. And here are the arguments and options and other things that came into play as this service came up. This is tremendously useful if you've got a running service that you're like, I don't know where that came from. I didn't install that on this fucking box. I don't know. Like, but I know that somebody did it, and I know that systemd found it when it came up, and I know it's set to turn on, and I know all these things, but I don't know where it's being configured from. Systemctl cat will always show you where a service came from. That's useful. Okay. This is one of my favorite ones. Systemd analyze critical chain. So systemd analyze critical chain will take all of the things that had to happen for SSH to start on this box, ssh.service. We had to start down here, add a disk coming up, and then we had systemd fsck if we needed it. Boot EFI, we had to get our local file system up. And moving up and to the left, all of these things had to start correctly before ssh.service started. So if I were to come to this server, systemctl status failed, and I were to have failed units loaded, and there were things like SSH that were supposed to start, which in our case it's not supposed to, but it was supposed to start, and it didn't, and I went and I found it in the failed, then I can go look at its critical chain and say, well, it makes a lot of sense to me. SSH didn't start when that LXD installer that's 4 down didn't start either. So my troubleshooting would not start up here, guys. Why would I troubleshoot SSH? We were talking about this the other day, or earlier today, actually. Somebody asked about, they were trying to get something to update, and we were like, well, can you ping it? Can you do this? Because if you can't even get these other things to work, there's no reason to talk about this. Like, if your system can't map back to like where Kali updates from, let's just say it couldn't, then there's no reason to talk about the apt upgrade. Because the apt update and the apt upgrade, those processes are not going to start until that name resolution happens. In his case, he said the name resolution was happening, so then we split off our forking of what we were talking about and what we would check, right? Same thing here. Why would I be trying to fix this service if something in its critical path was dead? It would be like if, If the whole, I go to a hotel and I put in a wake up call, so the person's like, yeah, we'll call you at 6 a.m. This was a thing that we used to do, right? And then I wake up in the morning and that whole half of the hotel has been like taken out by Godzilla. And then I'm like, well, why didn't this fucking guy call me? Well, it's pretty clear why the guy didn't call you. He's dead. He's over there in a footprint, right? But all right, anyways. All right, that's my attempt at humor, but I think that's funny. But anyways, the point is, yeah, we look where we look. We don't go up here and spend 2 hours up here mulling about like why SSH and go and looking for SSH to fail. We can find where things might have failed by using these different tools. So we keep going down. We're looking at stuff. Maybe we look at all the system files that are in here, and we see which ones are enabled. How are they enabled? Were they just enabled? Are they masked? So masked things, so the apt daily upgrade and apt daily service, we don't want those. So those are masked. Masked services cannot start in our system. Even if I tried to start that service, I would not be able to right now because it's masked. But could I go see where it's at? Systemctl cat, that guy? It says it's masked. I can't even cat it. You guys see that? Oops, hold on. I want my camera back on, but I want that thing off. I didn't mean to turn that on. All right, so we can see that it's masked, so I can't even get into it, right? Do we want to count up what's all here? We can go see that there are 123 that are enabled in some type of way, either by the vendor or before usage by the system. Now the system may have it disabled, but the vendor originally wanted it enabled. That's what the right one is there. We can look for, here's all of the states of all of our nodes, or all of our services. So, got 27 disabled, 78 enabled, 11 masked. We could look for just the masked ones if we want. Again, masked ones can't start. Game of cat and mouse, yeah. All right. So then we can look for specific packages, which we did this in another lab, but I want to see maybe versions and make sure that I have versions that are above the versioning problems of other things and things that have been found with common vulnerabilities and exposures. I showed you guys semantic versioning. You need to understand your semantic versioning. This is important. This is a thing that we just need to know as engineers. Is SSH service set to start in our server? In our server, it's not anymore, and I'm not sure why. But how many services are set to enabled? I think that was 123, right? We have that. And then I have a little bit more about reading more here. And this is inside of the Rocky Linux about how systemd works, right? So I talk about systemd and breaking that all down in the system. All right. Anyways, let's get that out of there. That was that whole chapter. And then we look up maybe SSH, and then we can see where configuration for SSH happens in our system. I think this is all valuable stuff to kind of understand. All right, so now we're going to look at what system ports are open and what software is running on each of them. And so we may run ss-ntulp real quick, and this will just dump a lot of stuff out to our screen. Let me move this over a little bit. We can compress that down a little bit. It'll be safe. I can even probably move this over a little bit. And let's put that up and look at that again. So if we do an ss-ntulp, here's a bunch of UDP ports here. Here's a bunch of TCP ports here. And they're either listening or unconnected. We can start to count them up. That's what this actually does, is it counts up that there's 5 UDP things that are listening and 8 TCP processes or ports that are being opened and listened to here. And now we can go start to dig into what they are. So I don't know what this 53 is, right? I don't like this 53 being open. I don't know what it is. And I say, okay, well, I'm going to go look at that open port and see what's touching that open port. So LSOF-I port 53 right here. And here's the systemd-R, which I think is becomes systemd resolve. Yeah, that's the user even. And what is holding open? So local 127.00.53, we're listening on the domain for whatever we're listening for, right? That should be some type of DNS traffic locally, right? So then maybe I wanted to find out how it was started. So I might look at systemctl and grep for, right here, systemctl and grep for resolve. So I see the systemd resolve d service. I don't know what the heck that is. So then I come down here and I see how it's started. This was that cat command we did from earlier, and I see that okay, I can go find more information about it and read about it a little bit. But it looks like, at least from this description, it's doing network name resolution locally on my system. And here's a whole bunch of information. Look at all these things that it's doing. And these are all tunable, right? Do I want protect home on? Yes, probably. But maybe I go read about it and I go, oh, no, I don't like what that's doing. So I go and turn it off. These things are here. Now, it's in user lib systemd systemd resolved.service. So because it's not in Etsy, anything that you change in this file is likely to not stay persistent. It's not going to stay persistent. I like that hat. It doesn't stay persistent through a reboot, or not a reboot, a reinstall. So if something ever updates this service, everything in user lib systemd is fair game to get rebooted or reset back to whatever the system is, right? So this is things that we can go figure out about the system. So maybe somebody modified this or changed this, and I need to go grab that and make that into my considerations going forward in my environment, right? These kind of things. All right. So look at you learning Linux. You've done the system setup. You've looked at systemd daemon for how processes are configured. You've looked at running software on open ports. This will help you decide what you need to move forward with on your new server builds. What processes do you need to keep running, and what software do you want to allow are to still be determined, but you have the tools to see what's currently happening in your environment. So you have so many things like at your command, so many tools, and there's so many things that those tools can help you figure out, but maybe you need to figure out what those questions are. Maybe you need to spend some time with the environment that's there so that you're more informed when somebody asks you like, well, do we even need that systemd resolve service anymore? Why do we have these 8 TCP ports open, but we only have 5 UDP? That doesn't sound right to me. And you look at them and go, oh God, like how did you get to be the security person here, right? Because you obviously don't know any Linux, but by the way, that's gonna be your whole career, guys. So just get used to that. I'm not talking trash about security, guys. I'm just saying there is a time to, but that's not now. I'm saying that there are people that are going to be doing stuff in your systems, and they're going to have a say, and they literally don't even know what like a kernel is. And so you're going to have to be the one to like guide them back to the beaten path of like, no, it's not some blogger on LinkedIn that determines how our company fucking does this stuff. It's the people that have actually been running it and know how it works, right? So you're going to see that stuff. Hayes said, why are these ports open? Why do I have these leeches on my chest? Yeah. Maybe the server just needs to be bled a little more. You just need to bleed the server a little bit more, and that'll be Colonel Sanders, yeah. Too many chefs. Yeah, one of our guys used to always sing Too Many Chefs when we'd be working on stuff. All right. So, guys, here's what we're going to do. I'm going to take a little bit of break because I'm going to be talking with you guys down in the Discord in about an hour and 20 minutes, or 2 hours. It's about 2 hours from now. We're going to be hanging out down in the Discord doing unit. We're going to be right here, guys. We're going to be doing unit 13 of this course. So we are going to be doing system hardening, right? That's going to be the stuff that we're doing. If anybody wants to, if you want to join the course, it's a little late. You probably won't get everything done, but you could do it. The courses are free. They're in the Discord. You guys can go hop in there and mess with them and stuff. And again, our goal as a group is to get you guys into doing this stuff professionally. We're getting you guys going and working them servers out, getting them. yeah, we want to harden those servers up. All right. So here's what I'm going to do. I'm going to go hop to my little end of stream thing. I appreciate you guys all coming. On the Twitch side, we'll go find somebody to raid. But on the YouTube side, I will see you guys later. And Twitch side, hold on a